So we'll have a 1 minute delay, but so now everybody is probably watching us, staring silently off into the distance, but welcome to NormConf, everyone.
Welcome to NormConf.
Very excited. Yes.
Cheers. Hope you all got your coffee. If you're, time zone dependent, since this is a global event, apparently, although there's never the wrong time for coffees. Cheers.
This is true. Coffee. We have also, if you're playing NormConf bingo, you now get a free card or a free spot because we talked about time zones and time zones being hard. So good morning, welcome, enjoy your free bingo spot. So
I didn't know there was NormConf bingo. What are some of the slots today?
It is okay. So
or am I spoiling it by asking? I get it.
No, I don't think you're spoiling it by asking because I did not have this scheduled to talk about. But if you go to, we have two great places for resources. So one is normconf.com. The other is the GitHub repo, github.com/normconf. And if you scroll down, you will see a Streamlit app with a bingo card generator. So it was like, time zones are hard. There were some free spaces. Pitching your Substack or your newsletter is also in there. Those were the ones that, data is the new oil. So, all of the classics. I didn't see one for data science is the sexiest job of the 21st century, but that's fine. So lots of good stuff. So how are you doing this morning? I think we're just kind of hanging out until we get started.
I'm feeling good. I'm excited. It's gonna be a good day. We're gonna be airing our collective dirty laundry about the way that you really get things done in this industry, and I'm excited for that. I think that's gonna be a really good day.
Yeah, and I think it's important to do as well because I think in data it's even though we do share our code and so many things are open and we talk about our mistakes, it's still really easy as a data scientist or MLE or whatnot to look at things that other people create and be like, oh gosh, I'm doing it all wrong. I'm never going to be that good. Or how do I get to that level? So yeah, I'm very, very excited for all the things we get to talk about today.
Yeah, there's so many of the folks that are talking today that are the folks I've been looking up to for a long, long time. And to be able to hear their stories about how they just have to tear through it the same way we all do is, it's been really, really exciting. And it's going to bring us all down to the level. And I appreciate that. I think it's going to be wonderful.
Okay, but also thinking about this group of people, in addition to being brilliant at what they do, so many of them, if not all of them, are funny. And I feel like these are some unfair advantages, right? Like you put all of your points in one talent tree and it was data science, but no, they were like, I'm going to be great at data science and I'm going to be funny. So
pretty soon we're going to have Dungeons and Dragons character sheets for data science people. Data science bards. There's going to be a lot of data science bards on the NormConf schedule today.
This is where I have to admit that I've played one-shot game. And so my knowledge of Dungeons and Dragons is pretty limited. So you're going to have to fill me in here. Like what is a bard? Why are data scientists bards?
I think the charm that we're getting from some of these folks, that's pure bard. And the musicality of talking about data science that we're going to be hearing, that's pure bard. I think that's why we're stacked with bards in the NormConf adventure party.
That's true. We do have a lot of charm, a lot of great speakers, a lot of good talks, so many good things happening today. So we are coming close to time. Is there a talk in particular that you're looking? I mean, I know they're all great, but is there one that you're like, that one?
Oh boy. Tim's this morning about 5 semesters of linear algebra and all. That rings true to me. All the linear algebra that we studied, and then the nitty gritty of how we're actually getting things done. I want to unpack that. I'm looking forward to that.
Yeah, I mean, I still, whenever someone puts something out there and says all beginner data scientists should use Python, I always think of Vicky's post that getting started with Python is still hard. And remember my early days of trying to install Python on a machine. I mean, I still mess it up. It's fine. Every new computer is a new chance to mess up your Python installation. So
every new Python project is a chance for a carte blanche. Just delete all, find Python, delete purge from the machine, start over fresh.
Just start over.
New beginnings.
Start over. Yeah, absolutely. Well, yeah, so that's going to be a great talk. I'm also really looking forward to, we have Helena Sarin in our talk today. So I'm very excited to see some incredible art. I mean, we do have it all. We have art, we have data, we have lines crossing between all of them. And we, I think, are getting ready to kick it off. So this is the official welcome to NormConf. Wait, I'm in charge of slides, James, so I'm going to have you kick it off here. What are we doing here? Yeah.
Welcome to NormConf, everybody. It's December 15th. It's NormConf. It's finally here, and we're going to be opening things up now. Just a minute. So, what is NormConf? You might be asking. NormConf itself was inspired by a tweet. It was Vicky Boykis, whom you all know and who will be speaking with us in just a couple minutes. She captured what I think a lot of us were feeling about the ritz and prestige of some of these machine learning conferences, and how we all wanted to sort of come to meet and talk about this more middlebrow topics about the way that our industry works and the way that our jobs go. And then the tweet snowballed into what we have today, which is tons of fantastic speakers, tons and tons of people coming together to discuss the way that we really get things done in our industry. And that's NormConf.
Yeah, NormConf. So
NormConf.
Over 20 incredible speakers and talks every half hour. And we are split up over 3 YouTube streams. You can follow all of that on normconf.com. Who are you?
I'm James Kirk. I'm the founder at Meru, and also spent the bulk of my career at Spotify working on recommenders, and I'm a machine learning and recommender guy at heart. And I'm just excited to see all the other flavors of data science and machine learning that we're getting today. What about you, Jessie?
I'm Jessie Mosbeck. I am a developer advocate at Base 10 and an animation student at Night. So just kind of doing all the things. Most of my data science work has been as leading data science teams, working at small nonprofits, startups before I moved into developer relations. And now I do a lot of talking and video editing and lots of fun stuff related to data science. So before we kick things off, I do want to give a quick shout out to Prefect. So we do appreciate your support in helping make this conference a reality. If you want to learn more about data orchestration, please feel free to stop by their booth in the Slack group. So without further ado, James, will you introduce the one and only reason we are here?
The reason we are here, our principal Docker file architect, who in our heart, the Docker file of our hearts, Vicky Boykis. She's our keynote speaker today and the reason that we are here. Welcome, Vicky.
Vicky.
Hey, can everybody see me and hear me?
Yes.
And see my curtain?
This is amazing.
I love it.
Okay. So it already kind of fell down, which is great because I scotch taped it up. Hey, everybody, welcome. So I guess I have to do this keynote now, huh?
You're up, yeah. I mean,
all right.
This is your thing. You can do what you want, honestly.
I could put my curtain back up, but I won't. Okay. Hey, everybody. Welcome to NormConf. Good morning, good afternoon, good evening. I am going to start off. So it's very appropriate that James and Jessie were talking about bards, because what I want to do is I actually want to tell you a machine learning fairy tale. Once upon a time, in the kingdom of all users contained in a matrix of m by n in the real number space, there lived a girl named Vectorella who was a machine learning engineer. And Vectorella was pretty happy. She was doing her machine learning stuff. She worked for a company that made Nutella, which, as everybody knows, is everybody's favorite spread for hypothesis testing fans. And as a company that made Nutella, this company shipped it far and wide across all places, both in the user matrix space and in the real world across hundreds and hundreds of countries. Now, as such, they had a lot of business transactions and a lot of data to deal with. So Vectorella had to handle a bunch of different stuff as a machine learning engineer. She had to handle API errors, time zone issues, import errors, K8s. And she was generally pretty okay with this, but she wanted a lot more. And what Vectorella saw whenever she went to her work Slack was past the airflow alerts, past the memes, past the Spark issues, there was a private channel that she could see that was called Staff MLEs. And all Vectorella wanted to do was to get into that Staff MLE channel with all of her heart. She was doing her day-to-day stuff, but she thought they were doing more in there. She thought they might have been doing Stable Diffusion or ChatGPT. And all she wanted to do was do that cool stuff instead of the stuff that she did on a day-to-day basis. One day, a miracle happened. Her very cool boss sent her a text message and said, "Hey, I think you've been doing a lot of this great work, and it's time for you to join this channel." And Vectorella said, "This is amazing. I would love to join this channel." But then a misfortune befell Vectorella. She went through a reorg. And so what happened was the cool boss she used to have was replaced by an evil boss and 2-step PMs. So now, not only did she have different work, but she had 3 people managing her work. And so she was further away from that Staff MLE channel than she ever thought possible. And she said, can I please go to this channel, to her new evil step PMs and step manager? And they said, "No, we have a lot of work for you to do. You have to do these 3 tasks. If you do these 3 tasks, maybe we will let you in the channel. Maybe. We'll have to see how well you do them." And so Vectorella thought, okay, I guess I've already been doing a lot of this work, but I really want to see what they're discussing in there. So she put on her hat and got to work. The first task that they gave her was to count sales. So Nutella comes in all sorts of varieties: large jars, medium jars, small jars. And in order to increase revenue, they also branched out into gelato and biscuits. Vectorella's job was to count all of these. Don't forget, it shipped both in the multidimensional vector space and in the real world. So there were sales across many, many countries. So she had sales for the US, Morocco, and Japan, and lots of other places. So she said, okay, I guess I'll do this. So she took all the orders that were placed in the United States. So there were biscuits, medium, small, large jars, etc. She had an enormous list. And she took that from the transaction logs and put that into a list. Then she said, okay, I guess I'll count these. So for every item in the orders, she added it to a default dict, and then she incremented the counter for everyone in the US until she had all her items added up all together. She wasn't done though yet, because there are a lot of other countries that had these sales. So she also had to do the same thing for Japan, Morocco, China, France, Italy, and others. At this point, Vectorella was getting really bored, but she really wanted to be in that channel. So then she said, okay, well, now I guess I have to add all of these countries together. So then she incremented a counter. She took all her global orders and she added and incremented those orders as well, so that she had a global count of everything all together. And she said, okay, I guess this is it. I did this. This is so boring. And then she went to her evil step boss and step PMs and said, is this getting me closer to getting into that Slack channel? And they said, sure, but we have a second task for you. Now you have to turn words and millions of recipes into numbers. And Vectorella said, why? Why do I have to do this? This is going to be so boring. And they said, just do it. Don't ask questions. So she said, okay. And she went to see that the recipes that Nutella had illegally scraped from the internet to do work with. She wasn't sure about that part. But she did look at these recipes, and they had things like a list of ingredients, a list of steps, a list of things that went together to make things out of Nutella. So for example, this is a Nutella cake. And there were millions of these. And she said, okay, well, how am I going to turn these into numbers? So what she did was first, she turned it into code and she created a big long string for each recipe. Then she said, okay, what am I going to do next? I guess I have to clean this data so I can somehow process these strings. And so Vectorella did what she did best, which was just clean a lot of data. So she had to lowercase all the stuff. She had to take out the contractions. She had to remove all the symbols, strip all the spaces. This is so boring. I bet they're doing stable diffusion in there, she thought as she was writing all this cleaning data. So then she had her cleaned words, and then she thought, okay, what am I going to do next? Then she ended up mapping each word in the cleaned list to an integer, to a sequential integer. And she said, okay, this is kind of something, but this is not really what they were asking for, I think. And so then what she did next was to actually encode the words. And so what she did was she took the dictionary, and for each word in the dictionary, she assigned it to a vector of zeros. And then everywhere in the vector where the word actually was, she replaced it with a 1. And then what she ended up having was a set of one-hot encodings. And she said, okay, I guess this is something. What is this? Why am I doing this? I could be posting memes in that channel right now. People would be liking it, appreciating it. Instead of making dictionaries. Vectorella was tired and angry. So she went to her step PMs and her step manager and said, look, I've created this. I've processed them, I've mapped my vocab, and I've encoded them so that I actually have vectors for each word. Is this something? Can I go now? And they said, no, you have one more task. Since you did these other 2 tasks, and they were reasonably okay, we'll see if we let you in the channel after that. Now you have to schedule these to run every day on a daily basis because we sell Nutella every day, and we also need to process it every day. And Vectorella said, oh, I just want to be in that room. So what she did was she rolled up her sleeves again, and she created a cron tab script that ran every day, and that did a couple of things. First, it took all the code that she had run on her local machine, and it synced it to a remote Linux server, because Nutella only has one remote Linux server. It's a very normcore company. And then what that script does is at the same time every day, it runs that sales script and that numbers script. And she said, okay, I'm done. I cleaned everything. And she said, please, please, can I be in that channel? And they said, okay, fine, you win. So the fairy SRE came along and gave her all the correct admin access and unlocked the staff MLE channel. And that's when Vectorella became staff MLE Vectorella vectors. But when she got to the channel, she noticed something weird. She noticed that these staff MLEs were asking interesting questions. So the first one asked, hey, how do I run a distributed Spark job on 1 million Parquet files in an S3 bucket to get the total counts of receipts for my sales forecast model? And Vectorella thought, curious. She thought, what do I know about Spark? What is Spark? So Spark is a way to do computation through data parallelism and fault tolerance across multiple commodity machines. What does that mean in English? It means that you can take a program that computes the frequencies or sums of all words or items in your sales catalog occurring in a set of text files and prints or outputs the most common ones. So what Vectorella realized was that the Spark diagram on the left was actually what she had been doing in adding sales per country and then aggregating them across the world this entire time. Vectorella was shocked and scandalized, but there was more in store for Vectorella. Second, in that super secret Staff Emily Slack channel, she did not see people multiplying matrices or working on stable diffusion. What she did see, well, she kind of did, but not really, not for the sake of the narrative. What she did see was this super Staff Emily number 2 that said, I'm trying to create a set of embeddings projected into a lower dimension space to predict which ingredients I can cluster with Nutella for optimal combinations to show my customers. What does this mean? It means you have millions of recipes and you have one Nutella. And you want people to select ingredients that they can cluster together to suggest what they can make with Nutella. So for example, on the right-hand side, if you have lemon, peppermint, and cream, and they commonly cluster together, you can suggest that they make Nutella cookies. If you have vanilla, butter, and chocolate, you can suggest that they make a Nutella cake, which requires buying 4 to 5 jars of Nutella. Buy Nutella, stock goes up. If you have, for some reason, banana and pizza dough and crepe, I'm sorry about this one, you can make something in the category of sandwiches, potentially, or flatbreads, or something similar that you can sell Nutella to. But for that, you need to generate embeddings out of text. And Vectorella thought, well, what is an embedding? Embeddings are just a way to compress highly dimensional data, such as text or images, into a smaller dimensional space by assigning each data point to a vector and comparing the similarity of those vectors to each other. So she thought, okay, well, what is this? This sounds familiar too. What was she doing? She was just creating vectors too. And in fact, if you go to the wonderful PyTorch documentation, it'll tell you that the one-hot vectors that we created, which are sparse, because they only have data points at certain points, are actually a special case of dense word embeddings, which we use for deep learning and stable diffusion. Finally, a third super staff machine learning engineer was asking a different question. Vectorella was puzzled. She thought this channel was going to be super high-level discussions, theory, etc. But what they asked is, can someone validate my Airflow job to update my machine learning retraining pipeline? And Vectorella thought, what is Airflow? She remembered that Airflow is a programmatic way to create, monitor, and deploy batch workflows on a scheduled basis. She thought, what does this sound like? This sounds like something that I've done before. It sounds like fancy cron tab. So Airflow is basically fancy cron tab. It's a way to schedule a lot of different complicated tasks, like, for example, your Python scripts or your model runs. So it turned out that Vectorella had been doing this also kind of all along. What is the moral of the story? Basically, in the data science, machine learning, and general data space, we are all Vectorella today. Why? Because the advertised map for what we do at work is not the true territory. The interviews that we go through, the Medium articles that we read, the Hacker News articles that we read, all of this work, not all of it is encompassed by what we do on a day-to-day basis, which is cron tab and creating dictionaries and adding things to lists. This is the heart of the true work of machine learning. Second, what Vectorella realized is that building machine learning systems is just building software, and building software is fragile. It has lots of different components. It has lots of things that break. It's not glamorous. It's not sexy. It's real true work that you need to do to get your stuff to work. And that's what she had been doing when she started working on this. Third, even advanced work deals with normal problems. So this is actually a screenshot for when I tried to register for ChatGPT on the first day it came out. And potentially they were having problems serving web requests, which has nothing to do with the really complicated and impressive model that was happening in the back end, which goes to my last point, which is that data work is also engineering work. And we deal with a lot of the complexities and fiddling with all the pieces that entails. And finally, something that Vectorella realized was that the solid fundamentals that she had been working all along that seemed very boring to her and not related to what she had read about in the media were actually the fundamentals. And if she learned those very well, then she could do and be present for the advanced work as well. And I think that's something that we can all take to heart. So what Vectorella realized is that she now lived enlightened ever after, still also in the staff MLE room because the fairy SRE had forgotten to rotate her credentials. And so something we can all take away is ad astra per aspera. This is kind of like my personal motto. It means the stars through difficulty. We're all going to deal with this stuff. We're all going to have this happening. And it's up to us to embrace it. So thank you. I want to say a couple of thank yous before I go. That was my talk. First of all, enormous thank you to all the NormConf organizers, Gania, Ben, Jeremy, and Roy. The amount of late nights, the amount of time spent, the love and effort put into this conference is amazing. I hope everyone sees it and enjoys it. We had so much fun planning it. And we hope you all love it too. Thank you to the MCs and moderators. Again, these people are, to my knowledge, not being paid for any of this. Everybody is doing it for fun and for love. And I'm excited to share this with you. Thank you to the speakers who I also volunteered to speak. I'm excited to hear what you're going to talk about. Thank you to our sponsors. If you are in Slack, you can come visit their booths, and they're all on our website. Thank you to our lightning speakers who led the way for the pregame to the conference and who had some amazing talks. Thank you to NumFocus, who make the tools that we use and who we're donating the optional donations of the conference to. And finally, thank you to you. This event would be nothing without the spirit of the data community, with everyone that works on this stuff, that contributes to it, and that builds on it every day. Welcome to NormConf.
Yeah, there's lots of clapping going on. We don't want to blow out the microphones. Wait, Vicky, come back. We have questions for you.
There's
You have
vuvuzelas
questions?
blaring in celebration somewhere.
I'm done.
All right.
God.
I thought you were going to kick me off. I was going to go fix my shower curtain.
No, we're going to subject you to at least
I don't
4
have
minutes
time.
of questions.
All right, let's do it.
I have one for you, Vicky. Why don't more promotion packages in our field come with headwear? Really seems like a missed opportunity for, if all we get our Slack channels to signal success like that, why don't we get headwear?
I think this would be a marketing opportunity for the Nutella Corporation. They could definitely, if nobody else does it first, they could definitely do this first. Nutella sales are lagging. I'm not sure why. Probably people don't want to buy a spread that's associated with zeros. Who knows? But yeah, they should definitely get on this. I'll make a note and let them know afterwards.
$1 million opportunity.
Yeah, for sure. So from the audience, the real question here is Vectorella spoken from experience?
No, completely fictional, has nothing to do with anything. Yeah. I would say she's like an amalgamation of the experience that I've had as a machine learning engineer, of the experiences that I've talked to my friends about that they've had, of stuff that I've read online. I think part of it is that, like, when you talk to people in person, over Nutella, they're going to tell you something, and then when you read about it on Hacker News, it's completely different. And I wanted to reflect what that something, like the core of that, really is. And that's kind of what my talk and this conference is about.
Yeah, absolutely. I think a really good follow-up to that is a question we have. So what is the inspiration for framing your keynote as a fairy tale?
I have 2 small children, so I do a lot of reading of stories and other things that are read to small children.
That's fair.
Feels like communicating with the small children and communicating with staff ML engineers, like, it's not all that different, if we're being honest.
It's a skill that a Bard level person, staff Bard level person would have.
I feel like I need to start playing Dungeons and Dragons so I can be a part of these conversations.
I don't know anything about it other than the fact that James said Bard before the talk. So I was like, okay, I should write this down and inject it at various points.
Yeah, absolutely. So I actually have a question, and I think it's the most important question of the conference. What is your favorite Nutella combination?
Okay, so this is gonna be very complicated. So what you do is you take a jar. So there's actually two different kinds of Nutella, at least. There is American Nutella and there's European Nutella. And European Nutella comes in glass jars. And if you can find it, so I find it in my local Eastern European grocery store. If you can find that Nutella, that's better. It's just better. And then what you do is you open the jar and you take a spoon and you just start eating it. But you have to limit yourself. You have to say, I promise I'm only going to eat 5 spoonfuls. And then you look at like the calories per spoonful and then you cry a little bit and then you eat like 3 more spoons.
This is perfect. This is everything I've ever wanted to know about Nutella.
That was my second MBA.
Well worth it too. This is just putting real knowledge out into the world.
A question from the room for you. Did Vectorella get a raise after getting into the Staff MLE channel?
No, sadly, no. Because like I said, Nutella was not doing so great as a company. They did give her an extra large jar with a bow on it.
I feel like that's about all you can ask for. So maybe, I'm not sure, you and I not being D&D players, what this may or may not make sense. What is the alignment of Vectorella? Is it lawful good?
Okay, what are all the alignments? There's like
there's like 9. It's a 3x3 grid. It's a matrix.
There's like chaotic neutral. There's evil, neutral, and good. Lawful. Yes. I just know this from memes. I don't actually know this.
Yeah, same. There's lawful, chaotic, and neutral, right? And then they all sync somehow.
So chaotic good is how I would describe her aspirationally.
Okay.
I think.
So if someone, go ahead, James. I'll let you take the next one.
Yeah, another question from the room. Do other staff MLEs make things complex because they need to attract talent, but also justify their jobs?
I would know. I'm not in the staff MLE channel. The real answer is, I think there's definitely some of this going on in the industry where we like obfuscate things for the sake of obfuscation. But hopefully NormConf will push back against that. That's my hope.
Absolutely. Well, Vicky, your talk was amazing. It's so great getting to chat with you. Everyone has done such a great job pulling this together. Is there anything you want to share before we get chatting about our next speaker? Any parting words of wisdom?
No, have an awesome conference. I have no more parting words other than my talk. Have an awesome conference. Do normcore work, share normcore work, be excellent to each other. Thank you so much to Jesse and James for taking the very, very early session on this one. Can't wait to hear the rest of the speakers. Can't wait to hear the rest of them.
Awesome. Thank you so much.
Thank you.
Thank you, Vicky.
Bye.
All right, James, are you ready?
Oh, I'm ready.
About our next speaker.
I've actually got a ball pit just so I can feel like I'm Vincent. It's just, you don't realize that I'm standing in a ball pit right now just to get in the mood.
That would be amazing. I feel like we should have put that in our MC request budget for the conference.
Some people have those walking treadmills under their desks. No.
Mm-hmm. Yeah, it's all about the ball pit.
Future.
Yeah. So Vincent is known for several things. I think about Vincent in terms of Calm Code, which you can go to. It's calmcode.io. Great way to do some very calm, anxiety-free coding. Fantastic set of videos, tutorials, information comes out through a newsletter. But James, are you familiar with the Pokemon story?
The Pokemon story? I'm not.
You don't know the Pokemon story?
I don't know the Pokemon story. What's the Pokemon story?
Okay, so my first introduction to Vincent was he has a talk where, oh gosh, now I'm going to bungle the joke. So he's got a list of all the technologies in data science and tech, and then he sprinkles in Pokemon names. And so he said that when recruiters would reach out, he would ask them to tell him which ones were the Pokemon and which ones were the tech software?
Writing Python for 10 years, I'm not so sure I would get those right, if I'm being honest.
Yeah, it's harder than you think, right? Because we come up with all these fanciful, fun names for things in tech. Pokemon have fanciful, fun names. Is a Hadoop, is that a Pokemon, or is that a piece of technology?
With the rate at which the Python packages and also the Pokemon universe, if I understand correctly, are growing, at this point, I think they probably overlap a lot more than you're giving it credit for.
Yes, yeah, definitely some overlap. So with that, I am very excited to kick it off to our second speaker of NormConf, Vincent, who is a machine learning engineer who enjoys coding calmly, to talk to us about group by statements that save the day. Welcome, Vincent.
Welcome, Vincent.
Hi there. So like one little anecdote about the Pokemon thing.
Yeah.
At some point, that joke meme thing became so popular on LinkedIn, recruiters started adding me. And also I keynoted a tech recruitment event because apparently all recruiters have seen that meme twice. Ask me for details in Slack later. Like, that was a fairly hilarious event. But it's not what I'm here to talk about. I'm here to talk about something else. What I'm here to talk about is group by statements that will save the day, which I thought was going to be an interesting topic. So what I would like to do is explain what this talk is about, but I also want to explain who the talk is for, because in my mind, there are people like Alice and Bob and Vectorella that are interested in maybe getting started in this field of stuff with data. It's a very attractive field. Maybe Alice and Bob are recent graduates. Maybe they're just interested in a career transition. But it's been a while since I was a beginner, so I was thinking, what is it like to maybe start out now? And then you give it a Google, and then you read stuff like, hey, data drives everything, and you need to get the skills you need for the future of work. And there are these listicles of like 10 essential skills for data scientists. And if you really try hard, I mean, you will even find like the best data science certificate programs from a boot camp that I will not name here. But people are very eager to take your money so they can give you a certificate. And that kind of brings me to the topic of this talk, because what I want to talk about in this talk is two stories of two data sets. These two data sets are properly beautiful because they both tell a story. But the reason why they're beautiful is also because it's a story that I think Alice and Bob and Vectorella really need to hear. It is a story to help remind everyone of the human aspect of this data work that we're doing. And hopefully it's also a story that might help remove some anxiety against this whole must-have skills phenomenon that I'm becoming increasingly frustrated with on the internet. So with that out of the way, let's talk about a beautiful data set. The first data set I want to talk about is called chickweight. Chickweight comes with the language R. So if you install R, you can call this variable chickweight, and you actually get this data set. It comes with the language. It's a neat feature. And this data set has a couple of columns. So one column is chick, the other one's time, the other one's weight. And the idea here is that the chicken number 1 at time step 0 had a certain weight. And as time moves on, the weight also increases. But this chicken also had a diet. This chicken got a specific kind of food. And different chickens might have different kinds of food, but you can imagine that there's kind of a use case here where, it's kind of like an A/B test. We're trying to figure out which diet is best for the chickens to get them to grow. And, if you're the good data scientist person that you're supposed to be, you do some exploratory work. So you make a chart and you kind of get this. On the x-axis, you've got time. On the y-axis here, you've got weight. And you can see that, there's this general pattern in the middle over here. You can definitely see like the average is, going up. But you can also see that there's a bit of variance. There's actually quite a bit of spread here. And that is something that you can totally see. But then you can do the clever group by. And what you then notice is that when you group by the time as well as the diet, you can kind of make a summary line for each diet. And you can also see that some of these diets perform better than others. It's like something that you can conclude. But now come the data machine learning people. And they say, we have these tools for the future of work. These are tools that you really want to use and apply. So I can imagine the pressure, right? Like, you're doing analysis here, but you need to wiggle a tool in here that's supposedly the future of work. And these are good tools, by the way, but like I can imagine that there's this pressure. So then immediately your mind kind of goes like, maybe I need to do something predictive here. And you can actually come up with a reasonable use case for that. You can actually say, well, given the diet and the time, maybe we can predict the growth trajectory for these chickens. And it's actually kind of a reasonable thing you could do. But you can also just wonder, well, is that the thing we should do? Like, should we immediately think about the modeling thing we want to predict here? Because maybe that's a distraction. And I'm about to give you like a very good hint. Like if you're in data science, there's one thing people don't do enough of. And that is that when they make a visualization like this, you need to take 5 minutes and just stare at the thing for a while. And you need to look for stuff that might surprise you. Hadley Wickham has this really great quote. Machine learning scales very well, but it doesn't surprise you. Visualizations don't scale super well, but they do have the ability to surprise you. And in this case, if you just squint your eyes a bit, something fishy is happening here. Notice here, like at time step 0, right? It seems that there's a chicken that's actually losing weight. Because if I look at the height, there's definitely like a chicken here that seems to be losing weight. I don't know which one of these chickens, right? But that's a bit off. And it's not just happening here. It's also happening, well, here. And that's a hint. So, okay, something weird seems to be happening there. Maybe we shouldn't model just yet. Maybe we need to think a little bit about that. Maybe we need to do another group by. And what I'm going to do now is I'm going to make the same visualization, but I'm just going to group by the chicken. Like I'm going to ignore the diet for now, just group by the chicken. And when you do that, you get a growth line for each of these chickens. Let's just go back there. You get a growth line for each of these chickens. And you can kind of see the trajectory for each of them. And when you then zoom in again and you squint your eyes again, you will notice that a chicken stops here. And another chicken stops there. Another chicken stops there. And if we now zoom out again and we just assign a color to the chickens that stop prematurely, okay, it seems that some chickens die prematurely. I don't know for sure, but like that's a hint that I'm getting. And now if I take a step back and I ask myself, which of these two charts is more important, right? Like, even if I'm using the most fancy machine learning tools and I'm like displaying all the metrics that try to convince you of how good the predictive power is, we have to be very critical here, because suppose that you have a TensorFlow model that's very good at predicting like the average diet weight over here. Are we actually sure that it's taking into account that some of the chickens might have died? Unless you are aware that that's a thing you got a model for, the model's not going to know about it. And this, I would argue, is a really nice example of a group by statement that can really save the day. If you didn't know this up front, you might be pushing a model to production that predicts dead chickens. And that will be bad, I think. So maybe we don't need TensorFlow to save the day. Maybe we need a certificate for asking the right question. Because that's something we maybe need more of. It's like a very simple conclusion that I have with this data set. So, okay, that's just one data set. Let's move on to the next one. Now, this other data set deserves a slightly different introduction because I have to talk about this kind of, I will say, unclear task first. That's increasingly popular. So what you can do is you can go to this website called Hugging Face. And Hugging Face has a couple of interesting features. They host data sets, they host a bunch of models, but you can also search for these models. And one way of searching allows you to say, well, I'm interested in the task of text classification. That means text goes in and some sort of class comes out. And, you can predict just about anything, like topic of a newspaper article and whatnot. But apparently, in the top 5, like most downloaded models on text classification, 4 of 5 are about sentiment, which is basically saying text goes in and out goes positive or negative. But then you start wondering, like, how do I interpret positive and negative? Because that's a pretty big bucket of stuff. Like, I can be in love and I can be laughing, but those are two quite distinct emotions that I don't think we should really pretend like they are the same. That feels a bit strange. And maybe the same thing for fear and anger. Like, I get that sentiment is like a simple concept, but it might be too simple as well, depending on what we're interested in doing with text. So imagine my delight when around the same time last year, like about a year ago, a bit longer, I learned about this data set called Google Emotions. they took the effort of actually writing a paper, and the Google name is attached. And this is a data set where we're not doing just sentiment. No, we're actually doing emotions. So they took data off of Reddit, and you've got text like this, like, oh my God, yep, that's the final answer. Thank you so much. And like you can attach labels to it. This is not classification, it's more like tagging. So you can have more than one class attached to this. Let's a bit of a detail, but I think it's interesting because it also makes sense. You can have text where more than one emotion applies. So that feels appropriate. And what you can do here is they also did a bit of annotation. So each example was annotated by at least 3 people. Sometimes even 5 people had a look at it. And you can read the paper and read all sorts of interesting details. So there's about almost 60,000 text examples, over 200,000 annotations. 82 people were annotating here. There were 27 emotion tags attached, from amusement to joy to relief to nervousness and grief. I mean, it's a huge palette of emotions that was covered. They also made this correlation chart that was interesting. So you can see that like some emotions co-occur together and some don't. Some just don't appear together at all. That's something that the paper mentioned. There's also like a lot of effort that went into pre-processing that was pretty interesting to read. So they removed a couple of subreddits just because they were too vulgar. Makes sense, Reddit. But they also masked the name of people as well as references to religion. Seems like a good thing. They made sure that each text had at least 3 tokens and no more than 30. All the annotators were English natives. So, a bunch of interesting things that went into this, bunch of thought. And then the paper also goes into like benchmark models. So they did the deep learning thing where they also show the confusion matrix. And it makes sense that certain emotions are confused with each other. And there's also these awesome like F1 charts for transfer learning. And here's where we need to stop again. Because we can get excited about these charts just like before. Like we can really get the blood pumping. But what if there are dead chickens in this data set too? And that's a question I've been asking myself more and more recently. So usually when you're looking for dead chickens in the data set, it's like a really good exercise to do. But if you're looking for a good hint, try to think about how the data set got created, because that might give you a hint. If you can't use visualization, how a data set got created usually gives a good hint too. So this data set got created because a bunch of people on the internet were annotating. And if I recall correctly, I believe the paper mentioned Mechanical Turk. So it's not just the fact that we have many people annotating, we also have people annotating that aren't in the same room. You can actually assume that these people don't necessarily talk to each other. And you can kind of wonder, well, maybe these people occasionally disagree. That's definitely possible, especially when it's emotion, which is culturally like a thing. It's not necessarily universal. It's language. That's also a thing. Oh, and by the way, it's also Reddit data. And that brings in an interesting phenomenon. So on Reddit, you can have text like, oh my God, those tiny shoes desire to, should be boop snoot, desire to boop snoot intensifies. Like that's a perfectly normal sentence on Reddit. But I can imagine that if you're like the 25-year-old or 50-year-old trying to parse what's actually being communicated here, like, can we really assume that everyone has the same opinion on whether or not this is about excitement? And by the way, this is an actual example from the data set. Like, I'm not making this up. This stuff just naturally appears. But no, okay, maybe this is grouped by time. Maybe this is one of those things I just need to check. Before I do any sort of modeling on this thing, let's just see if I can come up with a nice little number. So I group by text and I just check whether or not all the annotators agree. On all 27 emotions, by the way, at the same time. That's the number that I'm calculating here. And there you go. Out of the 58,000 text examples, less than 8,000 of them have every annotator agree on every emotion. So it's like 13% of all the examples have everyone actually agree on the emotions that are there. That's not a huge number. But I do want to caveat it just a little bit. So when there are 27 emotions, if only one of the annotators disagrees with one of the emotions, that also means that there's no agreement between all of them, right? So it's not like I expected this number to be high, but I would also expect, if I'm going to do machine learning on this, I do expect this number to be just slightly higher maybe, right? And what's more, you can also do like some other really interesting group bys here. So What you can also do is you can say, let's just look at the top 3 annotators. Usually these data sets, by the way, they come with like a huge skew. Like the top N% has like way more than N% of the annotations. So in this case, the top 3 annotators annotated about 14% of all the data. Together, they annotated almost 7,000 examples, and not even half of them agree with each other. So this whole disagreement thing, you didn't need 82 people to discover this. If you just take 3 people, it seems that they immediately disagree on a lot of this stuff. And again, I would argue, this is another example of a group by statement that could really save the day. Imagine not running this statistical check up front. Imagine training a huge model on it, right? And again, it's the same thing, like which is more important, and I hopefully don't have to convince too many people. There's a risk that you're going to model too early if you focus too much on the modeling tools that are out there. And just to like really drive this point home, like the standard data science pipeline, right? You start with your data, you pre-process the thing, you model the thing, out come some metrics, and if we like the metrics, we do the prediction thing. Well, if your data is not too great, your predictions are not going to be too great, but your metrics can still be super shiny. Like if people have bad labels, for example, your accuracy numbers are not going to prevent you from putting bad predictions out there. And I don't necessarily want to dunk on people, but I also had a look on the same Hugging Face website, and it turns out that a whole bunch of people trained models on Google Emotions, and they put them out there. And some of these models got downloaded like 260,000 times. And you got to wonder, like, did they run the group by? Maybe not. And I also don't want to blame them, right? If you see a data set from Google, that's like had all of this effort being taken in and had all the charts, I could definitely imagine that all of that distracts you from thinking about running this one little group by statement. Like, I do think it's a shame because people forget how these data sets came to be. But this whole annotation process that happens before it is really, really important. And I do worry that maybe if we're convincing ourselves that, let's say, TensorFlow or scikit-learn, if those are the must-have tools, then maybe we forget about the step back that we got to do once in a while. And, with that in mind, looking back, I do got to admit, Google Emotions is actually kind of a beautiful data set if you think about it. Like, sure, there's annotated disagreement, but I also don't want to dunk on Google Emotions here because a part of me actually fell in love with it. Like, for a moment here, right? How many data sets that are used for public benchmarking actually contain the annotator information? I can't think of a lot of them. And it's a great case study, actually, if you think about it. And what's more, there are actually some really interesting papers being written about this. There's one paper that I do recommend giving a read. The title is, Are We Modeling the Task or the Annotator? This is about annotator bias. Turns out if there's like one person who has like too many of the annotations under his or her belt, that's going to totally bias like the aggregate label that might come out. It's a really good read. But also, Google Emotions definitely had like a almost career-altering effect on me. Before, I would say, oh my God, super cool, new data set, let's try stuff. But now I like to think I'm a bit more critical. Before actually putting this in production, I really start to wonder, well, maybe there's something wrong with it. At least I should check like some basics. And it also led me to write a library. There's a library called DoubtLab. It is a relatively simple tool with some scikit-learn-based tricks to try and find some bad labels in your data set. And they're just simple tricks. They're not necessarily state-of-the-art, but there's stuff in there that generally is worth a try. And if you find that there are like some weird labels in your data set, that's an excellent time to maybe pull the plug and say, let's first check our annotator process. Maybe there's something up with that. And that's going to prevent a whole lot of harm in production. If you're interested in that, by the way, like how those tricks work, the Explosion YouTube channel, which is Mike's, again, my employer, I was able to make some content for that. So if you're interested in like the techniques on how to find these bad labels, definitely check that out. But then if I sort of pivot back to like the topic of the talk, like if we're going to be talking about like what are the must-have skills here, really? I mean, I get that you're not going to be able to buy a certificate in common sense. And I also understand that it's going to be kind of hard to find a boot camp in critical thinking. I also don't want to suggest that these tools are useless. They're not. Tools can be super useful, but maybe at this point in time, there's too much emphasis on learning these technical tools. And maybe it would be better if we can come up with more content that puts emphasis on this human part. Maybe we just need more anecdotes to share around, and maybe that's going to prevent more harm. So looking back, I hope people look at this and they say, well, this was indeed a talk about 2 data sets. And I also hope that we all agree that both of these data sets are actually super beautiful because they tell a very beautiful story. But most of all, I hope that the story here helps give Alice and Bob and Vectorella a sense of calm. Because maybe, even if we're Googling, we should worry less about these must-have and essential skills, because maybe we should just admit tools are just tools. It's very good to learn some, but maybe it's more important to just stay aware of what you're doing and to be the human in the loop. And when you do that, you might just have group by statements that save the day. And that, if anything else, is what we need more of in our field. And I also want to mention this because I do get this question a lot. It's this frustration with educational content that actually led me to make Calm Code. I get this question a bit, so I figured I might just mention it. It's honestly the fact that mainly what we maybe should be doing is just focusing on making educational content that are more about tools and thoughts that make your professional life just more enjoyable. And maybe we should be less braggy about the tools that we use. They're not necessarily super state-of-the-art. They're all just tricks to help us get through the day. And I'm mentioning this explicitly because a couple of you, dear listeners, are also content makers yourself. You do a bit of education. Try to keep the calm in mind is the only thing I would ask. Because I do think our profession will be a whole lot better if we stop bragging about the tools and we just start sharing anecdotes a bit more. I do think the field could maybe use a bit more of that. So, having said that, thanks for listening. I hope this was super interesting. And if I can give one small plug, so I work for this company called Explosion, and we have a bunch of cool tools like Spacey. You might have heard of that. And I can't announce anything just yet, but I can say there's a bunch of really cool stuff in the pipeline. So give us a follow. There's cool stuff coming. Just want to mention that. Thanks for listening. Ask me anything in Slack, and I'll be around for the conference today.
Thank you, Vincent.
Yeah, that was fantastic. Thank you so much. I really love this idea of cutting through some of the hype. And I think one of the themes that's starting to come through in NormConf is the importance of stories and anecdotes in highlighting some things. So are you ready for some questions from?
Yes, please.
Okay. So the first one, what are you using to doodle on the screen in real time? Or was that all pre-recorded?
My timing's not that good. No, so I can actually tilt the webcam a bit. So this is the Wacom One tablet. It's the cheapest drawing tablet from Wacom that you can buy that still allows you to see what you're drawing on. And I have this app called ScreenBrush. I can if I can click and drag that in. Nah, it's okay. It doesn't mix well with Keynote. But anyway, that's the tool that I'm using. If you go to Calm Code, there's actually courses on how I do this.
Very nice.
Yes.
A question from the room from Krishna. How many annotators were there in that data set?
82. Although, if I recall correctly, there was this one annotator that I think only annotated 3. It's very skewed, but there were 82 IDs involved, and it's also what the paper mentions.
Okay, so this is, I think, a question really appropriate for your talk. So when we bring up data deficiencies like this, they aren't always welcomed, right? Thinking perhaps in an employee-employer situation, especially when we don't have a good, cheap solution for it right away. So what are some approaches you use or that you would recommend for convincing stakeholders and teammates these open data questions are worth resolving?
I mean, there's always the argument of just mention the word risk. That's usually like the honest sort of thing. You can just say, look, when we deploy something, there's always just a little bit of risk, but this is not little risk. This is big risk. And another thing you might want to do is just share some anecdotes of stuff that went wrong in the past. Especially if you're interested in the ethical domain, I highly recommend going to the Dion website. It's this data science checklist of stuff you should check before you do stuff in production. And for every item that needs to be checked off, the website actually has a newspaper article of something that definitely went wrong. That's ammunition that you can bring along to your meetings. Calm Code also has a course, by the way, but that's stuff like that tends to help, where, again, anecdotes. And also, at some point, Another thing is also like recognize that it's often not malice but stupidity what's at play here. So it's not like someone wants to bring the evil algorithm to market, it's that people accidentally do this very often. So it also helps not to sort of like non-violent communication is like a book that might apply here that I do recommend people to also have a look at. Like those sort of tactics tend to work well too.
Yeah, it's great advice.
David in Slack asks you, do you think the professional skills like critical thinking can actually be taught in a classroom? If so, how? And by the way, he says he's asking for a friend. Wink.
I mean, so I am contemplating getting a bunch of friends together and writing a book that's just anecdotes.
Mm.
And what I do like to think is like, this is not a complete theory of creativity, but one thing the way that I think it works is when people make a connection between A and B that wasn't there before, that there's something creative about that. And I do think that like, if you've heard a story before where, hey, wasn't that chapter 4 of data science mistakes? Maybe that needs to be the topic of next meeting. I do think something like that could be very helpful. But a lot of critical thinking is just apply it on a daily basis. Like just ask the question, why am I doing this? An example that I remember from my internship, I used to be at this consultancy. And as the intern, boss man came up to me and said, Vincent, there's an Excel sheet. And when it's Monday, this value needs to appear. And when it's Tuesday, that value needs to appear. And you need to do that by hand. I'm sorry. But that would be an excellent point in time to say, no, we've got a for loop for that. That's also just critical thinking that we might be able to apply here. After that, there was a meeting and boss man asked me if I was sure I did it right because I was using code. Like that's, yeah. And then I quit.
That is, yeah, I don't know how, not the ending I expected to that anecdote, but I think that surprise ending in there is really what sells it for me.
Yeah.
So we have one for everyone at home. If you are in the Slack group, this is the place to ask questions. This is where we're pulling from. Vincent, you have more questions than we can possibly get to in this time. Like it's just
I'll be on Slack after. It's fine.
Yeah, I was going to say they just keep growing. So you've got a lot of post-talk follow-up. But before we kind of usher you out and usher in our next speaker, any final parting thoughts for our viewers at home?
What might be inspiring? I don't know. Try to be calm and just do like, I do like that. Maybe this, start your own blog more, especially because Twitter is not the place that it used to be. Maybe what we're going to need in a bit is just more RSS feeds, and we're going to maybe share interesting stories that way. And one thing I might want to see more of, like, blog posts are good, but just the today I learned thing, I think is like a powerful new thing. So instead of saying, I'm going to write a big think piece, just say like, hey, I learned something today. And because I learned something, that might also be something someone else is going to find useful. And then just take 10 minutes to just write that down. And let's just call that a blog post from now going on forward. I haven't written long like I write 2 think pieces a year now, maybe. And I write 5 of these today I learned things a month. And do that for a year and you've got a pretty full blog already. And I would love to see more people do that.
Yeah.
Bit of selfish advice this, but like, I would love to see more people do that.
No, that is fantastic advice. Thank you so much for your talk and for your advice, and wish you well in answering all of the questions waiting for you.
Thank you, Vincent.
Thanks for having me. Howdy.
Yeah, absolutely. So good. So lots of value here in stories, and definitely in telling our own stories and thinking about our own stories and blogging your stories. So coming up next though, wait, let me find, I have to do the screen share. James.
Yes. Coming up next, we have Tim Hopper.
Yes.
He'll be talking to us about 5 semesters of linear algebra, and all I do is solve Python dependency problems. This is an eminently familiar and maybe a little raw talk title. Did you ever take linear algebra?
I changed my major in college because I did not like linear algebra.
Just to dodge linear algebra.
Yeah, it was linear algebra. And I remember being in the class and we had like done calc and we'd done like baby linear algebra in high school. And I remember sitting in the class and just being so lost. And I remember turning to my classmate and being like, what's happening? And they were like, you don't know? And I was like, this is not for me. So this is not my major. And I got out of there pretty quickly. So
What'd you switch to?
at the time I switched into women's studies, but ultimately ended up graduating with a degree in biochemistry. So just a real windy path for me. No straight lines.
But they wound away from linear algebra is the important thing.
They did wind away from linear algebra. Yeah, like I still, every time I have to revisit matrix multiplication or matrix math in any form, there's this like pep talk of like, this isn't as hard as you think it is. Just sit down and do it. But I do. I pull up Khan Academy and just like make sure I actually know what I'm doing. So I don't have 5 semesters of linear algebra. So maybe that is why I cannot solve my Python dependency problems. I don't.
Well, no better man to tell us about it than Tim. Tim, are you on the call? Hey.
Here. Good morning.
Good morning.
Howdy, hello, good morning, Tim.
I'm worried this might not be the talk for you, Jesse. Just to prepare you.
I'm very ready. I've mentally prepared. I can do linear algebra. It's going to be good. So.
How hard could it be? It's got linear in the name, right?
That's right. Yeah. Straight lines. Perfect.
Ready to roll?
All yours, Tim.
All right. Good morning. I'm Tim Hopper. I'm a staff software engineer at Varo Bank. I'm speaking to you from my home office in Raleigh, North Carolina. I've worked remotely out of Raleigh for the last almost 10 years now. I hope this talk doesn't disappoint anyone to find out that it's actually not about linear algebra and it's not about Python dependencies. In particular, if you're too disappointed, you can head over to NormConf.com and watch some of the lightning talks for the next half hour. But if you're only a little bit disappointed and you want to talk about those things, I'd be happy to talk to you about them after the talk because they're two favorite topics of mine. What this talk is something I've kind of had in the back of my mind for years, is a reflection on the evolution of my own interest in my career and how the two relate and don't relate. In some ways, it's a working out of how I followed my passion, and my passion being really a love for math. And it led me to data science and machine learning, and kind of sent me out the other side of the door, doing work outside of my passions. I think it's possibly an overly introspective discourse on how I got into data science out of my love for math. And now 10 years into it, I do basically no math in my job. And I think there are others like me. I've talked to others like me. So this is a talk for you, and hopefully others who don't totally get it will benefit from it as well. So this is what my wife thinks I do, hunched over my desk in my home office, occasionally mumbling things about pip and conda, which she knows nothing about. My mom, on the other hand, she tells people I'm a super geek, and she doesn't know what I do. She just thinks I work magic with computers. My CEO, maybe a little too similar to my mom in ways, thinks I'm like Minority Report, a perfect precognition machine making predictions about the future. My manager, a little closer to home, knows me a little better. This is what he thinks I do. What I thought I would do as a grad student, studying machine learning 10, 12 years ago, was spend a lot of time choosing kernels for support vector machines. This is actually a plot I made in Mathematica for a paper I wrote on support vector machines as a grad student. And I can pretty confidently say I have never needed to choose a kernel for a support vector machine. On Twitter, of course, this is what I want people to think I do, work on deep learning and large language models and that kind of thing. But of course, what I actually do as a staff software engineer is search Stack Overflow for how to solve my Python dependency issues, like installing TensorFlow on a M1 Mac. If I was a little higher tech, I would include the clip that's famous in so many movies, like, "Yep, that's me. You probably wonder how I got here," and that's what I wonder too some days, how I got here, where my biggest contributions are often figuring out how to get pip to work the way we want it to work. So I'm a staff software engineer at Varo Bank. We're a consumer bank, phone-based bank, trying to make banking accessible to all. I help build and maintain our feature platform for the data science team to make machine learning features available for model training and in batch and real-time inference. So I also make it so defining new features is very accessible to our data science and analysts. And so they have the data they need, when they need it and where they need it, and reliably consistent data across the machine learning lifecycle. I've spent really, I guess, the last 5 years or so, more and more oriented towards helping provide tools and platforms that data scientists need to develop and productionize machine learning. I'm actually really glad I get to be involved on the more higher level and system level design of things. But I think in many ways, a lot of my contributions over my career has been trying to master the Python language and its ecosystem and use that knowledge to assist my team and my companies that I've worked at. So I've spent a lot of time just teaching people how to use Python more effectively, encouraging better software engineering practices, a lot of debugging people's pip issues, a lot of Googling Bodo exceptions, that kind of thing. And I enjoy that, and it's satisfying work, but it's not work that I expected to find myself doing. So I want to back up a little bit and talk about how I got here, because it's not really where I thought I would end up. So I really do love math. I loved linear algebra from the get-go. I think I was maybe that person sitting next to Jesse in linear algebra. Like, it came pretty natural to me. I've loved algorithms and just algorithmic thinking and mathematical models. And this goes back, for me at least, as far as Bill Clinton's first presidency, term in the presidency. In 1993, my parents sent out this Christmas letter when I was 8 years old, and talking about me, my mom said he hates handwriting, but since he learned phonics last year, he peruses the World Book for fun. Math is entertainment for him. Chris Albin, don't be offended that I use the World Book. We didn't have Wikipedia back then. But I loved math at 8 years old. I think there's an indication I love math at even younger than that. I wasn't like, Terry Tao, calculus genius at 4, but just always enjoyed math for as long as I can remember. Perhaps unsurprisingly, that led me to study math as an undergrad. I went to Grove City College in Western Pennsylvania. I actually started as a physics major. I think I had some kind of starry-eyed dream of becoming a physics professor for whatever reason. But pretty quickly, I actually changed to computer science as I realized I was enjoying some of that work, and I didn't particularly enjoy the lab side of physics. I enjoyed the math side of physics, unsurprisingly. So I thought maybe computer science would be for me. But pretty quickly, as a computer science student, I think my sophomore year, I was taking a theory of computation class, which is basically a math class about computation. And I was looking around the classroom and realized I was the only person actually enjoying it and really soaking it up. And most of my peers in computer science just wanted to be programming, and I wasn't actually particularly interested. That interested in programming. It kind of seemed like a tool to support the greater cause of studying this interesting, more abstract discipline of computer science. But I wasn't really wanting to be a programmer. So I finally realized math was for me and changed at the end of my sophomore year to be a math major. As an undergrad, I took my first two semesters of linear algebra, introduction to linear algebra, and then later numerical linear algebra. And I graduated in 2008 with highest honors in math. And while I was an undergrad, I came across this article. I have no recollection of how I came across it. But it was in Business Week, and I found it online still, 2006. And I remember this quote from the article. Says James R. Schatz, Chief of Mathematical Research Group at the National Security Agency, "There has never been a better time to be a mathematician." And I remember that quote, and I found that very compelling. And I was like, well, I could be a mathematician. This is great. Never been a better time. The article goes on actually to really start to describe what people started to call data science 4 or 5 years later. It says from fledglings like Inform to tech powerhouses such as IBM, companies are hitching mathematics to business in ways that would have seemed fanciful even a few years ago. Over the past decade, a sizable chunk of humanity has moved its work, play, chat, and shopping online. We feed networks gobs of digital data that once would have languished on scraps of paper or vanished as forgotten conversations. Even with the most powerful computers and abundant cheap storage, companies can't sort out their swelling oceans of data, much less build businesses on them without enlisting skilled mathematicians and computer scientists. And I think that's actually pretty great description of what would start to develop as data science over the last 15 years. But in hindsight, I think the choice of the term mathematician there was maybe a little bit skewed and not quite accurate. But for me at the time, I was like, this sounds great. I love math, and a job that uses math would be perfect for me. So after my undergrad, I actually entered the University of Virginia as a PhD student in the history of mathematics, which is certainly a talk for another time, not for today. But that was a program in the math department. I took my second semester of linear algebra, or my third semester of linear algebra there, advanced linear algebra. But I fairly quickly realized that this program was really only setting me up for a career in academia. And that career path was increasingly unattractive to me, which is probably a talk for also another time. I started to understand that my math skills on their own probably weren't going to be much value to anybody outside of teaching and instruction, which even then you need more than just math skills. But math skills at that time were really all that I had. I had done a little programming in high school. I taught myself PHP to make Lord of the Rings fan sites. And before that, I had done some TI Basic, which I don't think there's a NormConf talk on TI Basic, but there really should be next time around. I'm sure many of us cut our teeth on TI Basic on our graphing calculators. And I'd done a little programming in college, but I wasn't programming at all at this time as a grad student, and getting a job in software wasn't really an option for me. So I was kind of realizing I was somewhat skillless despite having a degree in math and being good at math. Nobody really is hiring for that for the most part. I discovered at some point the discipline of operations research, and it seemed like a great opportunity to merge interest in math, real world problems, and computation. And I found myself as a PhD student again at North Carolina State University, where I spent 2.5 years. And it was in this era, which is 2010 to 2012, that data science was really blowing up on Twitter. And I was spending more time on Twitter than I should have instead of on my homework. And seeing people like, the early data science crowd, Hillary Mason, Drew Conway, these people talking about this thing called data science that sounded really cool to me, and a way to use math, much like I was interested in operations research, to use math and computation to solve these real problems. And it seemed like a pretty obvious career path to me at the time. So I ended up losing my PhD advisor and dropping out with a master's. But in the interim, I was able to start to orient myself towards learning machine learning on the side, as well as in my coursework. And I was teaching myself R and Python in that era. It's also where I took my last 2 linear algebra classes, another numerical linear algebra class, and then an applied linear algebra class. So that leads me up to actually one step back in the middle of that time in grad school. I was able to talk my way into an internship at Kiva Systems, which is now Amazon Robotics, which James, the MC here, and I share in common. He worked there a few years after I did. But I was in the algorithms research group, which was just mostly one guy at the time. And I thought I had really, hit what was going to be the glory land for me, getting to do kind of this more pure algorithms work, focus more on thinking about these optimization problems, and working on optimizing warehouse robots. And my boss there was a PhD where he studied vehicle routing problems at UCLA. And as a starry-eyed grad student who wasn't that interested in software, I was discouraged to find out he was spending a lot of his time on the lowly work of getting Java code ready for production instead of doing what I thought was the pure work of algorithms research. And I committed myself that I was never going to fall down the route of just becoming a software developer. I was going to do math in my career. And from there, I left grad school. I thought I really found the perfect job for me in 2015. A friend asked me to come work with him on a DARPA project, building an open source implementation of inference for Bayesian non-parametric models, which involved a lot of really interesting statistics and math, and a lot of things I knew nothing about that I had to go read papers and learn and derive equations, and it was really fun. And then that 2 to 3 year project died suddenly after some staff change at DARPA, and I was back on the job market again. And after that, I had some kind of a realization that there's not this enormous market for algorithm implementers who get to do more of that kind of pure work of understanding the algorithm and implementing it, if only for the reason because you implement an algorithm one time and you have a good implementation, you get to use it over and over and over again, as we all use, scikit and PyTorch and TensorFlow and whatever over again. And sometimes we use Fortran implementations that were written 40 years ago. So after that, I shifted back towards more traditional data science roles. And I decided if I couldn't be responsible for the underlying algorithms, I could at least work on the math modeling side. But even then, I learned that in many companies, I think especially smaller companies where I've been a part of, the engineering barriers to making effective use of data science models was often momentous. And models often, and the math modeling was one of the least important parts because there were so many barriers to getting things into production. And so you had challenges like getting good data, political and organizational tensions, and these engineering challenges. So at some point I decided I was so frustrated with the engineering deficits that I was going to solve these engineering problems before going back and trying to solve what I thought were interesting kind of data and math modeling problems. I decided, I guess at this point, that I'd become what we now call a machine learning engineer because I wanted to be a data scientist who doesn't have to fight with Python dependency issues and who could instead spend all my time thinking about the nuances of support vector machine kernels and deep learning architectures. And so I'd be the change I wanted to see in my companies by doing the engineering required, what I kind of saw as the dirty work to allow the data scientists to do what I thought anyway is the interesting work. But at the same time, I've started to learn that there really actually is something quite enjoyable about writing great software, getting that software ready for production, and it's, if you're willing, it's something that's fun to be a part of. And so as a software developer, not doing mathy things necessarily, I still get to originate these ideas in my head and write them out with my fingertips. And unlike doing maybe just pure math work, you could maybe see that scale to work for millions of people or more and provide value for a company and its customers. And it's just fun to do something useful. Whereas, as much as I enjoy even the pure side of math and proof and various things, and getting to see something that can be used and engaged by others is very satisfying. I don't regret at all studying math. I'm actually really glad I did. I in many ways followed my passions, which I don't think is always great advice. I didn't really have a plan as I went into studying math. But it was just the route forward for me, and it's worked out in many ways. But as I think back on this quote, there's never been a better time to be a mathematician. My distrust for the NSA is probably on that quote, as well as more other things these days than it was at the time. But I think that was a misleading quote, and I think not to disparage many mathematicians that I know, but there's never been a better time to be competent at math, good at math, but being a mathematician on its own, I think usually is a pretty poor career path for people. And I tell most people today, people come and ask me about this, I think math skills without programming skills in 2022 are going to be all but worthless, unless you are becoming an instructor. But even then, I think probably a lot of people in various teaching capacities are going to want those programming skills, as well as they might have opportunities to teach things like data science courses. I was overconfident and perhaps oversold the value of being good at math for most of my day-to-day work. I can think back to, these are three of the linear algebra texts I had over the years. I reference very few of the ideas that I ever learned in those things. But sometimes when the need comes, it's great to have those little pieces of knowledge. At the same time, I've started to learn that software provides many of the same joys we can get in mathematics: problem solving, abstractions, worlds generated just by logic, reproducibility, really endless areas of study. And I think probably this was obvious to a lot of people, but it wasn't as obvious to me. For me, the joy and beauty of software was often hidden behind the frustrations and challenges of things like pips, resolution, impossible exception. But I've learned to uncover those beauty and that joy of getting to create things with software, the way that in math you can create things with ideas. So my career has been a crazy, unpredictable road, and I suspect it's going to continue to be that. I've spent a lot of time solving Python dependency issues, and a lot less time than I thought thinking about support vector machine kernels, but it's turned out all right. And I after this talk, if I think other people have sympathized with some of these ideas, if people want to talk about this, I'd be happy to do that. I'm done. Sorry, guys.
Thank you, Tim.
I see you waiting for me to say.
Staring at each other, waiting.
Thank you so much, Tim.
Thank you. You're welcome.
Yeah, that was fantastic. I'm going to ask my question before I ask anybody else's. How many classes in linear algebra are there? Because you took 5. Are there more?
They were all very different, actually. That probably mostly tapped it out, although there's a lot of, so they kind of diverge into 2 routes. Like you have these numerical approaches where you're like actually figuring out how you reliably do computations on a computer, and what kind of errors you can introduce. And then this middle textbook, Advanced Linear Algebra, was like it was kind of combining linear algebra and abstract algebra. So you're like doing linear algebra over other algebraic systems, which is like a whole another route. But I think kind of after you get to textbooks like these, you end up in something much more hyper specialized that wouldn't be called linear algebra necessarily. And then I guess the one on the left actually was probably one of my favorites, was applied linear algebra, trying to look at how linear algebra is used in things like statistical models. And it's actually really fascinating. Kind of probably more, these are all grad textbooks, but probably more of a continuation of what you might see in an undergrad class.
A question from Anders for you, Tim. As someone who dropped out of a CS master's and suffered a corresponding existential crisis, how did your brain convince you to try again? And was the second dropout existential crisis harder or easier to deal with?
What I didn't mention is how I actually started a computer science master's after my second PhD dropout. So I went straight from the University of Virginia to the North Carolina State University. I spent a year at UVA and went straight to this second program. And it wasn't an existential crisis as much as a I need to be able to feed myself crisis. So I mean, I really didn't feel like I had a great career path. And so getting more school, and I was able to get it, paid for and stuff, which makes a big difference. But getting more school seemed like kind of an essential thing to me at the time.
Yeah, that's great. So kind of related to math and your talk and all of this great stuff, Evan has a great question. So as someone who made a career change into data science and feels behind on the math side of work, what advice do you have for where to get started in improving math skills?
Yeah, this is a great question that I don't really feel terribly qualified to answer, because it's just not been particularly my experience. I think that would be a great question to drop in the Slack and have people discuss. I mean, obviously there are more resources today than ever through the internet and courses online and free books, that kind of thing. Yeah, I mean, I think probably the bigger challenge is how to structure your life and have the discipline to actually work on those things. But yeah, I don't. I think other people would be able to answer that better than I would.
Another question from this one's from Brandon for you, Tim. Do they make cameras tall enough for you?
Very funny.
I do like the framing, though. I feel like this is a really, it was a story about you, and it's a very intimate camera angle.
I'm standing at my standing desk, and I had to buy like the casters to put on the wheels to put underneath to make it tall enough for me to stand at. So some people are going to be lost in this discussion, but
I have one last one for you, Tim. You wrote, "Should I get a PhD?" Yeah.
Yeah. So I published this ebook years ago, probably 10 years ago, called "Should I Get a PhD?" Which I didn't really write. It's a compilation of interviews with 5 or 6 friends from Twitter, some of whom had PhDs, some who didn't, and to try to get people to think about that topic, which it's something I kind of think about less and less these days, but it's still hopefully useful. It's still free. ShouldigetAPhD.com. And I think the content is as relevant today as ever. But I went into PhD programs fairly ignorantly. I didn't have other than my professors, I didn't know people with PhDs. I didn't really know what a PhD program was like. And I think it's probably worth a lot. People thinking about a little more carefully. It's not necessarily the best route, that everyone should aspire to.
Yeah. So before we let you go and carry on with the rest of NormConf, any parting words of advice or inspiration for our viewers at home?
Just, I think, stay online and keep watching NormConf, because this is going to be a great conference. So I'm excited to have this stress of presenting behind me and now just get to sit and enjoy it a little bit. It's going to be a good day.
Thank you so much, Tim.
Sure. Thank you.
All right. So as I frantically, not that I haven't been hitting share screen all morning, but still can't find it consistently. I'm excited for all our talks. I'm also very excited for Lynn's talk today, NLP tips and tricks. But James, do you have a newsletter?
I don't. I maybe everybody's getting one. Maybe I should start one.
I mean, you should. I feel like you've gotten some good material. We've gotten some good advice. You could do you could hit everybody's inbox every day with a Today I Learned newsletter piece.
Are you saying you should be following me on my Substack?
Yeah, exactly. So
check that bingo box.
Check the bingo box. But Lynn writes a really fantastic newsletter. It is one of my favorite newsletters. It is things that I think are awesome. I also think Lynn's newsletter is awesome, but Lynn does this fantastic job of kind of going out in the world, finding interesting things, and then bringing all the links together into a regular newsletter. So it's perfect for people who love to have all of their links open, all of their tabs open, and just kind of progressively work through them. You can also read it and kind of go in and be like, oh, this sounds interesting, and follow up. So huge fan of Lynn's newsletter.
I have a question for you, Jesse. I'm suspecting you're a link pack rat just like me and just like Lynn. How do you keep track of all of the stuff that you want to read?
I do this thing where if I want to read it, like some things get my attention right away. There are things where I see the link and I'm like, I have to stop what I'm doing. I'm reading this right now. Some things get put into tabs, right? And I keep my tabs open, but either my computer forces a restart against my will and clears everything out, or there comes a point where a few days later I'll go through and I'll be like, you know what, I'm not going to make time for this. And so I just close everything out. Just no emotional attachment to those tabs.
Clean slate,
done. If it's important, I'll find it again. Right? How about you? Do you have a strategy for tab and link management?
I have a single todo.txt file that my entire life, all the links I got to read, all the work I got to do, all the doctor's appointments I got to schedule, one text file that is the anchor of my sanity and is where I pack my links.
What, do you back this up in 3 different locations?
Oh, I've got backups on backups of this text file. Lord knows what I'd do without it.
This sounds, how long is this list?
A couple 100,000 lines at this point. It's been going for over a decade.
I have so many, we just don't even have time to
That's
address.
a whole other one to unpack.
That's like a conference in and of itself is what, let's talk about your to-do list. But we won't do that. We will instead let someone much more interesting take over.
All right. Let's kick it over for NLP tips and tricks for Lynn from Lynn Cherney. Welcome, Lynn.
Oh, it looks like we've got a little audio connection.
There's nothing more normcore than audio connection issues, is there?
This is, I'm surprised that we've made it through the first part of NormConf without.
It's a pretty good record. Better than most meetings I attend.
This is true. All right, looks like Lynn, you might be back.
I'm here.
Hello, Lynn.
Can you hear me?
We can hear you. It looks like, yep. All right, everybody can hear everybody. So yeah, feel free to share slides, take it away. We're happy to cheer you on and fill space as needed.
Hi. I think there's a lag.
Oh.
I can hear you. Okay. Cool. I'm trying to figure out how to share that. Okay, so. Hang on, there's a security and privacy thing coming up now.
Naturally.
If this is what I think it is, Lynn might actually have to disconnect and rejoin us. This is a fun little Apple feature where when you try to share your screen, it says, cool, you got to change your permissions, close everything, restart, and rejoin. So that's fun. We will be here.
We'll be here. You know, Jesse, right before we kicked off this morning, right when you and I had just brewed our coffee and we're about to kick off, that is exactly when my computer decided it was the right time to restart with an update. And, you know, I think there is something in there detecting what is the worst possible time an update could be applied or a system could be restarted, and make sure to just stick it in there. Sort of a chaos monkey of computer rebooting.
Oh, absolutely. I mean, mine did it yesterday. It didn't even cross my mind. I was instead envisioning sitting down and NormConf starts, and then like kind of like in a hacker movie, right? Like everything just popped. Like for some reason, I've now got a virus and like I've got pop-ups everywhere and I can't actually use my computer. So I was mentally going through, what could I do? And then I was like, well, I have like 12 other computers. Like it's not that big of a deal. It's a Zoom link, Jesse, like just, you will be fine. But yeah, I feel like these kinds of things happen all the time, and nothing but empathy. We have all been there. So
Welcome back, Lynn.
yay.
Take us away.
Okay, can you guys hear me okay? I had to disconnect the YouTube because it was causing a problem. Can you guys hear me okay? Somebody?
Yeah,
Yes.
you are all clear on our
Okay.
end.
All right, sorry about that. Yes, it was a browser plus security issue. Okay, so yeah, this is me. I collect a lot of links. Slides are okay too? You can see them too?
Yep, everything is great.
Okay, sorry. All right, well, so I am a data science consultant, especially doing NLP these days, along with a bunch of other data science-y problems. I also used to do data visualization, and in fact co-ran a conference called NormConf a few years ago, which was, I will say, less well organized than this. So kudos to you guys. I have also been a professor at various points, but talk about a difficult job. And these days I do a lot with creative AI, which my newsletter reflects as well. So I work part-time with Google Arts and Culture and other clients. And I'm going to talk a little bit about some of them today because I've had some interesting problems with them. I've got a lot in this deck, and I'm probably going to go kind of fast. I'm not going to spend a ton of time on the code examples, but having been a professor, I believe solidly in giving code examples, and I spend a lot of my days looking for them online. So there's going to be a bunch of code, including stuff I'm not going to cover in my repo that will be linked from these slides. So you can find how to do things from that. And this is the essential plan. The last one, MISC Life Tips, is some of the tools I used that helped me solve some of the problems I'm going to show today. And we may not get to it. We'll see. So I'm going to use today a bunch of data related to text to image. So unless you're living under a rock, you know about these models where you can type in a phrase of what you want to see, and then you get an image out at the end. Stable Diffusion is the most popular open source model. And there are a bunch of repos of prompts that people have typed in, including this one, which is Lexica. So I'm going to use a sample of these for some of my examples today, just so you know what's coming. The first technique I want to talk about is called UMAP, which is a data visualization technique. This is incredibly useful for exploratory analysis. I've been using this technique of dimensionality reduction for a while, and before it was UMAP, it was TSNE, which people call TSNE, which drives me nuts for some reason. But anyway, we've got UMAP now, which is a little bit better, although related, as papers have shown. And it's something that allows you to get a glimpse of your data, a big picture text data, and really impresses clients, just as a side note. This is an old, not very pretty or sexy picture that I made using TSNE. This is a word-to-vec embedding of a bunch of poetry on Gutenberg books, so open source poetry. Alison Parrish collected all of this and turned it into a corpus that people use for various creative text projects. I was using it for a talk a few years ago, and then later was using the same corpus for a text generation project. And the first thing I did was this TSNE display of that poetry colored by date. So this is words, not sentences, embedded using Word2Vec. And then I mean, it's a blob. It's not like a good separation of anything, but the coloring and the sort of shape of it helped me discover something that I had suspected when I was playing with the data in a generation algorithm. In particular, this blob on the lower left is like archaic Latin, old English types of things, which basically were screwing up a lot of my output in this project. And having made this picture and done this color coding, I was able to clean the data set to turn it into something a little bit more modern, which is what I actually needed. So this was a tremendously useful display for me at the time. I do this all the time still. Now, frequently it's with sentences, or in this case, prompts. So this is prompts in this online data set that I'm going to be talking about, where basically, in this case, I was looking at like a subset with, I think the word body was the subset that I picked for reasons that will become clear. And I did this interactive display so that I could take a look at like, how was the word body appearing in these prompts? And in particular, like, is it a bad use? Because I was interested in not safe for work content detection. Making these interactive things, like the little GIF I just showed, is actually incredibly easy these days. The tools are just getting better and better. It's very easy with sentence transformers to just pick whatever model you want. Body prompts in this code example is just all of the text strings that have the word body in them. We do our model encoding, and then we run it through UMAP, which is this dimensionality reduction algorithm that Leland McInnes published. And that gets us XY coordinates, a two-dimensional matrix, which we can then turn into an interactive plot. Doing the interactive plot code is actually surprisingly easy. I mean, I'll put this in my repo, but basically we're going to use this library called Bokeh. And the thing that's cool about this library in particular is that you can either output in your notebook, in your Jupyter notebook, or you can make a file. And the file is self-contained, so you can send it to a client or show it later or save it in your repo. And it's fully interactive, where you can mouse over the text and see what the text is. So you can put HTML on the tooltips if you want. So that's that little hand symbol that you see there. That's me putting some HTML in. So it's really, really easy. This is another couple of examples. This is a different data set where I was looking at the use of the word blood in these prompts, because I was concerned about whether blood was being used in like a really gory way or whether it was just sort of generic. And it turned out actually that very few of them were really gory. A lot of it was very generic. So in particular, down at the very bottom is a lot of references here to blood moon, which is just a phrase, right? It's not especially about blood. So one of the things I end up doing a lot with these plots is sort of a crappy labeling, where I like basically outline like what's happening where on the plot in terms of content. This is painful and involves, doing sort of XY coordinates, getting an average, and then like, or just doing it by hand. So this over here on the right is one where I took, this is a bunch of books, and I did various averaging over the books for genre purposes. And the authors are the color coding here. And then I went into Photoshop and I did a really, really careful labeling job with all the content. So that takes a long time. And I mean, hopefully the tools for doing this are going to get better and better. The libraries for doing this are getting better and better. It's super powerful when it's presented nicely. And the interactive side of it is very cool too. So you might have seen this thing from Gnomic AI, which is actually Ben Schmidt, who's a digital humanities guy, who's essentially a database genius. He did this thing with all of these prompts from Krea.ai's stable diffusion search engine. It's very cool. All right, so relatedly, our previous speaker, Vincent Warmerton, he's been working on a tool called Bulk that supports selecting from one of these in order to do labeling. or to help with labeling in a kind of weak supervision method, which I had been doing before. So as soon as he released this library, I sent him like 6 issues of feature requests. And then Leland McInnes, the UMAP guy, is also working on a library called This Not That, which might actually end up being better for DataViz artifact creation. I don't know. I haven't had time to dig into it, but it looks like it's really cool. So that's essentially one of my main tips is like, if you do these displays, which are not actually hard to make anymore, you can get a whole lot of mileage out of them. They're fun and people like them, and you can make them look really good. Okay, so leaving behind the fun and not hard to make, let's talk about like real entity recognition issues in the wild. I've had 2 client issues this past year that raised so many issues around the tooling and the decision making and the design of these problems in this problem space. So here's one of the client problems. Suppose you want to see trends in searches in these prompts. So you have prompts like you see here from Lexica, where people are visualizing content, like in this case, castles, and they're putting in names of artists that they're interested in using as sort of inspirations. We all know that this is like a vexed issue in terms of artist citation. So suppose you want to track like who's being used in these artist names. Well, that's an entity recognition problem, right? It's also kind of hard for various reasons. I mean, right out of the box, it looks like it ought to be easy, but here's why it gets hard. So I took 80,000 Stable Diffusion prompts, and the repo link is shown there. There's much bigger sets out there, but for the purpose of this talk, I didn't want to use a big set. Ran it through Spacey, natural language processing libraries, BERT-based named entity recognizer, and got these totals. So right away, you can see the ones in red are essentially the same artist. Artgerm, Stanley, Artgerm, Lau, it would be probably in quotes there. So like this is one of those immediate questions that you hit immediately when you do one of these projects, which is, what do we do about that? I want to point out for people who know about using databases of entities to disambiguate or to link, a lot of these artists aren't in Wikipedia, that you have to go to other places to get any kind of like canonical reference ID or page for them. So yeah, the thing that comes up quickly with this kind of project is, what are you going to do with these? Like, what do you care about when you want to look for entities like that? So for instance, this is Mastodon's sparklines showing trending terms, hashtags on one of the servers. So in this case, like probably they don't care at Mastodon, but we might care from an NLP or data science perspective. Do we care that people don't know what the right term is? So for the Natural Language Conference, EMNLP, do we care that people are using both EMNLP 2022 and without the 2022? Should those be in some sense merged or not? So this is essentially an entity resolution problem. And the other question is like, do you want to know the truth about what people are typing, or do you want to know what do you want to know what they're actually typing in terms of how they type it out, the string, including mistakes, or how they refer to Artgerm? Do they know that it's Stanley Lau? And so all these questions come up quickly about like, what is truth and what are you going to be accurate with respect to in the data? You hit these problems immediately with this kind of project. So like I said, entity resolution is what we're talking about here, where we're usually talking about techniques that sort of identify, group, and link things to some object in the real world. So there is some artist who is Artgerm, and how do we talk about him, or how do people talk about him? And do we care about the differences in how they talk about him or not? So that's where the UI and the sort of system design part of it comes in. This is a huge topic of research and of tooling, and companies have solutions, et cetera. I'm a person, I'm not a company, but well, I am technically, but you know what I mean. So, so you end up doing research on like, what are the best ways to deal with this? You've only got a certain number of hours or days for the client or whatever. There's a bunch of papers and links that you can follow on this. But so some of the issues that you're going to come up with, you've done your named entity recognition, you've got in that data, you've got misspellings or orthographic variants that you found, like Leonardo da Vinci might be written in any number of ways. There might be misspellings like Leonor da Vinci. It looks like probably they're trying to refer to the same person, maybe not in some cases. And then we have things like name and label variants that are all true but are different. So this comes up a lot in researching things related to women's names. So Mrs. Smith, Mrs. John Smith, Pamela Smith, née Austin, like these are all potentially the same person. They're referred to, unfortunately, with a man's name in some cases. So your entity resolution situation has to handle these, right? Then there's misrecognitions of the model. So for instance, Mary's, it's actually Mary that's the entity, but this particular spacing model I was using often had an apostrophe S merged in with the token. Co-reference. So this is essentially another problem that sometimes clients care about and sometimes they don't. So Barry the Bat was a fun guy. Barry partied all night. Barry the Bat and Barry are referring to the same entity with different strings. So this is also classic with full names in journalism, and then you use the last name to refer to somebody. So sometimes clients want those merged and sometimes they don't. You need a co-reference detector to handle that, or crappy heuristics, which is what I end up doing a lot. All right, so tooling to handle this. So if you're just interested in counting and merging things, there's a whole bunch of tools out there that I've used a lot. One of them is the string grouper tool, which has various algorithms for how it tries to merge strings that might be the same. So it's a cool repo. I recommend looking at it. And you can do things like get what the similarity threshold is, use different algorithms, et cetera. But what essentially you're seeing here is I've run this thing over my list of artists or names from that data. And on the left is the original string, and on the right, it says right name. That's the first mention in the group that it made, that it's saying these are all probably the same thing. So you can see down at the bottom, Krenz-Kuchart, et cetera, et cetera, et cetera. They're all basically the same. Now, you're going to find that you have errors in your data. So there's the apostrophe S's, et cetera. Some of them are just bad. You might want to use a different tool. So here we're looking at like a combined list of who are the biggest groups. So Greg Rutkowski, Alphonse Buka had the biggest number of different variants, et cetera. Notice that not all of these are artists. Some of them are content of the image, like Emma Watson. So do you care is the question. Okay, so some of these things also have to be done by hand. So for instance, for big string differences, things like PricewaterhouseCooper, PwC is a valid way of referring to it. So you have to actually create a dictionary that says this is a thing that also is this thing. So the by hand thing is super vexed. You have to do this a lot, it turns out. So James Jean and James Dean are not the same person. One is an actor and one is an artist, but string similarity would say that they should be duped, like that they should probably be grouped together, and you're going to have to manage that. So you end up doing a ton of by hand stuff and maintaining databases and sort of lists of entities. It's just a problem in this space that you have to do that. And the tooling around this isn't superb. I just end up in dictionaries and lists a lot. It's a big problem. I'm going to skip this and move on to the next example. So one of the tools that I use, actually, this is very NormConf, is OpenRefine. So this is a GUI tool for helping you deal with data problems and sort of merge them and manage them. This is a great tool because I can just decide in this label, like right there in the list, how do I want to call that group and fix the string labeling issues. It requires a number of steps, and essentially what you want to do is you do this cluster and edit thing, and I recommend a sort of a workflow where you keep the original entity over in another column, and then you work off this column, and then you end up with a mapping so that you can use them later in a tool. All right, so wow, I'm definitely not going to get through all my slides. I knew this was coming. So basically, you'll be able to manage a dictionary of the original and the merged and export the data and deal with it. One of the reasons I want to talk about that is because dealing with rules is actually a big thing in NLP, at least in my world of NLP. You end up having to augment models with rules quite a lot. So Spacy has a bunch of tools for helping you deal with this, because you can write patterns and define rules that you can use as part of your pipeline in Spacy, which is super useful. So the entity ruler in particular allows you to say that this ArtGerm version is also this ArtGerm version with an ID. There's a whole bunch of docs and tooling around this that you can look at. So I'm now going to switch to this body prompts issue and the not safe for work classification problem that I was working on for one client. So say you have 8 million unlabeled examples and you're trying to work on a not safe for work porn classifier for these prompts. It turns out that one of the things that some of the moderators dealing with this data were looking at was mentions of porn stars. It turned out that that was actually not a bad idea. And in fact, in a lot of the cleaned up repos of this kind of data, the porn stars are still in there because nobody thought of ruling them out as content problems. So for instance, in this data set I was looking at. And like, let's talk about why that is. So the text itself is not bad, but the output image will probably be bad because it's been trained on photos of porn stars. So this is like, I was like, okay, this is an obvious gazetteer problem. I just need a list of porn stars. Where am I going to get a list of porn stars? Well, it turns out Wikipedia is excellent at this. And why might that be? Well, that's because an awful lot of editors of Wikipedia are white men. And so it's just a known fact that the entries on women porn stars are amazing. So this turns out to be a very good database for getting lists of porn stars. So Chris Albin's talking later, so I'm gonna give him shit about this, but anyway. So what I did, and this is something that a tool like Spacy will allow you to do, is you basically take a classifier that doesn't necessarily know enough about, say, porn stars, and you add them in as rules because you have this ability to do rules, and then you basically can override the text classification in case it doesn't know about the porn star and say, this is actually bad stuff. So I've spent a bunch of time doing like these creative modifications of pipelines in Spacy, and this is one of them. So I'm here to tell you how to do that. So basically all you have to do is define your own component that says, if I have a label that's a porn person, I'm going to call that a positive classification for porn, regardless of what the model did. And this is the crucial thing. It's like override the model and just don't allow it in this case. So you can get the code from my repo or from the slides, but basically we load in a trained text cat model, and then we define our rules for all the porn people, and we say override and use those rules for the porn person instead. And this is just tremendously useful. So for instance, I can have coffee with Mia Khalifa in the coffee shop and come out with these entities. One of them is a porn person, so the classification is definitely like, this is not safe for work. Whereas otherwise, if it's not a porn person, I get sort of ordinary entities, and I'm fine. I've learned a lot about doing really, really wacky things with spacey pipelines, some of which would not be probably approved of by the spacey explosion team, but basically here we are. There's a bunch of examples in my code in the repo. And I just want to wrap up. So Peter Baumgartner, who's also speaking later, has a great post about rules in NLP. And I mean, it's essentially the process you kind of want to go through is sort of this, which is you use rules to help yourself train a model, and then you review your errors, you fix and improve your model. This is fantastic, but also you might want to keep the rules around. So in this case, I mean, rules are fragile, and in this kind of context, you probably want to have like absolutely call it porn or call it not safe for work if this name comes up. You don't want to allow the model to be unsure. You just want to say this is blocked. There are a ton of spacey resources. I have become an expert on digging through them. You definitely want to use my list if you aren't up to date with how to use spacey and how to learn among their tools. There's a lot of information sort of floating around. There's a giant scary flow chart, which I'll show you a glimpse of in a second, but it's very, very useful. They have a customized labeling tool, and essentially they're like great people, and two of them are speaking here. So obviously they're excellent. This is only a part of the giant scary flow chart, but it is tremendously useful. Named entity
sorry to jump in, Lynn. If we didn't get to any questions, we got a real quick one for you. Have you found that there are some sentence embedding models that work better out of the box for the purposes of UMAP?
So I just try a bunch because, like I said, it's an exploratory method for me. So I just try a few until I see if I can see clusters. But the problem is that with UMAP, you also have like a bunch of different things you can control in the settings. So you can end up iterating a lot until you get to the point that you like your picture.
Fantastic. And will you be hanging out in the Slack with us after?
I will, and I'm sorry I went long, definitely the connection problems, but I knew I wasn't going to cover everything too. So
thank you so much.
Yeah, tons of great information.
Sure.
Thank you so much for speaking and sharing with us today.
Much
Sure,
appreciated.
All right. We are ready for our next speaker. Let's get my slides here. So we are getting ready to talk about Docker. Maybe.
Yes. Next up, we have how small we can shrink that Docker container with Matthias. Matthias, are you on the call?
Yes, I'm right here.
Welcome.
Thank you. Thank you. Right. Yeah, no principal Dockerfile architect, but I'm gonna try my best.
You're gonna do great. We're very excited.
Cool. Thanks a lot. Yeah. So it's really great to be here at this first NormConf event. It's been a lot of fun so far, and I'm definitely sticking around for the rest of the day as well. So my name is Matthias. I work at Accelerated, where I give trainings. I give a lot of trainings on data and DevOps related things in my work time. In my spare time, I really like to dig into things and see how they work and what makes them tick. And Docker is definitely one of them. What I'll do today is I'll share a story with you that's based on some experience from like 7-8 years ago when I was doing my first ML project that actually had to go to production. We recently started using Docker for some Django services, some Flask services. We had them running on VMs, and Docker seemed like a good bet to get this machine learning project in production as well. So, I got some help from some people, and I whipped up the first Docker file. And the simplest Docker file that you could probably build to do this looked something like this. Forgo the version numbers; they're a bit more recent than 7 years ago, of course. But we just grab a decent base image, Python 3.8. We copy in some requirements files. We install them. We copy the rest of our source code, and like maybe we run some tests or we start an application when we actually starting up. Because this was a data science problem, this was a container that trained a model. Our dependencies looked something like this. We had scikit-learn and pandas to do the actual ML part and the data wrangling part, which of course used NumPy as well and SciPy in the background. Produce some plots, so we needed matplotlib to make sure that we could actually get some nice statistics out of this thing as well. So I this together with the code of the actual model, made a nice commit out of this, submitted it, asked for a review, and this is the answer that I got. This container is massive. There's all this stuff in there that you don't need. We can't actually run this thing as it is now. Whoops, that kind of makes sense. And at this point, you also maybe understand why Docker chose like a massive mammal as their logo, because this thing is 1.7 gigabytes for just a simple Python container. It's insane. And if we go back to the Docker file and we think about that thing again, then it's kind of obvious also why it's so big. There was this line into the container without really deciding whether that's needed or not. And, I don't know about you, but a typical project folder for me looks something like this. There's a Git folder that stores my Git repository. There's an IDE folder, which has like my settings for my development environment. Maybe there's some local data, some locally trained models, some notebooks that I'm using. There's a virtual env in there that I'm using to test things and install things. And all this stuff got copied into my container. And, a lot of this is actually not needed. So, what should we do here? Well, we're not going to sort of one by one type out everything that we do need to add. Instead, what we do is we add like a Docker ignore file to our repo as well. This thing works the same as a git ignore. Essentially, it tells Docker, in this case, don't copy all these files when you're copying into your container image. I typically also use essentially the same thing that I use for my git ignore, except that I also add the git folder to the Docker ignore because there's no need for git history in there as well. And when I rebuilt this container, it already started to make a bit more sense, but it was still massive. 1.3 gigabytes, it's not as bad. So I committed this, asked for another review, and that's also the feedback that I got. It's much better, but still a bit on the big side. So let's try to shave off a bit more. Let's use a smaller base image, because if you look at the Docker history of this container that we just built, essentially almost a gigabyte of this size came from this Python 3.8 base image. So step 2 in this journey was using a different base image. And that was very, very straightforward, because there's a slim version of Python 3.8 slim or 3.9 slim, which is based on a different Debian image, Debian Buster Slim, which doesn't install like manual pages and other useful packages that you use on like a normal Debian operating system install, but not in a non-interactive environment like a container. So I rebuilt this thing, and at this point I kind of started enjoying myself. Like, oh, this dropped down to 490 megabytes. That's quite a big difference. That's pretty cool. So I went back to our operations guy and said, this is fun. This is triggering something in me. This number going down that's brilliant. So what should I do next? How can I figure out what can I still do? And they said, there's this tool called Dive. And Dive is pretty cool. It allows you to look at your container image that you've built and sort of see what's in there. So, at this point, I thought, this sounds fun. This is a couple of evenings of just digging around and trying things. Let's dive in. So this is what Dive looks like. It's a terminal user interface. You run Dive with an image name, and then you get this after some analysis time. And what we see here on the top left, sort of this area, is essentially all the layers that our Docker image contains. You can scroll through them, and then on the right side, you see the files or the state of the file system at that point in time for that layer. Everything in orange is adjusted. Everything in green is new. So we can sort of see what this layer added. And one of the first things that I noticed was that there is an 80 megabyte cache folder. That seems kind of weird. Also in Matplotlib, there's some tests. All these tests have baseline images. That's also like a couple of megabytes. Then if you dig further, you'll see like there's markdown files and there's txt files and there's like pyx files, and all of those things are useful in the context of interactive development, but kind of useless for this production container image setting. So I thought, let's just try to get rid of them. So I adjusted my Docker file slightly again, and I added a couple of statements near the end to say, well, get rid of this pip cache, look in this site packages folder and find everything that ends with like JPEG or JavaScript maps or uncompiled C source code. Just get rid of it. That should save, well, at least the 80 megabytes of our pip cache, but probably even more. Now, when I actually tried to build this, I kind of got surprised because in contrast to what I believed, this actually made our image bigger rather than smaller. It added like 14 megabytes for some reason. And I tried to look around for a bit, but I didn't really understand why this was happening. So back to our operations person. Okay, what's actually going on here? Do you understand this? And he pointed me in the right direction and said, you should read up on how these layers of container images work. Okay, all right, that sounds doable. How do they work? Essentially, when you build a container image, every run statement in your Docker file becomes a new layer. And a layer is the difference in file system content of what happened after the layer versus what was there before. So if you have a layer that adds a requirements.txt, essentially that layer will have a zipped tar file that has that requirements.txt there in that right location. Requirements.txt is not that big, it's like 85 bytes. Just that is that layer that's part of our image. Same thing will happen when we roll pip install. This pip install will run. Docker will check what is the difference after running pip install versus before. Let's take that difference, put it in a tar. That's our new layer as well. Now, the thing that becomes interesting when we start to remove things, because a layer can't go back to previous layers and change things in them. So the only thing that we can do in that layer where we say delete the cache pip folder is essentially make a tombstone. Say that there was a file here, but it's not anymore. From this point on, you should consider it as if it doesn't exist. So it's essentially a 0 bytes layer that says this file that was previously there, treat it as if it's not there anymore. And the same thing happens, of course, for this find thing. This is also why there is no actual size decrease when we structure our container image like we did. So after giving this some thought, the answer was kind of obvious. We need to make sure that we add files and delete files in the same layer. And we can simply do that by chaining some bash commands together. So when I do a pip install, also on the same line, but part of the same run statement, run this find command with the delete and instruct pip. Pip has an option that says no cache there, so it can actually not even make that pip cache in the first place. And essentially squashing these layers together, oh, that did work. That was quite a big step. One side note, we can do this manually like this, so just combining this adding and deletion in the same run statement. There is also a squash command when you do a Docker build that kind of does this for you, but it just does this for all the layers, which makes it slightly smaller and slightly less work to do, but has some disadvantages with layer caching that are, slightly less optimal that one. So at this point, we shaved more than a gigabyte off our initial image and almost a gigabyte off the image with the Docker ignore. So it was going in the right direction. And I started Googling it a bit, and I got some hints that said, well, maybe you should try looking at Alpine. Python 3 Alpine is an even smaller base image than the Python 3.8 Slim version that you're using. And that's true. It's only 6 megabytes or less than 6 megabytes. So that's what I did. I once again changed my Docker file that's built from this other base image instead. Tried to build it, but unfortunately that errored out. command error that with exit status 1, Python setup by egg info, check the logs. So I started comparing the log of these two Docker builds. And the first line that looked different was this downloading matplotlib line. On the top, we have the line from the Python 3.8 base image, and the bottom we have it from the Python 3.8 Alpine image. And the main thing that we see different is that in the top here, we see a wheel being downloaded, where in the bottom here, we see a tar.gc downloaded. Right? That seems to be the main difference. And sort of the conclusion here is that PyPI wheels are not compatible with Alpine for some reason. So what is a wheel and why aren't they compatible? A wheel is essentially the reason why most Python packaging just works nowadays. When you do a pip install pandas or scikit-learn, it will just download something, and there's not a lot of dependencies that you need to have pre-installed on your PC. And that's because wheels are a binary distribution format in which all external C code is already built for you, rather than a so-called source distribution, which is the tar.gc thing, in which the C code is not pre-built and actually needs to be compiled on your PC when you install the package. You can see, for example, for pandas, the difference between the source dist build and a wheel dist on the right. In the source dist build, we see algos.c and algos.pxd and algos.pyx, which are the CPython or the Siphon and original C code, whereas on the right we see this CPython 37m darwin.so, this shared object, which is essentially the compiled C code in the wheel distribution for us already. Again, on Alpine, it essentially downloads the left side, whereas on our previous one, it downloaded on Python 3.8, it downloaded the right side distribution. So why are those two things incompatible? And that turns out because Alpine wants to be so small, they use a slightly different set of base packages than, for example, Debian does. This whole wheel thing is brilliant, but there's a lot of work in the background that needed to happen to make this possible. And essentially all Linux distributions are slightly different from each other. So what the original PEP writers thought of when they came up with the wheel PEP was to make a standard subset of kernel plus user space APIs that we could assume to work on many different types of Linux installations. And they called this standard Many Linux. Part of this standard is that things needs to be built against glibc standard library, whereas Alpine doesn't use glibc as the C library implementation, but uses Moozle. So all normal Many Linux wheels that work on Debian and Ubuntu and what have you don't work on Alpine. So we kind of have to compile the code on our Alpine distribution to make them work. That means adding a lot of dependencies. Build-based, free-type dev, libpng dev for matplotlib, openblast dev for like numpy and scipy and stuff. So let's add all of those to our Docker file, install again, do a build, takes about an hour, and it results in a bigger image. That's a bit of a shame. Makes sense though, right? We needed all these build dependencies that we didn't have in our previous Python 3.8 image. So we should probably try to get rid of them. Now we already saw why this doesn't work, why we can't run this a pk delete of our build tabs somewhere later on, because that's not how the Docker layering works. But what we also don't want is to squash all these layers together, because with these kinds of build times, like these hour-long build times, we really like to use this Docker layer caching and make the most use out of it so that our iteration speed is at least somewhat decent. What we can do instead is use this thing called multi-stage builds. Multi-stage builds essentially allow you to have multiple from statements in a single Docker file, and you can copy stuff from an earlier Docker container build in the same file to a later Docker image. So we make a builder stage here in the top, we make a runner stage here in the bottom. And essentially what we do in the runner stage is we download from the builder all the installed packages and all the therefore compiled code as well. We still need openblast and freetype because those are runtime dependencies. So we add those to the runner image as well. That saves a good chunk of of size. But then the last question is kind of, okay, why did we still need open blast and free type? Because our wheel has the precompiled code, it runs in the runner image. So why is that still necessary? And open blast and free type, by the way, add like 200 plus megabytes to this image. So what makes the wheels that we downloaded from PyPI different than the wheels that we just built ourselves in the builder image? That has to do with that they're still linked against available dependencies on the operating systems dynamically. Those dependencies aren't part of the wheel yet. And we can check this using a tool called Audit Wheel. So Audit Wheel is a tool that can check whether wheels are built correctly, whether they're self-contained, but they can also nicely fix wheels and make sure that they don't need any external dependencies. So this is, for example, a wheel that I built myself for NumPy. I ran Audit Wheel against it, and it says, sure, this looks good, but there's still external shared libraries required by the wheel. If we would do this for Matplotlib, we would see OpenBLAS and FreeType in there. But as I said, we can also use Audit Wheel to repair wheels. So if I ask Audit Wheel to repair the NumPy wheel, it will essentially look in the operating system and see, okay, which dependencies, external dependencies did we rely on? And let's copy those into the wheel instead. If we add that to, so if we add Audit Wheel and all those dependencies to our Docker file, install the, or fix the wheels, then copy the fixed wheels to our runner image and run our tests, we see that we got this container image down to 288 megabytes. At this point, most of the size comes from our side packages folder. That's good. 197 megabytes out of the total 230 something, 280 something. But considering we can probably do even better, because we're compiling all the source code anyway, we can ask the C compiler, well, get rid of all kinds of debug information and optimize for disk space. For SciPy, that saves about 10 megabytes. We can add these compiler flags to our pip wheel statements. That saves about 50 megabytes. Then there's one last thing, which we can link some of these system dependencies, these SO files together using symlinks, and that saves another 50 megabytes. We really shouldn't do this though. This is not Normcore anymore. This is not part for a NormConf conference anymore. We should probably just stick with Python 3.8 Slim and do the decent thing and get Docker images that install in 5 minutes rather than an hour. That's it. Thanks.
Thank you, Matthias.
Needed to rush a bit for the end, but it.
Yeah, we got to keep things on time.
Yeah, no, completely right.
What people can't see at home is James has these amazing handmade signs that he just holds up until our speakers give like a slight, okay, I see it. So no, this was a great talk. I love this kind of troubleshooting and walking through step-by-step approach. I do have kind of a question for you. So do you have any readings or other recommendations for someone who's at a senior level and maybe wants to go to the next level?
That's in what topic? Because it's a very broad question.
I copied the wrong question from the wrong seed. So that
Sorry.
I was like, this doesn't really make sense, but I'm just going to keep reading. But
I have one for you, Matthias.
Sure.
Very, very simple one. Open up your soul. Do you like Docker, or was Docker a mistake?
No, I like Docker. There's definitely issues with it, but it's much better than what we had before. Which was, my first job, I was in a software engineer in a Java shop. Nothing was isolated. We had like a couple of VMs that we SSH'd into and copied WAR files and then had to restart Tomcat and just fingers crossed hope that everything worked. That was how it started. And we got Ansible, and Ansible was an improvement, but it's like, it's not the same. I really like the flexibility that Docker gives, the way that you can just use it in CI and test against it. I don't think it was a mistake. Oh. Nice. But good question.
Yeah, so it does seem like there is a lot of effort to get these packages working on Alpine Linux. So
Yeah.
why can't there also be I don't know how to say this, I want to say like muesli.
Why isn't there a
Muesli.
better way?
Why isn't there a better way?
Yeah,
Yes.
yeah. So things move slowly in this space. I think there is a lot of effort now to actually make a better way. There's a semi-recent PEP 600 something, I think, that essentially says, let's make not just a many Linux stack, but also make a Moozle Linux stack that would say, oh, wait, it's essentially the same kind of idea, but then for everything that uses Moozle as the standard library. So once that gets adopted, gets implemented on PyPI, and once package maintainers then also start building all their stuff for Moozle Linux tags, then hopefully a lot of this stuff will get better. But yeah, that's still gonna take a while, I think. I'm afraid.
One from Vincent, our speaker from before. He had a question for you. If the logo were not a humpback whale, what other animal would be a better logo for Docker?
Well, this was definitely a rabbit hole, so maybe a rabbit. I don't know. This is kind of sad to see a rabbit with containers on its back, though. So
That's true.
But they are very small containers. And
yeah, very small containers. Then it's fine again. Yeah, yeah.
Only would have been sad if we didn't take your advice from the talk.
Excellent point.
All right. Before we change over, do you have any other parting thoughts for us all, Matthias?
So don't get stuck in learning tools, but do make sure to learn the tools properly if you use them. Make sure you understand how they work. Make sure you understand how your application interacts with them. Most of this wasn't Docker; it was Linux skills and like Python dependency management skills, which are a whole topic in and of itself for an entire conference. But yeah, not necessarily just a Docker issue.
Great advice. Thank you so much.
Yes, thank you. This is fantastic. All right. So before we get to talking about our next speaker, I do want to give a big shout out to Delta Lake for sponsoring today's event. We couldn't have pulled this conference off without the support of our sponsors. And if you want to learn more about Data Lakehouse architecture, you can visit Delta Lake's virtual conference booth in our Slack channels. So next, well, I mean, yes, I feel like I'm very torn right now, James, because I kind of want to talk about the Docker logo, but also we have another fantastic talk coming up. I feel like we're at the point in NormConf where the number of good things to talk about has piled up. And we just have to leave some things on the cutting room floor.
Yeah, we do. And I really liked Matthias's interior decorating, but that's a whole conference in and of itself as well.
It's funny you say that because I was watching the talk and I was like, this like really just an incredible background. And I did think about like, is it appropriate for me as an MC to start asking for interior decoration recommendations at NormConf?
I think it's all on the table.
That's true. Although
it's a really nice table.
It is a nice table. You have an interior decoration piece that ties in to our previous talk because you have a favorite animal.
Oh, yeah. Well, when you're a kid and you tell your family you've got a favorite animal because you're a kid. I happened to tell my family that my favorite animal was whales. I thought whales were super cool. And the way it goes, that means that pretty much every holiday for the rest of my life, I've gotten something whale themed from my family. And these days I'm like, Uncle John, I'm in my 30s, and don't get me wrong, I still love whales, but mostly it's Docker. But I have a whale here in frame. I have a couple more whales framed on the wall and other whale themed things all around. So maybe I was meant for Docker after all.
Yeah. It sounds like you're in the Docker theme, right? Like these nice nods to Docker, as long as they don't change their logo.
Yeah, I'll have to get bunny theme all over the house.
Bunnies all over. Fantastic. So we have a talk coming up, Spark horror stories from the field. And not to make this all about things Jesse doesn't know, but Spark, Pokemon, D&D class. Can you give me the Spark 101?
All of the above. Well, it's a level one spell. You only have to use a level 1 spell slot, so don't worry about that. But it's also, I think, a classic move in Pokemon for your electric Pokemon. Really, it's universally viable across games and tech stacks. I've really, my experience with Spark in the real world has mostly just been through PySpark and using it to take things that were just too slow and toss them into something else that seems to make them faster. So I'm really excited to be able to actually open up the hood a bit more with Gwenya here and learn more about how Spark really works under the hood.
Yeah, especially horror stories, I think, are maybe my favorite genre of tech talk, because it makes me feel not so bad about myself. And that we all have horror. Do you have any memorable horror stories that you can share?
Oh, actually on theme with we all do cron. At my very first job, it was at Amazon. There was a SQL query running on a cron job, running once a minute, dumping some stats, and it had been broken since long before I was hired. And so one of the very first things my team had me do was just fix the SQL statement. So I went in, changed a couple of the column names, and the statement resolved just fine. And I was traveling, so I go to the restaurant for after work, and I'm hanging out and relaxing. Next thing you know, my phone is blowing up because slowly those queries started taking 65 seconds each time, and brought down a couple of Amazon warehouses while I was eating my dinner. So that is cron still to this day. Like, my back tightens up a little bit when I hear the word cron. That's my horror story.
That's a good one. So we will at this point turn it over to Gwenya, a specialist solution architecture manager at Databricks, to share her horror stories in the field and can do a little comparative analysis afterwards.
Welcome, Gwenya.
Thank you. Thank you, guys. Okay, let me share my screen. Okay. Well, good morning, good afternoon, and good evening, NormConf. Welcome to my talk, Spark Horror Stories from the Field. My name is Genia Izquierdo. I am a field engineering manager at Databricks, managing the SSI team. I was trained as a software engineer, but I turned to data engineering and I've really loved it. My framework of choice has been Spark for the past 7 years. So here we are today. So today I want to talk about things I've seen people do using the Spark framework to develop their data applications, which have horrified me. And I hope to scare you enough to prevent the world from committing these Spark crimes again. So I will show you how I would have done this differently and what, from my very opinionated way, view is the right way. So I've grouped these stories into testing, performance, and monitoring groups. So let's dig in. Okay, testing stories first. A while ago, I opened a very important repo to make some changes needed to the utils functions of a very important project I had just been assigned to. And to my horror, there was no arrow next to the Scala folder under the test folder, which means no tests. So I decide to open the utils file, and I see many functions in there, and all of them, of course, were untested. Needless to say, I flipped the table. But then in a different occasion, I encountered myself in a similar project, but this time when I opened the repo, there were tests. So I happily opened the file to see what the test coverage looks like, and I find this. What is this? This is only testing that Spark can read data in. Come on, we can do better. There really isn't a need to test the Spark internals. You can be assured that that code has been tested thoroughly. So it is very hard to change production code without knowing the implications of the changes to the already existing code. So how do we make our code less spooky, our future lives easier, and our products better? Well, step one, the first step heading in the right direction is modularize your code with particular emphasis around reusable code, non-trivial transformations, UDFs, and utility functions. Step two, we write the actual tests. At a minimum, you should write a happy path test per function. Then if you want to go further, focus on what's important for each function you want to test. You can start with covering common corner cases and then checking to see whether there are complex arithmetics that could be prone to error. Are there any possibilities of getting into a null pointer error if one of the conditions is not met and you want to ensure the function returns gracefully? Or if you require the output to be of a specific format or schema, etc. So there are many things to consider in testing when you decide to dive in, and I encourage you to read more about it and actually do dive in. There's a lot of docs online. There's a lot of information online that you can check out. But at the very least, please write those happy path tests. Okay, so next up, for my second group of stories, I want to tell you some performance impacting horror stories. For these, I decided to tell you about things I see every day that are just low-hanging fruit, very normie, that can have an immediate impact on the performance of your jobs. So keep in mind that these are all simplifications of examples I've seen in production, and also that my recommendations can be applied to exploratory work and analysis, but I'm more interested in helping you put this into action on your production code. Okay, with that said, in order for you to see the horror in the next few examples, let's do a quick refresh of what Spark is and how it works. So under the hood of a Spark driver, we have a driver. The driver is the machine in which the application runs. It is responsible for three main things: maintaining information about the Spark application, responding to the user's program, analyzing, distributing, and scheduling work across the executors. And then we have the worker nodes. The worker node hosts the executor process. It has a fixed number of executors allocated at any point in time. Each executor holds a chunk of data to be processed. This chunk is called a Spark partition. It is a collection of rows that sits on one physical machine in the cluster. Executors are responsible for carrying out the work assigned by the driver, and each executor is responsible for two things. One, execute the code that has been assigned by the driver, and second, report the state of the computation back to the driver. In each executor, we have a number of cores, which you can also think of as slots or threads, and Spark parallelizes at two levels. One is splitting the work among the executors, and the other one is the slots in each of them. So each executor has a number of slots, and each slot can be assigned a task. In this diagram, for example, some slots have been filled by a task, and some slots are open. Now let's look at how Spark executes your program. So using one of these clusters that I just mentioned, Spark processes your data by breaking up a large task into smaller ones and distributing the work among several machines, which are called workers. At the core of every Spark application is the Spark driver program. The secret to Spark's performance is parallelism. Each parallelized action is referred to as a job. The driver converts your Spark application into one or more Spark jobs, and each job is broken down into stages. Stages are created based on what operations can be performed serially or in parallel, and not all Spark operations can happen in a single stage, so they may be divided into multiple stages. So each stage then is broken down into Spark tasks, which are then federated across each Spark executor, and each task maps to a single core and works on a single partition of data. For example, an executor with 16 cores can have 16 tasks running in parallel at any given point. So with that background in mind, that one was for you, Jesse. Let's go back to the stories. So one day, someone brings to my attention that their job they just deployed to production is really slow. So I go in, look at the code. Within 3 seconds, I tell them how to fix it. They do it, their job runs smoothly, and they happily move along. So what did I see? So I saw what I've seen so many times now that I just tell people to look for it without even looking at their code. So there's a few things going on in this particular version that I created here for you. So in rows 1 and 2, we load the data. In row 5, we filter the data so that we only look at today's state. Good. In row 6, we perform a join. In row 7 and 8, we group the data and perform an aggregation. Fine. In row 10, we print a count of the resulting data frame, and let's go back. We print a count of the resulting data frame, and we print that in a production job. So that's really bad. We shouldn't do that. And now, why is that bad? Let's unpack Spark a little bit more. In Spark, there are two types of operations. There's transformations and there's actions. Transformations are lazily evaluated, which means that the evaluation of your code is delayed until that result is needed. There are two types of transformations. There's narrow transformations and wide. Narrow transformations are those that you can compute using a single input partition. For example, think of a filter. Wide transformations usually require data to be shuffled or moved between your worker nodes because the operation involves data in multiple partitions. For example, think of a group by. So your key might be in any of the input partitions. So then the second type of operations are actions. And these are the ones who trigger the physical evaluation of the code written before, which is usually a set of transformations. Here at the bottom, we have some examples of what narrow and wide transformations are, as well as actions. And there's a lot more, and you can see those in the Spark documentation. So with that, let's take a look at our code again. So we see that we have a single narrow transformation, which is the filter. And then we have two wide transformations, the join and the group by. So, and then we have two actions. We have the count, sorry, we have just single one action, which is the count. When we decide to print a count on line 10, Spark will actually create the execution plan and your code will be run on your input data, which means that data that needs to shuffle for the join and the group by will do so now. This might seem insignificant with a small amount of data or during one-off analysis, but when you deploy this code to production, you are adding unnecessary overhead to your job. Some scenarios where this can be particularly bad are if you have really large data sets, of course, or if you are streaming and doing some sort of unnecessary action on every micro batch, then that adds latency to your stream. So remember, when you go to prod, remove all unnecessary displays and prints that trigger an action. So now the next are two different horror stories, but I've put them together because the resulting anti-pattern is the same. So in the first horror story, someone was wondering why their job seemed to be stuck in a very simple operation. And when I took a look, they were converting their data frame to pandas in order to iterate over the data frame. This is always a red flag because you rarely ever need to iterate over a data frame. For the second story, someone thought their job was taking a really long time and it wasn't even supposed to be operating on too much data. Okay, so why are these bad? In both of these cases, all records in the data frame are sent to the driver, which defeats the purpose of having a distributed system, since you're no longer executing your code in parallel on multiple cores and machines. So when you're writing your code, make sure you ask yourself whether you need to use either of these approaches, or if you can find a Spark idiomatic way of doing what you're trying to do. For example, one option for the first story could be to rewrite your pandas code into Spark to take full advantage of parallelization and remove the iteration. But I understand that you don't always have the option of moving away from pandas. I live in this world too. So if that's the case, I recommend you use the distributed version of pandas available on Spark 3.2 and above. This will allow you to keep your code as is, but take advantage of more parallelization. I wanted to show you a small example of the impact of all three options. So I run a simple count on this data set that has over 7 million rows. So when you run it on pandas, it runs in a little bit over 40 seconds. When you use distributed pandas, it runs in 0.59 seconds. And that's pretty good since we barely had any code change. And then if you do the refactoring and you write it in Spark, it returns in 0.12 seconds, which is much better again, but it would require some refactoring. So I'll let those numbers sit on the screen for a second here, and I'll let you draw your own conclusions. Okay, so for the next one, I wanted to talk about collect a little bit more. Let's spot the difference the differences between these two code snippets. So on the left, we have, we first collect the data and then we aggregate. On the second, we aggregate first, then we collect. So how big is the runtime difference, do you think? Keeping in mind that we are still processing the same data frame that contains over 7 million rows. Well, the first one took 3.72 minutes. The second one took 15.87 seconds. And it makes sense. In the first one, we brought all 7 million rows into the driver, and then we did all the computation in a single machine. Whereas in the second one, we took advantage of all those cores available in the cluster. Then we brought the very small aggregated data set into the driver. So, sorry, I wrapped that one really quick. So I just wanted to let that sit for a second too, and then move on to the next story. So for this one is a story about UDFs. And what makes it extra sad, bad, horrific for me is that I was the one who wrote it a long time ago when I was learning Spark and thinking I was a Scala ninja. It made for a very good, bad example of what I was trying to illustrate today. So I decided to let you roast me at a code conference, because where else, if not at a NormConf slide, would I be able to do this? So here we go. Let's not look at the code yet. Don't get hung up on that. First, let's talk about the requirements. The requirements I received was that given a date and an arbitrary day of the week that denotes the start of the week, not necessarily Sunday or Monday. In this case, it was mostly Wednesdays. We needed to determine what week starting date corresponded to the given date. And why is my code so bad? Well, for starters, the absolutely unnecessary complexity. It makes it harder to maintain, and it makes it harder for anyone onboarding to the code, given that we can write this in a much simpler way. But no, the worst part of it is that we're using a UDF when Spark native functions would do the work. So how can we rewrite all of this? Well, like that. Let's look at that again. So all of that into this. Okay, so what just happened? We used two Spark functions, date sub and next day. And by doing so, we simplified the code and optimized it because we removed the UDF. So why should you avoid UDFs when possible? So Spark SQL and data frame instructions are compact and optimized for distributing those instructions from the driver to each executor. When we use code, we obfuscate all of that, and that code has to be serialized, sent to the executors, and then deserialized before it can be executed. So it's a black box to Spark optimizers. A friend of mine always says that you should strive to master your tools. And if you work with Spark often, it really pays off to dive into this native functionality. It can make your code much more performant and maintainable, and ensures you don't get roasted in a future conference, at least not for your Spark code. Last, I want to tell you about a monitoring story. Well, this one happened to me again, that once I deployed a job to production and used the default cluster configuration my team had settled upon for production jobs. The job didn't have any issues, but a year after having this job run flawlessly, our infrastructure team was performing an audit and asked us to review our pipelines to make sure we were using resources effectively. Well, let me tell you, this particular job was not, and I felt really bad for all that year-long waste. So to be honest, this is something that happens quite often. We deploy an application to production and we monitor for its stability. We get emails if it fails. We have health checks that check that the output data looks all right, etc. But if the SLAs are met, health checks pass, and no crashes happen, usually we don't review production applications. So today, I want to show you a quick monitoring option that is available on Spark, and it's my go-to when I deploy, ever since that time, when I deploy a new job and want to make sure that it's configured correctly. So adjust your eyes, because the name of the tool is Ganglia. Ganglia looks like it's straight out of the 80s, but it does a great job at giving you a first-glance utilization overview of your cluster. If you are using Databricks to deploy your Spark jobs, the recommended best practice is that you put each job into its own job cluster. This allows for the cluster to only be up for the time needed for the job to complete, then shut off afterwards. If you're using a shared cluster, either on Databricks or using open source Spark, you will still be able to use Ganglia, only that you won't be able to infer the resource utilization for that particular job. But you would still be able to use Ganglia and determine whether the overall cluster has been provisioned correctly, and then talk to your infra team using some of the tips I'm about to give you. So there are three main parts on this beautiful screen that I want to focus on. The first one is at the top right, and it's the memory utilization. So let's zoom in. So here, the red line that you see is the total available memory for the cluster at any given time. As you can see, this cluster auto-scaled up and down a few times according to the usage of the cluster. That's why the red line goes up and down. The purple area is the memory actually being used. The green is the data that you have cached, and yellow is available memory. Just looking at this metric alone, if this was my cluster, this cluster seems to be doing all right. Next, we want to look at the CPU utilization at the bottom left. So let's zoom in. Here we see that the percentage, in this graph, we see the percentage, what percentage of the total available CPU was in use at any given time. As you can see, the most this cluster was used was around Wednesday at 1 a.m. That was probably me running the code to present today. And the CPU utilization was around 70%. So now I wouldn't change the configuration right away. I would probably give it a few other days or a few other runs to collect more data, and then decide how much I can downsize this cluster by, at least CPU-wise, because as you can see, there are short bursts of utilization, but overall the cluster CPUs is fairly underutilized. So last but not least, we want to look at the cluster network performance. This is a pretty simple one. It just tells us how much data we're bringing into the cluster and how much data we're writing out and how long those operations are taking. So the green line is how much data we've read into the cluster. The blue line is how much data we've written out. And the horizontal length, I'm going to call it. For example, if you saw the green line or blue line stretch horizontally for a particular point, that's how long it took to move the data in or out. So this is pretty much it with this one. The main thing to watch out for are those sustained peaks, which will indicate you need to provision a cluster with more network bandwidth, which you or your infrastructure team can do by choosing a different VM type. So that is all I have for today. Thank you all for checking out my talk, and enjoy the rest of the conference.
Thank you, Gwenya.
All right, let me stop this. All right.
A lot of the something a lot of the folks on the stream won't know is that Gwenya put in an enormous amount of work when it comes to putting together the conference, working with Vicky and all the other organizers. So thank you, not just for the talk, but for all of that work that went into making this happen. Thank you so much. Also, I felt bad because I was really only holding up these signs like, oh, we're at time. So I made you a sign just here for great job. Thank you so much, Gwenya.
Thank you.
I want everyone to know we appreciate them.
Thank you. That's lovely. Thank you.
So
Yeah,
looks like.
Oh, go ahead.
I was just going to say, it looks like we got some questions, particularly one here from Nishad. He asked, I'd be interested in seeing other benchmarks for vanilla pandas versus pandas on Spark versus pure Spark to get a sense of where it's worth adding engineering effort to translate from pandas to pure Spark. Do you know anywhere or anyone that does this?
I should know this, but I don't. I don't know of any particular resource that has the benchmarks that I can send you. But what I can do is, after the talk, I can go look, because I'm pretty sure I'll find some and I'll post them on Slack.
Yeah, fantastic. Super helpful. So one, I really appreciate the Spark overview. Very helpful for me. So do you have any tips for working through the panic of just realizing that you are watching a horror story play out in front of you?
Okay, this will happen all the time. So first advice is get used to it. This will come the moment you have the option to put something into production or write production code, you need to get ready for fires to happen, because they will happen. So getting comfortable with the waves, I think that's important. So, and while you're in it, I think it's remaining calm, going back to the root of the problem, trying to find the root of the problem, staying confident, because you wrote that code that went to production. So you know the context better than anybody else. So staying confident and just really being open to embrace the chaos as it comes, and be ready to tackle it.
Yeah, that's great advice.
Paul in the Slack had a question for you. What specific unit tests do you add to your Spark code?
So what specific unit tests?
Yeah, anything you make sure that you cover every time?
Yeah, so again, as I mentioned, you want to cover transformations. They're very important. UDFs and utility functions. So those three are I usually don't test that. For example, you have a data frame, you do a bunch of transformations, and then the output. Those are less interesting to me, because again, you're testing Spark internals at that point. Is the specific transformations that you want to make sure that if you feed them a particular corner case or a corner boundary, they're handled correctly. But yeah, so usually, as I mentioned, first start with happy path. You'll be surprised how much you solve with just using happy path. But you have to have something that tells you that things are running correctly. So yeah, at least I always add the happy path.
Yeah, that's great. So your talk seems to have inspired some people to get interested in trying out Spark. So we have a question from Wahid, who asks, what are some ways to get more familiar with Spark on personal projects?
Oh, that's a great question. So Spark is an open source project. You can just go to the site and download Spark onto your computer. It can mimic a Spark system on your local that you can run and start writing code and getting familiar with it. You won't get the full experience of what distribution looks like when you actually have a cluster with actual physical machines out in the world. But at least you'll get familiar with the syntax, some of the caveats of the differences, because it's like you look at it, if you've written SQL before, you look at Spark and it's like it looks familiar. Wait, but so there's certain things that are very, very familiar, but there's some nuances that are different. Yeah.
One last one for you, Gwenya. Do you do any kind of life coaching? Not just, or maybe just for code review? Could use a boost from a coach like you.
I do not. I think you've got it. I think I believe in everybody who's trying. That's the first step. So
fair. Well, we super appreciate everything you've done for the conference and for your talk today. And before we say goodbye, do you have any advice or final inspiration or closing thoughts for our viewers at home?
Stay curious. Follow your instincts when you're writing code. And yeah, have fun with it. I think it's very important to know that you're in it for the enjoyment of the work too. So yeah, keep that in mind.
Thank you so much. This has been fantastic.
Thank you both.
Thank you.
You're doing awesome. Thank you. Bye.
Yeah, I feel like now I'm just going to need a great job. Hold up. I'm going to need someone at work, like just in life, right? Can we hire you, like just in life, someone to pop up and just be like, great job.
There was a podcast that was talking about replacing your car horn with, so aggressive and angry, just replace it with something that says great job. Somebody merges in politely, great job. Just, lift people up a little bit.
Yeah, right. So that's such a great point, because when you're driving, anything you do to like communicate with another driver is pretty negative. We don't have any systems for being like, you're doing a good job. So
I do live in Boston though, so I'm pretty sure if I said great job to people while driving, they just think I was being extra rude, rather than the normal level of rude driving around here.
Like
So-
a very sarcastic, good job.
Oh yeah,
buddy.
great job.
You've done this before, for sure. So. So I'm excited for our next talk. So James and I did some research and some homework on all of our speakers, but this was a last minute swap, which means we got to do some frantic Googling and Twitter stalking right, this morning. And so the first time I saw this talk come through in the title, and I was like, I thought it was going to be about data science on senior citizens. Right. And I was like, I don't know how to banter about that, but that's okay. We'll get there. But it is a talk about, in Luca's own words, speaking at NormConf about a lack of leadership training for senior plus IC roles.
Staff citizens.
Staff citizens. Yes. Yeah. And so I'm curious, you are in a leadership position at the moment in your company.
Yeah, it definitely, like, I was also a staff engineer before, and it's a role that is still kind of amorphous at so many organizations. Like it's relatively new in terms of how a lot of people think about their org charts, and the people who are really effective at it are the ones who find their own shape within that role and then just really excel at that. But nobody really knows what that shape is going to be until you're in it. And so it's very hard to get mentorship. Because it's such a new thing, and it's very hard to really know, even if you're doing a great job. Like a lot of leadership positions, feedback does not come as easily as knowing that your unit tests have passed and things like that. So I'm really, really excited to see what Luca's got for us, wisdom on that, because Lord knows it's been sorely needed for me, and I'm sure for a lot of the folks on the stream today.
Yeah, absolutely. I think at least my paradigm for thinking about this historically has been you're an IC until you finally cave and become a manager, right? And so I'm very curious about this senior IC role, but also you've got me thinking, more of your great ideas, unit testing for leadership, right? What? Let's write those tests, like just get that feedback as you're doing your job. So.
All the unit tests for leadership are return 1 = 1.
Yes, exactly. We've got it. We've done it. So with that, Luca, we would love to have you come on camera and kick off your talk. Also, definitely check out Luca's Twitter profile, because the pinned tweet is Italian food. And I started looking at it and had to stop because it was going to derail this entire conference because it looks amazing. So Luca, welcome
Luca.
NormConf.
Thank you. Hi, everyone. Thanks for having me today.
Yeah, thanks for being here.
Like the background.
Thank you. I live in San Francisco.
Perfect.
Let me present my slides. Just give me 1 sec. Do you see them?
Yep, we are all good.
Perfect. Well, once again, hello, everyone. Thanks for being here with me today. I am going to talk a little bit about my experience about being sort of staff citizen or a senior engineer at Twitter and how my job changed. So a little bit about me. In a previous life, I had a PhD in math. After some soul searching or life crisis, as some other people might call it, I did what many people in that situation would do, which is go to find a software job. After a few years, I moved to San Francisco to do data science for a conversion and ad company. And in the past 5.5 years ago, I have been at Twitter, where I co-founded the machine learning ethics, transparency, and accountability team, and I operated as a capacity of tech lead for a research lead for the team. And sort of like this talk really came. I started thinking more about leadership for ICs during my time at Twitter. And so maybe if there is one thing that I want you to remember in the spirit of this conference is this meme. So it's a little bit more nuanced than this, but when people talk about a manager and an IC sort of career, they are very presented usually very separately. However, what I'm hoping to convince you is that they're actually not as different as people claim them to be. So maybe let me start with some disclaimers. This is not a talk about what being a staff plus IC mean. There's been books and blogs and many other resources being about that. So this is not about that. This is also not a talk to convince you to be an IC or not to be an IC, or if you should be a manager or you should not be a manager. I don't have anything against manager. Managers are awesome. Having a great manager really helps. Of course, there are not everyone is a great manager, but that's true for everyone. And so, I have talked about, I've used these words like IC is geriatric IC, like what does the word mean? So let's start maybe by defining them. So IC is short for individual contributor, is someone who usually in tech companies is a person who might ship code or do analysis. Roughly speaking, we can think as someone who consumes Jira stories. For the purpose of this talk, we'll consider geriatric IC or senior citizen, someone who is equal or above, of course, that depends on the role and the company, senior level. And sometimes these roles are called staff or principal, and senior level in most companies consider sort of like to be the final level, meaning that if you want, you can stay at that level without sort of getting flagged for performance, lack of performance. A manager, as we might know, but I just want to make it clear, is someone who manages people, has like literally direct reports, and so is usually responsible for the team. Of course, he's not always like, there is a lot of gray areas in between the two. Some companies also allow what is usually called tech lead manager, but for the sake of this talk and for simplicity, we are going to ignore this for now. And so what is the ladder? The ladder is usually the process that is in companies to get promoted. And so as I was mentioning earlier in my introduction, like my time really at Twitter made me think a little bit more about all this leadership and like how like sort of like a career for IC is not that different for manager in the sense that, so I was promoted to staff a couple of years ago. My job really changed drastically. However, I did not receive any proper or specific training for that. And so what happened to me, it was, I was trying to do my work and then someone would say like, oh, you should join this planning meeting. Or, I was added to a bunch of other meetings. And at the same time, I was still being asked to keep contributing, to keep being INC, like to ship my own code, to ship my own analysis. And at first I was very confused and annoyed, and I would like begrudgingly join all these meetings. In fact, here's a picture of me in those meetings. And again, like not really understanding why I was being asked to do too many jobs at the same time. Over time, I realized that I was juggling multiple things, and maybe that is what the job is all about. And so I was not only doing IC work for myself, so like again pushing code, in my case doing analysis. I was also mentoring junior people from my team, meaning helping them with the day-to-day sort of jobs and should we do X or Y? How do we interpret this analysis? How do we frame this problem? A lot of that. And also people from other teams, maybe more on a monthly basis or so. But I was also involved in a lot of this sort of like planning, team strategy, high-level meetings, a lot of talking that I was not expecting at first. And oftentimes when the discussion of like, should you be a manager, should you stay as an IC, they come out, I feel there is a lot of themes that keep coming back and that I might disagree with. So for example, I hear a lot, I want to remain on the IC ladder because I don't like meetings. Or, I don't like talking to people. I spend my day writing code. I do think that the hardest part of any project is the technical part. So I think all of those are sort of like things that I've seen and heard multiple times in conversation when people were sort of deciding to be maybe to switch to management. However, my friend Nick said that in the best way possible, which is any simplicity advanced engineer is indistinguishable from management. And so this is a little bit of an exaggeration, but is what the entire sort of like idea behind this talk is. So let's talk for a moment about ladders, tech ladders, or how do you get promoted in a big company? So here's an example of what a data science ladder, for example, could look like in your company. So you have a couple of entry levels, then you might get to like senior level, and then there is a bunch of other things after senior. Again, they might be called staff, they might be called something else. There might be, here is a 7-step ladder. It might be a different number of levels in your company, but it doesn't matter. The point being, there is usually sort of like that level, which in here we identify between sort of like senior and staff, where the job really changes, and that's where we call geriatric, as we defined earlier. Sometimes, some people might decide that they want to actually do management, and usually that happens not before someone reaches sort of like the senior level of IC, and they say, I would like to be a manager. And the company says like, great, let me train you. Let me give you some training for that. And they would receive manager training and, be a manager. On top of that, the more they go up their ladder, they will have even more training. Sometimes fancy school will do ad hoc programs for director plus or VP level. And of course, this is absolutely not a complaint about manager receiving training. I do think, and I do hope people, companies will keep train manager. They are very important. However, my question is, what happens? What do we get as ICs when we go up on our ladder? We don't really get anything. And so the point here, in a maybe more visual way, is that the two ladders are not really parallel as people tend to, as people like to think, but they actually tend to collide. And I know what you're asking now. Like, did I do this terrible slide myself? Yes, thank you. As you might know, graphic design is indeed my passion. And so, it is something that I have seen many people struggle in, like at that level, when they not tend to be aware of sort of like the leadership part. Sometimes people tend to think that in order for them to grow to the ladder, to be promoted to all the levels, they just have to be sort of like more hardcore, whatever that means. However, this is not enough. In fact, this is probably not the most important part. So let's talk about skill sets. What better way than talking about skill set than Venn diagram? In fact, like Kamala, I do love Venn diagrams as well. I said before, usually skill set are presented in a very complementary ways. So, you have manager skills, and then you have sort of like geriatric or IC skills, and they don't really touch. Some example that we heard a lot is like, oh, you're good at talking with people, you should consider being a manager or maybe a PM. However, I think, again, as I mentioned earlier, I think this is a lie, because after a certain threshold, and again, that's where the geriatric part comes in, they really overlap a lot. And so I do think that the real picture is not to it's not to non-overlapping Venn diagram, but is something like closer to this. And of course, there are some skills that are, IC only or manager only. So, for example, as an IC, you're indeed expected to, publish your own code, being opinionated about any kind of technical decision, write technical design docs and whatnot. As a manager, of course, you're supposed to do a salary conversation with your reports. You're supposed to honestly have a lot of awkward conversation, do a bunch of admin stuff and whatnot. However, my point here is that the stuff that really matters is not that the stuff that it's on the border, but it's stuff that's in the middle. And that's what I see mostly tend to lack, because we lack training. And so let's call this the make shit happen skills. And so if we look at this like area of overlap, we see there is a lot of things that are classically not associated with IC work, right? So there is mentoring, for example, as I mentioned earlier, like literally checking with more junior people on an almost daily basis if needed, if they're blocked, if they need help. A lot of meetings. Some of this meeting might be about planning. Some other meetings might be, with other teams. Indirect impact. So like, how do we make stuff happen that I cannot do it myself because of lack of time? And, a big project honestly required a lot of people. And so a single person cannot and should not, this is actually an anti-pattern, I think, if a single person does everything by themselves. And so what is what is it convincing people to do stuff mean? Well, maybe it's, you have an idea and you want to get headcount for that. In fact, our political amplification work started exactly that way, with like a simple idea, having a prototype, and then trying to get a larger team to work on that. Maybe it's getting technical consensus for a critical decision, or maybe it's helping, unblock someone on my team to work with some other team. Maybe there's an issue there, and they're not understanding each other. Is there something we can do there? Or maybe, it was to convince other teams that we should work together on a single issue. And so honestly, this, in my work, this came out a lot because my team did not own any of the models. And so if you really wanted to have any kind of an impact in the product, we had to convince other people who own the model themselves to make the changes. So that's where the indirect impact comes from. And so this is sort of, again, this is this middle area is like the area that mostly talking to people is the part that is most involved here, right? Not doing code yourself, but making sure that other people are enabled to do the work. In fact, I would even argue that the technical work is the easy part. The people work is the hard part. Sometimes teams have conflicting priorities. How do you convince them that they should listen to you instead of maybe their own priorities? I do think that this is, like as I mentioned, like the people work is really the hard part here. And so what's the difference really? What do managers do maybe that we don't as ICs? Capitalism, like the military, requires a very strong hierarchical structure where there can only be one person formally in charge. And in companies, this is usually the manager. And so usually they have internal responsibility for the team. And this goes both ways, right? If something goes wrong, they are the first one getting yelled. And of course, they will then try to figure out what was wrong in the team. At the same time, if everything is great, the manager will be the one sort of like representing the team for the praises. And of course, great manager will be able to elevate their reports as well. I mentioned that earlier, but I want to say that again. Like, part of a manager job is also to have a bunch of awkward conversation. Not everyone likes it. And finally, if you really want to sort of like be a C-level person in a company, eventually, if you eventually want to be a C person in a company, most often the path involves the manager chain. And so when I was thinking about this talk, I was like, well, what is that I've learned in my last, few years in my career that really helped me? What is like the sort of like a really important thing I learned? And I don't think it's anything related to a specific technology, a specific library, or a specific whatever. But it's really like the social skills that I learned just by doing this work. And so, the real transferable skills are the friends or the social skills we made along the way. And so to conclude and recap, I want to say that, manager usually get leadership training when they start being managers. However, I see don't, even after they sort of like pass a threshold that we call geriatric. Their work is very similar to management. So why don't we get the same training? I think as an industry, we should be more aware of that. And, especially because this is holding many folks back, because no one told people that that is something that's really important. And so if that resonates with you, and if you're interested, I've left some ways of keeping in touch. And with that, I'm happy to take any questions.
Thank you, Luca.
Yeah,
Thanks
this is
so much.
fantastic. And it clearly resonated with a lot of people. As you see, is when you head back into Slackland, a lot of people are, yeah, really, really applicable talk. So to kind of kick things off, could you suggest any readings or recommendations for someone who's at the senior level and wants to go maybe to the next level?
Great question. I wish I could. If you go to a bookstore and you look at the leadership section there might be a lot of books, but they're all for managers. I feel like literally it does not exist anything for people who do not manage people. And I wish there was something. But as far as I know, there is not a lot. My recommendation would be to try to find someone who could mentor you. This is what happened to me. I had the fortune of having someone mentoring me, like a person who was more senior than me, who really helped me a lot. So
I have one for you. This one's from me. So this is something I've heard from some colleagues who've gotten to this staff or principal level, is that because it's treated as such a fork in the road in terms of your own career progression, even though the skills converge, if you do decide you genuinely want to hop from one track to the other, that can be extremely difficult because you don't have that entry-level genuine management experience under your belt. Have you seen people make that leap, or do you have any advice for people who might want to make that leap?
So you mean from sort of like principal IC to management career?
Yeah, is it all the way back down to the bottom of the management ladder if you do make that hop, or are there ways that somebody could make more of a lateral move?
I have never been a manager, so I'm not the most qualified person to respond to that. However, Katie, who is also a speaker in this amazing conference, once told me something like, you have to, in order for you to be a senior manager, probably you have to have managed out someone at least once as an experience, because this is probably something that is really hard to do. and is like a career-changing experience in some respect. So I would probably agree with that, to be honest.
Yeah, great. So this is an interesting, I mean, they're all interesting questions, but this one from Sanjeev. So something they've always wondered, but don't have a way to A/B test is, how much does knowing the finer details of the tech that you're managing matter at a really high level? So saying that I feel like your knowledge reduces naturally over seniority for pretty much everyone, but looking for some clarification on whether or not that is an undesirable or immaterial shift.
This is true, and I think it goes back to different archetypes that are for like staff engineers. And there is the person, and I think I identify most with that, who is more broad rather than deep. So for example, that's where you maybe work with other people in your team that might be more aware of the like fine prints, and your job is actually to ask the question, to get the fine prints yourself, to understand the fine prints yourself, but you don't need to know all the details of all the project at once. If there is a critical time, you have to have the capability to go deep. But I would argue that you probably don't need that all the time. Some other people are like the dual of that. They actually, are super deep. They're like the world-renowned expert on that one thing. And then, of course, they also have sort of like a lot of indirect impact, but they might own that one thing. So I going back to the question, I would say it depends. This is something I struggle with a lot, because I like too many things at once, for example. In general, I would say it's an ongoing conversation with your manager to sort of like decide what is the right thing to do at that time. And that might change. Like the other thing that I want to say is that people think you are in one mode once and then you're stuck there your entire life. This is not true. Like things evolve. And so there might be a time where like, oh, well, now I have to go very deep in this one thing. But there might be another time where like, okay, now I need to scale horizontally. So I will work with more people and have less details myself.
A question for you from Max in the chat. How do you think the advice here would differ, if it does, for senior plus engineering ICs versus senior plus data science ICs?
Honestly, I think that would not change, in the sense that it will change in like the technical knowledge or the technical skill set might change. So that the thing that was on the left on the two Venn diagrams. But I think that mostly what stays in the middle is independent of the specific job title. Could be data scientist, engineer, ML researcher, whatever.
Great. So we unfortunately cannot get to everybody's questions, but you, on the other hand, now have a bunch of questions waiting for you in Slack about your talk, and people with questions about technical work and how to, how job hopping contributes to all of this. So I'm really excited to be able to read that and follow up. But before we let you go, do you have any parting thoughts, advice, or insights for our viewers at home?
Don't put pineapple on pizza. That is everything I want to say. Thank you.
Thank you. Okay, there was a Slack message that now makes a lot of sense in that context. All right, folks, you heard it here.
I'm glad I clarified.
It's the important.
Thank you so much.
Thank you.
Thank you,
Thank you.
Luca.
Of course. Anytime. Bye-bye.
So James, I have to ask, do you put pineapple on pizza?
Do.
I love
Dude,
it.
now that he's off the call, I can say
So
that.
good.
Honestly, but it's kind of a guilty pleasure thing. You gotta hide that. You gotta go into Uber Eats after and like delete the order so nobody can find out that you did that.
No, be proud of your pineapple on pizza love. I'm a huge fan. Not related to pineapples, although it wouldn't surprise me if she's done artwork with pineapples. I'd have to go back and look. I am so
not yet. I'll think about it.
Perfect. We have Helena Sarin, who is going to be talking to us about a game of construction. If you are not familiar with her work, stop what you're doing right now. Twitter.com/neural bricolage. This is one that was really hard for me to think about an introduction to, because it's literally just words like beautiful, incredible. Oh my, like I don't know how to describe it. But James and I are both big fans. And James, I know that you have some particular favorites.
Yeah, the Pottery Gan series that you've been doing lately. I really, it's remarkable. And I particularly, I think it's just so incredible to take your generative art and then bridge into a different medium like that. It's been so cool to follow.
Thank you.
What about you,
much.
Jesse? You have one?
I do, but first, can we just talk about the pottery? Because I know, Helena, you do pottery. You throw clay and make pottery. And there are times where I look at the things that you're posting and I can't tell if it's been generated or if it is real.
I like to intrigue people, so it's your choice. I mean, it's I don't know. I mean, sometimes, yeah, that's the whole thing, like the game of intrigue.
Yeah. Oh, absolutely. It draws people in. And I think a particular piece that I'm very taken with lately is seasonal ornaments. And if you haven't seen it, go through the media files. There's something about, it's these kind of bright, flat colors that look almost like construction paper that has been 3D sculpted. It was one that came across my feed and I was just like, it's stunning. I love it.
Yeah, now I am thinking I should kind of like do some paper engineering.
I mean, I'm not going to say
I mean,
no.
this one on my to-do list.
How long is your to-do list of projects?
Yeah. I won't tell.
That's fair. That's fair. We did find out that James has a to-do list of almost 100,000 items. So
yeah, pretty much.
Yeah.
And I'm sure that this one's going to be adding a few new items to that to-do list after this talk as well.
Yeah.
Absolutely. Yes. So without further ado, I would love to just hand this over to you. One quick announcement I do have for everybody at home is within a couple talks, we will be moving to a different YouTube stream for the live feed. We will let you know. You can go to normconf.com and you will get the link. We'll make sure everybody gets there, but just a heads up, at some point in the next hour or so, it's just this stream's going to go dead. But more important things, I would love to turn things over for a game of construction. Yes.
Okay, so first of all, do you see my screen?
Yes.
Yep.
Okay, perfect. So we can start. My name is Helena Sarin. I live in New Jersey. I'm a ceramic artist, and I live with my rescue dog, Cumin, my 3 GPUs, and my husband. And today I'll be talking about game of construction. Construction is a metaphor for art making by Pollock, and he famously said, it is all a game of construction. Some with a brush, some with a shovel, some choose a pen, and some of us choose neural networks to do our art. But the first question, what makes me a ceramic artist now qualified for talking at the Mail conference? I would say that a couple of years ago, I discovered this magical word, koge, and it means craft in Japanese, but literally it means engineered art. And since then, I'm calling myself engineering artist. And as a koge practitioner, it was my whole life when I was coding the low-level protocols in telecom, when I kind of expanded into machine learning 7 years ago, and when I'm now a practicing artist, making art for a living for the last almost 4 years. So koge is our word here. So, and I'll be talking about creating art, making art in the intersection of art and technology. So technology is our tool for us engineering artists. And it's not only with AI, it's basically for the last maybe century, it's even accelerated where technical invention brought a new art form. So we can pinpoint this in like history of art is like prints, then photography, cinema, computer arts, and now AI kind of like burst into the scene big time. So I work with generative adversarial networks. I mean, up until prompt-based AI came into the picture, I would say like AI interchangeably with GANs. Now I need to qualify that I work with GANs mostly. So the base recipe, first of all, I work with my own data sets. I collect them. I make photography, or I use my digitized sketches. So here is like my famous vegan model, which I took like salad leaves at the beginning of COVID, basically sitting home in lockdown. So I took I made 2,000 pictures of lettuce in like on my force for 2 days, making pictures in the light box of few boxes of whole food, organic, clean lettuce leaves. And I trained the network style GAN, and it started after like few days of training. It started generating creating this generative produce, what I started calling after then latentuses. So this talk I'm quoting a lot of, is a culture trash, and I'm like always into quoting. And I think this quote by Karpate is really kind of like relevant for artist engineers who like tinkering. So basically training your network is you sitting through the like days and nights, watching your model kind of making stuff, saving checkpoints. And the difference may be with researchers or scientists who work with neural networks. My loss functions are more kind of like wandering functions. I mean, I don't kind of care for particular loss. I care more about visuals, and that's why I'm glued to the screen, because I need to see like particular checkpoints where I kind of discover some gem. And I used to call training networks is my meditative regime, breathing in and out with the loss function. So, but basically it's like a game of curation. I mean, a lot of this, and for practitioners, being them engineers or artists, is just like you curating your results. And that's why I have this famous Burroughs quote, because you need, I mean, in any art form, you kind of like do sketches, you do a lot of curation. It's not kind of like particular to making art with the eye. But also, I think it's like a great tool of honing your visual perception. I mean, I kind of like some of my early work is a cringe, but some of them is sort of like, you know, looking at the world like a child, and spoiled and in awe of what you see. And this is one of my, basically one of my first publicly shared pieces, which I'm still very proud about. So, game of subversion. I keep saying that, like in a sense, us working with the same networks that researchers work, it's a little bit kind of like subverting what the model do. Because if researchers, their goal at large, getting to some digital correctness, in my case, is more like seeing interesting and novel and exciting stuff. So that's why maybe nobody cares about like first cycles of training, but for me, and this is a picture on the left, the fleeting beauty of early iterations. But also, like when you get like beyond the expiration date, I mean, I have some models on the right. You see the example of model drop, of mode drop, where I trained basically the network for almost like 2 years on and off. Yeah, and this is the network that was trained on my sketches. But also one of the technique I used a lot after I kind of like passed this excitement of like something in, something out, I started building the pipelines. So kind of like poor woman, one of the example of like poor woman super resolution, where I sort of like trained the next network on the result of the previous one, just getting to the resolution which I wanted or needed, because like the initial result was like 256 by 256. So I love this quote by Karpathy, who said, "It is not a single model, it's a beautiful composition of many submodels." That's how my pipelines look, because I have like about 100 models that I use practically all the time. Another thing that happens is you make art on the limitations of your medium. So early on, like again, to overcome this problem of low resolution, I started working with the grid. And for me, it became like a neural aesthetics in a sense. So I could have like interesting images and augment them, or kind of like make them bigger by employing the grid approach. And then I was surprised where like famous artist Jack Whitten called this the grid is a DNA of visual perception. It's an amazing quote. I didn't think in these terms, but that's what it is. Another thing, like again, like playing this subversion game, people who worked with neural networks early on remember this like problem of checkerboard. So kind of I jokingly started calling this checkerboard amplification series. So it's kind of like post-Gainism. I started writing a lot of like Python scripts, just doing like this computational grids, playing with a few kind of like digital collaging and stuff. So that's how this series of non-pointillism and checkerboard amplification series were born. Another thing, like for a couple of years, I worked with my sketches, and it's resulted in this, what I call the carvings of Latviansko, riffing on the Lascaux caves, where like cavemen's like our like predecessors in a sense drew on the cave. So I think like we early AI practitioners drew our part on this Latviansko caves. But also I like this quote by Linda Berry, who said that, like, take advantage of a basic human inclination to find meaning in random information. So basically the semi-abstract output of the early models invited this kind of like punning in gameplay, and I worked with it a lot. I mean, I kind of like, it's sort of like honing your verbal perception or your kind of like pun mechanism. This is kind of like controversial, but for me, it's very important. I kind of like burnt a lot about on this. So when like almost everybody, I started with AWS, of course. But then when I, like 5-6 years ago, started training on my own art, I decided I need my own setup. Not only because I didn't want to move like my data all the time back and forth on and forgetting to disconnect the volumes. I decided I basically want my own rig. And I started with GTX GeForce, like 1060, I think. And then kind of people of NVIDIA gifted me with this Quadro. And like I say, GPU is a girl best friend, of course. So now I have like this small stable of GPUs. And like, since I sort of like make this forays into different applied arts, last year I kind of got my own kiln, and I have like other kind of stuff. And it's not about bragging. I mean, it's like printing. I used to print a lot, and like outsourcing, it's a pain. And you pay dear because, first of all, in quality, because you can't control this. And another kind of like you pay money to people which you can kind of like not pay and make your art more affordable in a sense. So this was my star slide in every talks for the last like 3 years. And it sort of became obsolete with like prompt models, and I'll explain why. So in a nutshell, what I was talking about here, and it was relevant when like for training on your own data. So the more you own and the more you curate your data, the more original you are. So like in the origin of this chart, you have the less original art. So it's like art breeder and first kind of like public trained applications. But then like prompt text to image applications came into fore this year, and we all basically gathered around this push the button thing. And this is like, I looked at this slide and thought like, maybe it's not relevant anymore. And then I had this z-axis with ideas. And I think like since when you can find them, they join them. So we are all in the realms of this prompt models. I mean, it's inevitable, and this is something, the reality that we can't deny. So I think it's still kind of like relevant graph, but with more access, how ideas become more and more important. So that's probably, again, I mean, something that I take away from here. So to finish this part is just how I see this AI artist, or basically any artist who works with like technology. So you basically curiosity driven. I mean, it's like the world of what ifs. You try this. I mean, what if I kind of like make this data set or this data set? You improvise on the spot. You see your model behave this way. You kind of like encourage it to do it, or kind of like do something else. You are very attentive and good listener, because I think like patience is a very important trait for working with technology. You need to be attuned to what you do, but you also need to like tinkering. It's a lot of tinkering when you write your code, you whatever, like AI or any other thing. So creative coder goes without saying. You make your own tools. I mean, the less applications you use, the more interesting you are. It's not guaranteed, but still kind of like a precursor. So collector, process-oriented, we already talked about this meditative qualities of AI training. Collector, I mean, I basically save everything. I mean, you never know, I mean, whatever, checkpoints, like outputs, you never know what you can use. I used to kind of like pre-curate them. Then I stopped doing it because something that looked like a junk 2 years ago, all of a sudden becomes treasure right now. So you never know, your perception changes, the tools you're working with changes. So a lot of like dynamics. Also easily excited and easily bored. I mean, because we work with novelty tools, you move around a lot. So you get excited, you try it. I mean, you maybe need to stay with certain kind of like stuff for a while to see. So you're not jumping from thing to thing like without giving it a chance to express itself. And also, I think it's very important not to be precious about your work. And of course, having a good sense of humor helps. I mean, because it kind of like helps with the frustration, but also kind of like because AI is still kind of goofy often. So in the next like 5 minutes that left, I'll talk about projects I worked at. And I mean, neural bricolage manifest, like I keep getting this question, what bricolage means. And neural is kind of like comes from neural networks, but bricolage is basically making useful and beautiful out of a heap of latent space. I mean, this is how I kind of like riff on the definition. and my art is for people. So again, like artists, some artists say, oh, I will create because it's like I create for myself. There is a part of this, but I make stuff for people. Without people, I would be just curl in the armchair and just reading stuff. So a little bit of like, this is like mandatory milestone line, and how I call myself, like taking this expression from my friend. So I basically awkwardly stuck between digital and analog. In fact, I was very surprised when somebody like 3 years ago called me a digital artist. I never considered myself being it. Digital was always means to an end, and then being like projects I discuss right now. So, I mean, I try to kind of like do interesting stuff, different stuff with the output. So I went through the period of printmaking, silk screen, cyanotype. Then I started making artist books because it's so kind of like, I love books, and I think it's like everybody needs to make at least like one book in their lives. So the first book was like a religious trope on like this Genesis play. And it was like small, all my books are self-published. So this was like my first books with latent doodles. Then I think it's very important to have like collaborations with artists. I'm very independent, but still I believe like when you find a great collaborator, is just like amazing. So in this case, Dmitry Cherniak, a generative artist, created for me the training data sets with 3GS. And then I trained like 17 models total, and like from scratch. And that's like on the right, the results. And we are publishing the book. It's coming up soon. So another kind of collaboration is the book of vegan, was just published with the amazing food writer Kate Ray, who wrote recipes for this book. I'm very proud. I designed this book from scratch. It's like I went overboard. It's 150 pages thick, but still, this is what it is. And like we discussed, I'm into pottery for this year. And my first foray with generative pottery was like a couple of years ago, and I like this like riff on Pottery Barn, which became Pottery again. And yeah, I mean, then I kind of like stumble on a learning curve because it's a slow process. I'm kind of like all over the place person. So ceramics was not that, I mean, it was tough, but again, COVID and stuff sort of slowed me down. And I think like this time I'm ready. And basically I have my first fruits of my kiln coming out. And again, in a nutshell, it's something that I use GAN outputs to kind of like go through the convoluted process of printing 3D molds, then pressing or slip casting. So it's like very involved process, and maybe it's such a difference from like fast-paced AI art that I really kind of like getting very used to it, and I love this. So, but to finish, it is all a game of construction. Thank you.
Thank you. Thank you so much.
Thank you. I just feel, yeah, some of the messages happening in Slack. I think you are breaking people's brains in
that's like I said, I like to intrigue
the best possible way. So one of the questions that's kind of come up is, so I would say, at least in Western culture, we tend to think of art and technology as separate entities. And you bring them together and you thrive at the boundary in a way that I think people tend to struggle with. I mean, can you talk a little bit more about being comfortable in that boundary space?
Yeah, because I basically was doing this art tech stuff for my whole life, but they were like parallel tracks. I mean, like people watch TV, I make art. I mean, it's just like, I think we have a lot of like free time, especially these days, that it's up to you how you use them. So I moonlighted a lot. I did like food photography, I did like food styling, I kind of knitted. So it's like, so for me, it was never kind of a problem, but I always wanted to combine them. I tried generative art. It didn't work for me because it's like a lot of pure programming that at the time I was doing for a living. And then AI happened. And it's like, it was something that really elevated my artistic voice in a sense, because it's organic. I mean, that was my problem with generative art, because it's like too abstract or even like too non-abstract. It's too cold. But the AI GANs, early GANs, they have like sense of humor. They have like this goofiness. They have like this beauty. It was meant for me. I mean, so that's why. And all the adjacent areas happened like as a result, because it became like too kind of crowded for me. So I tried to kind of like look at different forays from where I started.
Yeah.
I have a question for you. When you started picking up these machine learning and deep learning skill sets to use for your art, how did you get started? What was your path to gaining those skills?
So I mean, I forever owe to Jeremy Howard and Rachel Thomas. I mean, I was super lucky to be in the first cohort of FastAI, and this is like, you know, a lot of like people who we know the names in AI right now came from this first group of first bunch of people. And another thing, like all of us pretty much like first AI practitioners worked on their job. So, I mean, I started with Keras with the Cholet book in hand. So I read it probably like cover to cover several times. So that's FastAI plus Cholet's book.
Yeah, that's so that in a lot of ways, I think that gets a lot of people started, right? Like, oh, okay, this is a good starting point. But what inspires you these days? What kind of has your attention?
I mean, it's like I said, I mean, I'm trying to kind of like, I have so many ideas about pottery, but I said like pottery is too slow for me. So I'm trying to kind of devise a way to kind of like speed it up, but in a slow way, if it makes sense. So I still want to make like one kind of a thing. So like what I call, I found this like perfect definition of where I'm going with pottery. It's called the deliberate imperfection. So that's kind of like tough to make if it makes sense. I mean, you don't want to force it, but you still kind of want it to be perfect, but still have like this handmade quality. So it's tough, and that's probably where I kind of like sitting and thinking like hard.
On that note, a question from Tim in the chat. You mentioned that you get glued to the screen while training to know when you reach something that's an interesting result. Have you gained any sort of intuitions around when you might expect those interesting results?
No. Like I said, I mean, I have this model for Latin doodles or set of models that basically reached the equilibrium. So that's why I kind of like intensified the frequency of saving checkpoints, because each checkpoint might bring something interesting. Typically it's not, but yeah. So no intuition, no.
I love it. It's always a surprise.
Yeah, I mean, that's it. I mean, that's probably a good thing to say about. I mean, I'm joking. I definitely have some ideas, but I want to be surprised. I mean, otherwise, if you're bored, what's the point?
Yeah.
Or if you build the tools. I said I build the tools, but like, I'm very kind of like, I prefer to do like a lot of manual stuff. I don't automate like curation because I'm afraid of missing something. So maybe I am control freak. I don't know.
Well, this has been such a delight. I know there are still questions coming in Slack if you want to take some time afterwards and chat with people. But before we let you go, do you have any parting words of advice or inspiration for our viewers at home?
Play a game of construction.
It's perfect. Thank you so much. This has been fantastic.
Thank you so much.
Thank you.
All right. So for everyone playing along at home, this is your second to last reminder that we will be switching YouTube links after Zachary's talk. If you're not sure where to go, you can check Slack or you can check normconf.com. So we are up on our final talk of our shift, James.
Oh, yeah. Yeah, it's how the morning has flown by. You know, where my gears are spinning on is that there's an element of Helena's arc that she didn't unpack, which is the tremendous puns, the vegan, anasis, numpytalism. That's, I want to know where that inspiration comes from.
Yes, yeah, it's definitely a talent, but we're going to go from art to hacking. And have you ever been, this is probably not what the talk is about, but have you ever been hacked?
Oh, the other definition of hack. Yeah, I have been hacked. Somebody got through an exposed Jupyter instance and ended up doing a whole bunch of Ethereum mining on an instance that we were managing. So I was on a first name basis with the very friendly members of the corporate security team as we got to the bottom of that one, and why exactly my team had an exposed Jupyter instance is a secret I'll take to my grave.
Yeah.
What about you?
Hacked, no, though I will say I follow a lot of InfoSec people on Twitter, and I know that I'm bad with secrets, so I do purposefully, try to be very cognizant of that. But like, I'm very easy. I feel like I would be very easily socially engineered, and this is a constant concern of mine. People have struck up conversations with me on LinkedIn, and they're friendly, and we're just talking about the industry, and they'll like ask me a specific thing about my job, and I'll be like, oh no. We're not talking anymore, like mute, we're done. But yeah, like you buy me lunch, we're gonna have a conversation. So it's something to be aware of. Yeah, definitely worry about that.
All our best friends on the stream now know exactly how to get your passwords.
Yeah. They're like, oh, so Jesse just needs lunch and we can get passwords. Fantastic. But yeah, pretty much. But you, as the CTO of a tech startup, you have some familiarity with like hacking your way to things, perhaps?
The other definition of hacking. Yeah. Pretty much everything I've done for the last 2 years has been a hack. That's the nature of things. Sometimes you gotta make it happen quick and dirty. You gotta just keep the ball moving and take whatever shortcuts are available to you, knowing that you're taking the shortcuts.
Yeah, if it works, it works, right?
It works. I think that's a lot of what Zach's here to tell us about.
Well, we're going to find out. Zach, we'd love for you to join us and talk to us about hacking our way to a better API.
Wonderful. All right, let me see if I can get my screen set up.
This is the most tense part of any conference talk. That's finding the button.
Let's see here. I will say I do really love Slack's new thing where it shows you a little mini window of that has been a game changer. So I'm very confident that you're seeing what I'm seeing.
Yes.
So my name is Zachary Blackwood, and I am a senior data engineer at Snowflake, part of the Streamlit team and acquisition. And I want to talk to you today about what it says on the screen, how to hack your way to a better API. Hopefully not to get hacked, but that could be a risk that you face along the way. So I suspect many of you have interesting stories for how you got into data. I don't know how many of the people listening and watching are at what stage in their career, and how many people kind of had this vision that I want to be a data person. I want to do things I want to do machine learning and modeling. or at least I want to do computer science. That was not at all my original plan. Actually began as a teacher, taught high school, various things, and eventually couldn't afford to do that anymore, sadly, and so I went into software. And one of the themes that I've noticed throughout my career as I've grown and as I've transitioned is realizing this doesn't seem like it's working great. There's got to be a better way. Even when I started teaching physics, I realized I went in not understanding a lot of fundamental things, even with a physics degree. And so I wanted to do better for my students than I had experienced. And a lot of that shifted into last few years. I want to build better tools for data related stuff. And in particular lately, I want to help build better data apps with working with Streamlit and being at Snowflake, helping to do that. So I do some amount of data engineering on the pipelines and DBT models and things like that. But I get to spend a lot of my time just playing around with Streamlit apps and trying to make things work better, which is a lot of fun and has led me to this topic. I remember very distinctly beginning my very first software job. I was in a small startup, sitting in a room with a bunch of smart people, having done zero professional programming before. And basically, I would spend a few minutes, get stuck on something, and turn around and ask the guy sitting behind me. And there were very smart and very patient and kind people sitting around me. And so I'm sure they got annoyed, but they did answer my questions. And slowly I got to learn more and more things about what we were doing, ask fewer questions or better questions. Eventually I learned there was a way to ask those questions on the internet. And I got slightly better at, look for what is the specific error message or error numbers, things like that. What is the specific software that I'm using? Can I figure out what's actually causing the problem? And I got pretty good at Googling things to find the solution. And for a long time, that was sufficient. But at a few years in, a new coworker came in, and he just seemed to know so many things about the software that we were using. And I'd been working with it for a while. And how did you find that out? Oh, well, I read it here. Well, how did you find that out? I read it here. And this is a guy who would actually read. He would read the PEPs for the new Python features coming out, and he would just read the documentation for the tools we were using. And I finally after going to him again and again, realized, oh, I should start doing that. So that became kind of the next stage of my journey as a developer that was slowly moving into the data world somewhat. But the last stage, which is really the thing I want to talk about today, and maybe 90% of you are here, but I hope there's a few of you who maybe are still at stage 2 or 3 here, is I actually realized as someone who's working with software, I can actually dig into the internals of the software that I'm using, of the third-party tools that I'm using, and actually can get a lot of value by doing that. So I want to convince you today that the internals of the software that you're using may be more accessible than you think, and that sometimes messing around with those internals is a good idea. So I want to talk about 2 particular kinds of messing around with internals that have been very interesting and useful to me, particularly in the last few years. And the first one is monkey patching. So monkey patching, besides being an excellent term, is a broadly applicable idea in various dynamic languages, where you actually can replace some of the code as your code runs. You can actually replace some piece of code with another piece of code, which turns out to be a pretty handy thing. I think I first was exposed to this idea with writing tests, and we need to pretend that API works this way, and so just for the context of this test, we're going to swap out a little bit of code to make it do something different, not hit a server, things like that. So this was a very surprising idea to me. I had no intuition that if I said x dot something equals something else, that it would actually work, but it turns out it did. Which is a very interesting thing and opens up a lot of doors. Oftentimes and maybe you have the same question of, okay, why is this package broken? Or maybe more often, why doesn't it do the thing that I want it to do? Why doesn't it work the way I want it to work, and I need it to work for this particular instance? Before we get into too far into the internals, the wonderful thing, if you have either a modern IDE or an ancient IDE with some modern plugins, you can very quickly get access to things like, here's the doc string for this method. You can find out all sorts of things. No, this is very basic kind of thing, but this is where often it all starts, and sometimes it all ends. Like, oh, now I understand why it does what it does. I understand I was using it in the wrong way, or, oh, it actually does support it. It just has this extra argument that I didn't realize. And so sometimes that's enough, but not always. Sometimes you really need to start digging in a little deeper. So one of the very handy things about many editors is you can actually go from your reference to a particular method, in this case, to the actual method itself. So with a couple of command clicks, in my case, here is the actual code behind that. And the interesting thing to me is that not is this some abstract representation of the source code as it exists somewhere. This is the actual code that is in my virtual environment that is being run whenever I call this method, which means, of course, that I can just change the code. I could literally go into this file and say, I would like it to work this way. I'm going to edit this file with my editor, and then my code will work. This is this is not monkey patching, but this is sort of the madman version 1 of it. This code doesn't work the way I want it to. I'm just going to change the code. Of course, maybe this is very obvious to you. It was not obvious until I tried it once. Oh, that's not a good idea, because number one, I now have no documentation about what I changed, and I'm probably going to forget what I did and never going to be able to find it again. And 2, the next time I update that package, my beautiful functioning code is gone. So not a good plan, but a pretty cool thing that you can do. And at least digging around and actually looking through the actual source code is a pretty handy thing to do. But if you want to do the slightly saner thing, which is, okay, I have this code, I want it to behave differently. Here's an example of what you can do. So if I'm building a Streamlit app, it has this markdown function that I think is nice, but it really could be a little more exciting. It really could be, I just want to have a little more emphasis, a little more oomph whenever I'm adding some markdown to my app. So I've imported my original code, and I've written this new function, which takes the same arguments as the old one, and manipulates the string that I passed in a little bit, and then some other boring stuff that I don't care too much about, and I just copied from the source code of the old one. The main thing is this line here, and now I can actually replace the old function with my new one by just declaring it to be. This is now going to be this, and like magic, it just changes, and and everything is fine, and now I can use it, and it works the way it should work, which is every time I write something, it yells it out in title in H1 with lots of exclamations. So this is obviously an incredibly useful example, but you can even do more things with monkey patching, and I'll give you another example later. Another wonderful thing that is more open than it seems at first glance is pretty much any website that you use. So if you're not yet familiar with developer tools, find out how to open developer tools in your favorite browser and just start poking around. And it turns out that there's all kinds of information that you get just from opening that up and reloading the page and seeing what happens. You can look in details about all the different elements on the page and what makes those happen. You can see the underlying source code, what's the JavaScript, what's the CSS behind the scenes. You can see what the network traffic is happening, all kinds of exciting things that are exposed to you, even just as a casual user of the website. So that's pretty neat. But even more fun is it's not just websites anymore. Your favorite editor may in fact be a website in disguise. So here's VS Code, and you see that's the same code I was previously editing. And on the right, I have developer tools open, which is you could just open up in VS Code because it's all Electron apps these days. So I can actually see here are the network requests that are being made to populate things, to load plugins, and various things like that. And while we're at it, it's not just editors. Your instant messaging program may well also be a website under the scenes, under the covers. So in this case, you don't get it for free. You have to pass an extra environment variable. But once you've passed that environment variable, once you've set that environment variable, now we can explore Slack as a website, which is of course exactly what it is. It's just a JavaScript app, HTML, CSS, JavaScript, just like I guess everything is these days. So here's the general channel from a couple weeks ago, and here are the network calls that are being made, and there's quite a lot of them. So all right, so what can you actually do with that as the most obvious thing that you can do, which my students were very thrilled whenever I showed them that they could do this, was, oh, I can change any website to look any way that I want. They thought it was really cool that they could go to the school website that showed their grades and show it to their parents after they had handily edited it. So of course you can do that. You can play around. It's very helpful for tweaking designs and things like that if you're actually building a website. But more interesting to me and more practical for a lot of my work is the network tab. So this is a particular request from the NormConf Slack. And this is one particular request. I hope I chopped off enough of the tokens so that you can't impersonate me, but oh well. So this is a request to get and I particularly like the everyone and not bots and not apps. So apparently this is to populate the list of who is in this channel. And I think this is the general channel. And I now not only see that this request was made and have the ability to see, okay, here's the parameters that were passed, but Developer Tools gives me this very wonderful thing, which is I can copy it. I can copy it, not just like copy the URL, but copy all of the details behind it so that I could replay that. And in my terminal, I can run a curl command to rerun that exact query with all of the cookies and everything set so that it just works until my token expires and things like that. But for now, I could rerun that and get that data out as a curl command. Maybe you love Unix kind of tools like curl. I personally don't have I love that they work and they're simple, but I often prefer to bring them into something I'm a little more familiar with. So there's probably several tools like this, but one that I like is curl converter, which allows you to take a curl command and convert it into the language of your choice. So here's that specific request turned into Python with a little bit of details stripped out. But this is now a functioning Python script that will return a response object that I can then, get it as JSON or whatever I want. And it just works. And now I can do programmatic things like maybe I really do want to see bots. Maybe whatever. Maybe I want to see what apps are loaded in this channel, or I just want to, make a cool contact list of all the cool people who are in the general channel in NormConf. So it turns out this is oftentimes a good way to work with a website or an app disguised as a website. I had a friend in another Slack group ask about, hey, is there a good, anybody know any good packages for scraping the Jenkins API? And I responded very cheekily with requests. And it turned out it actually was a pretty good option. So oftentimes just a simple ability to make arbitrary requests and take the actual network requests that are being made and turn them into code turns out to be really useful. So I want to talk about two real world ways that I've used this kind of digging into internals. one particular one happened a few months ago, and we had this situation where we had all this data that was being collected in a Datadog, and it was really useful for alerting engineers when something happened. But we wanted to store it in a more long-term place. We wanted to put it in our warehouse so that we could have it for queries later and see how things were happening over time. And there wasn't a real straightforward, obvious way that I could find to do this. So a colleague and I worked on a way to do this. And one of the first things that he actually found was Datadog has this wonderful UI in their website for building these queries and building up these monitors. And then they even give you a export as curl, which is just a really wonderful thing. It really encourages this kind of use this other places reusability. It's a very nice feature. And so that immediately gave us what we wanted. Almost, we really wanted it to be able to a little more programmatic than just the raw curl request. It turns out they also have a nice Python API to wrap around those curl commands, and you can basically take the query part of it and slap it into this Python library, and you get out something that, and you have type hints and all that niceness because the library knows what it returns. But used it. Sometimes it worked, but I found a case where it didn't work. It was complaining that it was expecting a string and it was throwing a validation error because it was receiving a Boolean. I was very sure, as far as I could tell, things were set up right on the Datadog side. It really was supposed to be a Boolean. I think I was using the wrapper right. Very possibly I wasn't, but as far as I could tell, I was. And I need to get around this error. So what did I do? Monkey patch it. And it turned out to be as simple as here's the old version of the method. Here's my new version of the method, which has the same arguments, and it returns the old version, except in this case, and it just skips the validation. Is that a great idea? It worked and it solved my problem. And I knew for sure I was smarter than this validator, that this really was supposed to be Boolean. So it worked out okay. And then I just slapped that in and ta-da, everything worked great. Other than that, no issues. One other example of this is very near and dear to my heart. So I'm on the part of the Streamlit data team. I don't work on the Streamlit core, but we use Streamlit a lot. So we build a lot of apps for seeing how are things going in the ecosystem. Are people using it? Are people using the new features? And we tend to, get the bleeding edge of the latest and greatest features and get real excited. And we were so excited when the native multi-page app feature, you get this nice sidebar with all the different pages. It changes your URL. We could throw out the old radio button based one. But as soon as I started using it, I realized, oh, well, you get this, this boring file icon, but you can put emojis in, just like we had in our radio button version, but you have to put emojis in the file name. And trust me, I could not stomach putting emojis in my file name. It hurt my soul too deeply to allow this to be the way. And so I had to find a hack. So looked around in the Python source code and found this method that's being called to generate that sidebar, which is called getPages. And lo and behold, it returns this dictionary that is a global variable that is cached, which means that if I make a new method that calls that getPages method, empties out the dictionary and replaces it item by item with what I want it to be, with whatever icon and whatever path and whatever name I'd like to get those pages, and then call this internal method, it just works. And so I could very nicely have my sidebar, have my cake and eat it too, with just a little extra method. This isn't technically a monkey patch. I'm not actually replacing the code, but in the sense that I'm digging into the internals, using things that may not be advisable to use. All right, this is my goal with this. You've learned over the years to use Google, to read the docs, use ChatGPT, and I hope I've convinced you that sometimes it's a good idea to dig into the internals and make your own API. And that's my talk.
That was fantastic. Thank you. What I'm taking away from this is it just works. And like, that's all that
Sometimes.
matters. That's all that matters.
If it does just work, that's mostly all that matters.
Right. That's all we really need. So one of the questions that came up was, when is it a bad idea, or is it ever a bad idea to use or manipulate internal APIs?
It's often a bad idea to depend on that. It depends very much on the context. I suspect that there are many people like me who do a fair amount of work, which is somewhat needs to work for a little while and doesn't necessarily need to work forever. Like I really need to be pulling this data a few times, or I need it to work for a month. That gets a lot easier than I need this to work forever. You run into problems like anytime I update the library, I've depended on all these things, and now those things have changed either on the website or on the source code, and so you pretty quickly, and it becomes very difficult to maintain long term. Sometimes internal APIs are pretty stable, but yeah, you run into issues like that. Another problem can be if this is always what you do. You can actually get into the situation where you're really not using the library the way it's meant to, and it actually does support your use case. You just need to actually do step 3 and read the docs. So those are some that come to mind.
Very cool.
I have a question for you. When should I think about doing something like this as a monkey patch versus, to your last point there, like when should I just be writing a shim or a wrapper or something to just make those internal APIs working the way I want them to, by bundling it up myself?
Yeah, that's a good question. I think the nice thing about a monkey patch is that I'm thinking about this as actually modifying or replacing a particular feature of this library, rather than I'm adding this whole new thing. I actually want basically what this is, but tweaked. And I think I think that can be at least conceptually a helpful thing. Excuse me. With thinking through your code. So when I see, oh yeah, I've actually replaced that function, that means it should work basically like the original function, but slightly differently. That's a good case for monkey patching. And when you're doing something that I was doing, which is I'm actually adding a new piece of functionality that really doesn't exist anywhere, which is where I can pass a list of pages. That's maybe a good example where kind of a wrapper around it.
Thank you so much, Zach. Really appreciate it.
Yeah, super helpful. I feel like I have a lot to put in my Today I Learned blog that I'm going to start writing for Vincent. So before we let you go, do you have any parting words of advice or inspiration for all of our viewers at home?
I feel like we'll just go rewatch the previous talk and get all your wise words of wisdom from that. I think is the best advice I can give.
Perfect.
I guess no, for real though, actually, don't be afraid to dig in. And maybe I'm talking to people who, all of you really already feel very empowered to just dig in and mess around. But I didn't for years of my career. You should feel, yeah, you might break something, but you're probably going to break it on your local thing and it doesn't matter. But you should feel that and feel empowered to dig in and tweak things and make them work the way you think they ought to.
Perfect. Well, thank you so much. Fantastic advice and a fantastic talk.
Thank you very much.
Yeah. So before we head out, NormConf is not over, friends, but James and I are done for the day. Well, you can tune into Zoom. You can tune into James's talk later. I don't know if we're still live, but let's assume we are. We're done doing talks on this YouTube channel, so you have to go to this new link. If you do not want to write all of this down, go to normconf.com. The link will be there. The link is also in Slack. There's at least 20 messages. Can't miss it. But James, this has been so much fun.
It's been a blast. Thank you for hanging out. And it's been awesome seeing all these talks. And we're only the tip of the iceberg so far.
We're 1/3 of the way through. So,
thanks for hanging, Jesse. It's been a lot of fun.
This has been great. James, I'm going to ask before we go, do you have any words of advice or inspiration for the viewers at home?
I don't know. Just keep it real. Thanks for vibing. If you need me, I'm on my mobile. Hit me up.
I can't top that. So with that, I think we are going to say goodbye, and we will see you over in the next stream. Bye.
Bye-bye.
Yeah. My image background is not there, so let me see if I can get it. We're doing this
We're
live.
streaming somewhere. I'm just going to assume that this. Oh, mute myself. There we go. So many things going on. All right. While Ben works out his video stream, we should be live. Welcome to part 2 of NormConf. People should be going in. Oh, there you are. There you are. And yeah, we are here with our speaker already. We have Joel Gruz here. I happen to know him from back in the day of the TensorFlow FizzBuzz thing. That was, I think, the first time I saw him and interacted. Do you happen to have any interesting things, Ben?
Well, how don't I know, Joel? There's Data Science from Scratch first edition, then there's Data Science of Scratch second edition, and you can't forget, of course, his Advent of Code live streaming events. So there's many ways to know Joel, if not from Twitter, those things, and we're just really excited to have him here today to be presenting.
So I think we were not live, so we got to start over. But I'm told now we're live. So
we're now live.
My
live.
YouTube has not refreshed itself, but
oh yeah. All right.
Okay. Well, everyone, thank you again for joining us as we set up the second session of NormConf Talks. Randy, want to
all right, we are
everything?
here with our speaker, Joel Gruz. I happen to know him from way back in the day, the TensorFlow FizzBuzz thing, which is epic if you happen to like FizzBuzz programming.
well, hold on one sec. It's still wrong. It's streaming to the first link. Give me a sec. Okay.
Technical difficulties.
Okay.
I'm going to just open the second link and then just watch it.
That's what I'm doing.
Cool.
Just so you know, there'll be a 1 minute lag between streaming on YouTube and streaming right here.
Yep.
Oh, really, a minute lag?
It's like 45 seconds or something. It is pretty. All right. I am hard muting the tab so it can't jump out and start blaring at us and cause feedback. Okay. Change. What's going on? Oh my God. Exit full screen. All right, are we on the first stream or a second stream?
I don't know. I don't really understand what's going on.
Yeah, hold on. I think we're live on the second stream. I mean the first one. What am I doing? It's just rebroad, unless they're changing it. Because I think I can see myself on the other one. Yeah. Okay, we're live on the first stream. So
okay, but there's like 400 people waiting on the second stream and only 200 people in the first stream.
Hold on.
And what we're going to do for now is just wait until
we're going to just start chatting about stuff and entertain ourselves.
We're going to entertain ourselves until this is all figured out. Some of you might be seeing us. Some of you might not be seeing us. This is what the nature of a NormConf conference. So I'm just going to keep talking. And then when this gets all worked out, we'll be fine. So first things first, I want to thank the previous MCs who were hosting for like 5 hours, which was amazing. And they did a great job. They set a great precedent for us. And now we've got to take the reins from them, which is amazing. Randy, how did you like the first section of the talk?
It's terrifying because the bar is so high. So all right, we're just gonna do this. But so we're gonna talk data still, right?
We're gonna talk data.
What would you like to know about data?
Well, is the data good? Is it clean?
No, never.
No, never.
It's never clean.
No. Can we just like light it all on fire? Would that just make it better?
No, pick techniques that'll work even if your data is not clean.
And
like random guessing.
Random guessing is good.
Yeah.
What kind of problems are you working on personally these days? Anything interesting, or is it non-data related, Joel?
Advent of code. That's my personal problem, and then woodworking. Those are sort of my two hobbies right now.
It'd be cool if we could get Helena, kind of a Helena inspiration here, and get data and software, science into woodworking. That'd be kind of cool, just like she's done with pottery. Use GANs to inspire your woodworking.
Yep. Sorry, I'm reading the Slack. Someone's asking if I would be open to life coaching. I don't know if they're asking if I need life coaching or if I'm willing to do life coaching.
I think the answer is both.
Obviously, you must need life coaching if they're asking, right?
I'm not good at taking advice from people, to be honest.
Yep. Someone brought up the dog.
So this is Josie. She is a golden doodle. She is about a year and a half old, and she likes to sleep while I'm working, and so I actually I put some cheese on that mat so that she would sleep there during my talk. Otherwise, she wouldn't sleep anywhere. But I figured she would look good in the background. So
she does look good.
As long as no one comes and rings the doorbell. If someone comes and rings the doorbell, she'll flip out, and then it will mess everything up. But
all right, so I think we've come to a conclusion that we are going to stream on the first link. That is my understanding of what's going on. So what I'm going to do now is, at least for the beginning, we're going to introduce our hosts, us, and then we're going to introduce Joel just after that. So just briefly, again, thank you, Jesse and James, for emceeing the first session of the conference. And thank you for your patience as we transition to this second session of the conference. My name is Ben Labashin. I will be one of your MCs. And I'm going to pass this back to Randy, who will introduce himself.
Hi, I'm Randy, Randy Au, just your second host for this session. And we're just here with Joel, Joel Cruz, and I know him from way back in the day. The joke about TensorFlow and using that to write FizzBuzz. Great joke if you can find it. It's still in the archives of the internet somewhere. And I'm Ben. Do you have any interesting things that you know about Joel?
Well, I mean, I knew about Joel before I even got into data science, so I'm sure that's very much like other people. His books. Data Science from Scratch, first edition, Data Science from Scratch, second edition. These were inspirational for me in improving my work in data science. And so I think we're very curious to hear what Joel has to talk to us today about. So
perfect. Thank you so much. Thanks everyone who put this conference together. I've been sort of peering behind the curtains, and I know it's been a lot of work, very little of which I actually did, but very much of which a lot of other people did. So let me share my screen and make this go full screen, which is this thing right here. And now I think we're good. Can you see my slides?
You're good. It's all yours.
Okay, and I got to find my lens. So I'm Joel, and I'm going to talk about what is the simplest possible thing that might work, and why didn't you try that first? So first I tried to ask ChatGPT to write my talk, but it gave me one of its mealy-mouthed, it's complicated answers. If you're playing NormConf bingo, I hope you have ChatGPT on your card a lot, because that's probably the only one that you're going to get, but you'll get it a lot of times. So anyway, like I said, I'm Joel. I wrote a book called Data Science from Scratch, which was mentioned. I also more recently wrote a book called 10 Essays on FizzBuzz, which is interesting. You should check it out. I'm known sometimes for my live coding videos, and more infamously, I'm the guy who does not like Jupyter notebooks. And so if you don't like Jupyter notebooks, you can watch my talk and agree. Or if you do like them, you can watch my talk and not agree. And I have a podcast, Abstraction Learning, which I didn't plug because we never make new episodes anymore, but maybe we will. Okay, so Most of you have never worked with me, but if you had, you would know that my favorite people to ask questions, or my favorite question to ask people about the problems is, what is the simplest thing that might possibly work? And the reason I started asking that is because people like to make things overly complicated. For example, not too long ago, I was talking with someone who wanted to do a machine learning project involving book reviews. And so they needed book reviews. And so they started asking questions about, like, what's the best way to build a Goodreads scraper? And if you look at, like, building a Goodreads scraper is a non-trivial endeavor. And so I looked in the mirror and asked myself, what is the simplest thing that might possibly work? And that was, hey, maybe someone else has already scraped this data set and shared it. And sure enough, it turns out that they have. And so that was, potentially a better solution and a simpler solution. And ChatGPT knows this. If you asked it how to get the book reviews data, it will suggest downloading it. I'm very bullish on ChatGPT. I would be even more bullish if it weren't broken. Half the time I asked it to try to slide, but big things are coming. And so over the course of my career, I've spent a lot of time teaching diverse teams of junior data scientists to do good data science. I've done this so much that if you ask DALL-E to draw a picture of someone doing this, it draws a picture that looks almost exactly like me. And so my style is to go off and let people try things, and then they try things and they come back and they tell me about them. And so then I have to ask, what's the simplest thing that might possibly work? And why didn't you try that first? And so I kept asking that a lot. But the further I go, I find that simplicity is not, well, one, it's not easy to get an AI to draw it, but also it's not easy to define. And so, here's this quote about simplicity requires hard work to achieve, and complexity sells better. So maybe simplicity is sort of the opposite of complexity. Okay, well, then what's complexity? Well, if you do machine learning, you've probably seen this bias variance trade-off graph where as your model gets more complex, the bias goes down and the variance goes up. And here complexity means something like, number of parameters or model capacity. Is that a good way to think about it? That's probably not how I want to think about it, but we'll see. And you can find examples of, here are some models that are simpler in the model capacity sense that do better than models that are more complex. And, people will write about these. That's not where I kind of want to go. Rather, I would like to really seek what is simplicity, and then you can distrust what I say. So a big part of why I ended up thinking about this problem is that for the last 5+ years, I've been doing a lot of natural language processing. And so I'm always talking to people about their natural language processing problems. And so I talked to a lot of people about text classification. It's come up a couple of times today already. And so if you're not an NLP person, text classification is exactly what it sounds like. Trying to decide whether email is spam or not. Trying to decide whether a piece of text has positive sentiment or negative sentiment or neither. Trying to decide whether a blog comment is toxic or whether a talk is worth attending based on its title or its abstract or its presenter, or whether a machine learning model is simple based on its description. So there's a lot of ways you could proceed. One easy approach might be logistic regression. Take each email, convert it to a feature vector somehow using like bag of words or one-hot coding or averaging word vectors, and then you learn some weights, one per feature. So that's basically like one parameter for each word in your vocabulary. So, that's reasonably simple. Another very classic approach is what's called naive Bayes classification. I don't want to go through the math, but you chop your email into words, you do some computation about how likely you are to see a given word in a spam email or not, and then you apply this Peepaw-Bebe theorem, and then you get it out. This is kind of the classical approach to spam detection. There's a chapter on it in my book. You could implement it yourself in an afternoon. And it, again, has like n parameters where that's the number of words. About 5 years ago, the state of the art would have been, this less dim tatsum model where you take your email, convert it to a sequence of embeddings, run them through this recurrent neural network, get a final state, classify that hidden state. This is now suddenly thousands and thousands of parameters for all these matrices that you're multiplying by. And, more recently you do a BERT model, which I'm using a shorthand for any kind of transformer model, where you take the email, convert it to a bunch of different embeddings, feed it to the transformer, get some pre-trained embedding as an input to the classifier, fine tune it. And now you're talking like hundreds of millions of parameters. And so, if I could see you and listen to you, I would ask you a question and I would say, which of these is the simplest approach to test classification? Logistic regression, naive Bayes, LSTM, or BERTs? And so there's no audience feedback, but I'm just going to assume that you're all voting for choice number one. So I don't know. I don't think there's a right answer. people can differ. But now here's a different question. Let's say you had a friend who was a junior data scientist and they needed to do some kind of text classification and they needed to get good results and their job depended on them getting good results. What would you recommend? And there, I know what the answer is. I would recommend that they use BERT. And I know that's the answer because I keep meeting people who are doing text classification using naive Bayes or logistic regression or XGBoost on TF-IDF vectors or other things that you don't even want to know about. And I'm like, why did you not just use BERT? And so it's not just that I tell them to use BERT, it's that I'm like, why are you like wasting your time doing the others? But then like there's this tension, right? Like on one hand, you have this angel on my shoulder saying, try the simplest thing first. And then you also have this devil that's like, why did you just not use BERT? And so, I felt like there was this contradiction there, right? And so what do we do when we feel like we have a contradiction? Well, you turn to Ayn Rand and she says, contradictions do not exist. When you think you have one, check your premises and one of them is wrong. So which of my premises is wrong? Well, let's take a step back. When we did that LSTM model, I said that it had thousands of parameters from these matrices that were multiplying things by and so on and so forth. But the reason that that model only has thousands of parameters is that it's kind of free riding off of whatever text embedding model you're using, glove vectors or word2vec. If you go and set out to download the glove vectors themselves, that's going to be hundreds of megabytes of data. So maybe those should count for part of the complexity of the model that, in this model, you have millions of parameters worth of data that choose which word goes to which vector, but most of those parameters are already fixed by the time you show up. Someone had to learn those vectors once, but then you can use them over and over again for different problems, just changing some parameters here and there. So they're a black box. It's not really part of our model. Do they count as complexity? They're pretty complex. Or do they count as simplicity because they move the complexity kind of out of our modeling and into the pre-processing, if you will. And so if we go back to BERT, you could also think of the BERT embeddings as a black box. So I think of BERT as something where I give it a sentence and it spits out an embedding. Okay. And now I take that embedding, use it as input to some simple classifier, logistic regression or whatever. And now I fine tune this. And that part of the model itself, that's thousands of parameters, not millions of parameters, right? And then I'm cheating a little bit because when you fine tune, you are like updating those BERT weights somewhat. So they're not quite a black box or like a gray box. But there's actually, outside of BERT computing those embeddings for you, there's not a lot going on. In fact, there's less going on there than in the fancy LSTM model. And what's more, there's also some hidden complexity in the simple models like naive Bayes. So, imagine you're doing this naive Bayes where I want to chop my email into words. Well, maybe I also want to consider phrases. So now I need to, look at n-grams rather than words. And maybe I want to filter out stop words. And maybe I would like to do some kind of stemming so that classifier and classification show up as basically the same word. Maybe I want to split out contractions. Maybe I want to do any number of things. And so, once you get into the mechanics of, I want to do a simple naive Bayes model on this, you have to make a lot of choices and you have a lot of degrees of freedom. And suddenly, if you include those degrees of freedom in your model, it's less simple. With, one of these transformer models, you just kind of shove the text in and it does with it what it does with it, to kind of go back to what we were talking about earlier about find methods that can cope with your dirty data and just ignore it. So this is a lot of clutter. So where do we find the simplicity? And I mentioned woodworking at the start, so now I'm actually going to talk about woodworking, and hopefully it will be relevant and make sense. So as I mentioned, in the pre-talk banter, woodworking is sort of a new hobby of mine. I only started doing it in earnest a month or two ago, but what I've been doing all year is watching woodworking videos on YouTube. In fact, I'm not bragging when I say that I'm pretty much like a savant at watching woodworking videos on YouTube. Like I'm really, I'm a 10x woodworking video watcher, if you will. As a woodworker, I'm not that good. I barely know how to use my tools, but I'm good at the watching videos. So now Imagine that you and your friends are like building a dining table, right? And so like these people, I think they're people, you have no idea what you're doing, but you know you don't want it to have these sort of ugly, simple, square legs. You want your table to be beautiful and have these complex tapered legs with, you know, nice slopes that intersect each other and that look good. And so, you know, one thing you can do, obviously what's the simplest thing you can do, and why do you not do that first, is you can go to Amazon and buy tapered legs. It'll cost you $175, but if you just want legs and you just want to buy them, then you can do it that way. It works, it's expensive, but it is an intricate and involved process. And there's a lot of ways that it can go wrong if you're not like a master craftsman like this guy. Like this is a video of someone, you know, making tapered legs. And he's really good at what he does, and he's got all these hand tools, and he makes his precise cuts, and you know, it turns out beautifully. But then you watch more YouTube videos, and you start learning about jigs. And so a jig is sort of like a tool that you build to take away some of your complexity. So this here is a tapering jig. I want to cut a piece of wood at a specific angle to a specific length. So I build this little frame that I can put my wood in. It has a stop so that the wood can only go in really one place. And it has another stop that holds the wood at exactly one angle. And you put a piece of wood in, you run it through your table saw, and you get the exact, you know, slope and size that you want. And it's repeatable and it always works. And so all you have to do is, you know, however many of these pieces you want, you shove a piece of wood in it, you run it through the table saw, and you try not to cut your fingers off, and, you know, you're done. And it's suggested to me that how simple something is not just how complex it is in theory, but also how difficult is it for you to try it. So, you know, if it's 2018 and you wanted to fine tune a BERT model, you were signing up for a lot of work. This is one of the examples. This is a text classification example from PyTorch pre-trained BERT, which was like the original precursor that became Hugging Face eventually. And if you wanted to make it work on your data, you were signing up for a minor adventure. This is like line 532 of the text classification example. And so, you know, many hundreds of lines of code. In 2022, if you want to fine tune BERT, like this is basically it. You import a couple of things from transformers and, you know, create a tokenizer, create a padding collator, create a model, train it, and train. And like, I've left out a few lines, but this is like basically it, right? These days, you know, in 2018, it was not simple to use BERT. It was not simple to fine tune a BERT model. Today, it is pretty simple to use a BERT model. And in fact, I would argue it's simpler to get good results by fine tuning a BERT model than it is to get good results with a simpler model. And if you just want like the pre-trained embeddings out of it, it's even simpler. It's basically 3 lines of code. You import from sentence transformers, load a model, and say encode my sentences, and you're done. So there's like nothing to it. So maybe when I talk about simplicity, I mean not just a model that's itself simple, but a model by which it's simple to get good results. So, you know, one other example that's slightly out of the ML data science space is sorting. Sorting algorithms can be really simple. You know, sometimes if you interview canonically, they'll ask you to implement, you know, bubble sort or merge sort or quick sort or whatever. You know, back when I was preparing for coding interviews back in the day, I memorized like every one known to man. Not that that's really done me any good. And Python uses an algorithm called timsort. You know, my guess is that most of you don't know how timsort works, because I don't know how timsort works. It's slightly complicated. It's not obvious. It's not a simple algorithm. And yet it's simple to use, right? So if you ask ChatGPT, what's the simplest sorting algorithm? It says probably bubble sort. And I think that's right. Probably conceptually, you know, if I had to explain it to my 11-year-old, I would pick bubble sort. But if you're working in Python, you should, of course, use the built-in sorted algorithm that you used to, unless you have like a super good reason not to, right? And then if you ask it, you know, is timsort a simple algorithm? It says, no, it's not a simple algorithm. But is it simple to use correctly? Yes, it's very simple to use correctly, right? Unless you have a comparison function like the other day in the advent of code, which it was less simple to use correctly. But anyway, the point I'm trying to make is that as our tools get better, the boundary between simple and complex changes. So how easy a solution is to implement and scale depends a great deal on the tools and abstractions you have for working with it. You know, with a tapering jig, it's simple to implement and scale making tapered legs. If you don't have a jig like that, it's not so simple. With the Python standard library, it's simple to use a stable hybrid merge insertion sort, which is what timsort is. In other languages, it's not so simple. So I saw an interesting tweet about this from the CEO of AngelList Venture. He says, why use AngelList to run a fund? He says, my answer, AngelList abstracts away all the complexity. So he said it was starting and running a fund. And so I found that phrase really interesting, right? It's not that it eliminates the complexity. The complexity can't be gotten rid of, but it abstracts it all away and gives you an API where for the most part, you don't have to worry about it. And from your perspective, it's much simpler. So sometimes things can be simple, not because they lack complexity, but because the complexity has been abstracted away. And so, I guess the lesson here is that as you're doing data science or machine learning or software engineering or data engineering or whatever, think about ways to abstract away the complexity. Sometimes that can be, just using pre-trained models and user-friendly libraries. Sometimes you might want to create your own shared project templates, crafting clean APIs, using engineering best practices and using shared processes. And then if you do that, you can use complex machinery in a NormConf way. So there's a survey that was floating around the other day about ML and AI practices where a third of the people said they were using natural language understanding, but only a third of those people said they were using transformers. And now, maybe they didn't know because they say, oh, I use Hugging Face on it. I don't know. But when I see that, I think, wow, that's, 2/3 of the people using natural language understanding are probably not getting as good results as they could with the same amount of work. So, you have my blessing to go import transformers and go nuts, and I won't criticize you. And even ChatGPT knows this one, right? If you ask it, what's the simplest way to solve a text classification problem? It suggests bag of words, but then it says another option is to use a pre-trained language model to generate embeddings for each document and then train a classifier for these embeddings. So, take it from ChatGPT. That's a simple way to solve the problem. This is one of the woodworking YouTubers that I follow. He put out a video pretty recently about making a simple, elegant table. And of course, I saw the word simple and it keyed with me. And he said, simplicity is something that sometimes we only discover through experience and with confidence. And that resonated with me, right? Knowing what the complex parts and the simple parts are is how you know how to abstract those complex parts away and leave yourself with something simple to work with. And so I'll leave you with a quote by Lao Tzu about abstracting complexity away. It's not really about that, but there aren't too many quotes about abstracting complexity away. Manifest plainness, embrace simplicity, reduce selfishness, have few desires. Okay, so manifest plainness, that means, don't put too many stickers on your laptop. There's too many, take them off. Reduce selfishness, that means don't hog all the GPUs, share them, other people need to use them too. Everyone needs to train machine learning models. Have few desires, I don't really understand this one. I don't know, someone can explain it to me later, I don't get it. And then, embrace simplicity, right? So, if there's a moral to this talk, it's maybe that simplicity isn't simple. Things that seem simple sometimes aren't, and things that seem complex might actually be a simpler choice. So thank you. I'm Joel. You can find me on Twitter. Everyone keeps saying that Twitter is dying. It's not dying. It's still there. It's the same as always, pretty much. So I'm still there. And that's that. And I will stop sharing my screen.
Thank you.
All right. Thank you so much, Joel. That was great. A lot to think about there. So you have some time for a few questions?
Yeah, sure.
All right. So, you said to turn to BERT, as a simple option to, import an NLP model. But are you really saying BERT, or are you saying any sort of Hugging Face standard NLP model to start with?
Whenever I say BERT in there, I mean a transformers model. So it could be, Roberta or Distilbert, any of those. I don't mean BERT, specifically BERT. It's shorthand for a BERT style model.
Got it. Cool. We have a question from the audience.
Okay.
So the question is, does regularized logistic regression qualify as a simple, trying to interpret this, unregularized logistic regression? That's the question.
does it qualify as?
I think he's asking, are they considered equally simple, or is one more difficult than the other?
Here's the thing. One, there's not like an absolute scale of simplicity where we can say this is simple and this is not simple. And two, like, you know, I'm not the simplicity czar, right? I'm just a guy who wrote a talk about simplicity. So obviously regularization is like slightly more complex as a process. At the same time, like it will get you often simpler models if you want to cut down on the number of variables you're using or prevent overfitting or whatnot. I don't have a real strong opinion about which one to call simpler, to be honest.
All right.
Okay.
Go ahead.
Randy, you got a question teed up, or do you? Okay, cool. So this is another one we got from the audience. So to Joel, how would you think about model lifecycle management, deployments, and model updates fitting into simplicity? It might be very difficult to manage inferences for an LM, for example, versus inferences from logistic regression.
Well, when you say manage inferences, do you mean it's like more computationally expensive to like generate the inferences or something else? Either way, like once you deploy it, your model is, let's say, a microservice that you send it something, it sends you back a prediction, right? And so, the process of managing that is the same in some ways, regardless of what's going on inside the black box, right? You send it stuff, you get a result back, you need to track like what kind of results you're getting and make sure that, it's behaving properly, the results are good, the inputs are not like drifting or whatever. But if the question is it computationally more intensive, it is. And I think that's a fair point as well. If you're doing something at like exceptionally high volumes, which I think most people are probably not, then, maybe it's too expensive to like leave GPUs spinning all the time and set up a cluster of them just to do your inferences. But, if you're doing batch jobs or if you're, a GPU machine's like $1 an hour. So it's not going to like break the bank if you have to leave a couple of them running.
Cool. So we have another question that someone's saying that they're using simple models like Logit, and they can control and iterate on the process, but some simple models that are easy to use are hard to iterate on. They're just, the levers are hard to mess with. So do you think that control over the process should be part of the simplicity question?
I can go both ways, right? Like one of my examples was about the naive Bayes and like all the levers you have about, should I do stemming? Should I remove stop words? And there are a lot of ways in which that really complicates your life, having to make all those decisions, right? Because, you do it and someone's like, oh, well, did you try using stop words? Oh, well, did you try this other stop word list? Oh, like it exponentially multiplies the number of things you kind of have to try, right? So for some problems, like having those levers is important, but for some problems, having those levers just is a time suck, to be honest. And it's hard to draw a principled line between when that is.
Okay, well, Joel, there are a bunch more questions for you in the chat if you're interested in engaging with them, but we've really appreciated you presenting today. Is there anything else you want to leave the audience with?
No. Thanks for listening. Thanks for watching. Enjoy the rest of the conference. Thanks again to everyone who put it on and to you guys for hosting.
Thank you so much.
Thank you. Okay. Well, we can now prep our next speaker, which is Peter Sobat, and his title is "It's All About Cost: How to Think About Machine Learning Products." So he's gonna take it away from here, and thank you, Peter.
Awesome. Thanks for the intro. Okay, hello everybody. Hello NormConf. My name is Peter, and as was just mentioned, it's all about cost. This talk is about how to think about machine learning products, specifically from an engineering perspective, to try and save money. So first off, who am I and why am I talking to you today? Well, my name is Peter Sobat. I'm a staff machine learning engineer. By day, I work on audio-based machine learning for all sorts of interesting purposes, trying to tell people how happy songs are or how energetic songs are, and doing all sorts of cool stuff with data and music like that. If you've been online on Twitter and you do audio-based machine learning or anything to do with audio, you may have seen one of the packages that I work on called Pedalboard for doing nice stuff with audio in Python. But Today, I'm not talking about any of those specifics or what I actually do day to day. Today, I'm focusing on how I tend to apply engineering principles to the world of data science and machine learning so that we can deploy things to millions and millions of users without breaking the bank. And I really want to focus on this word engineer first, because this is really where I'm coming from. I don't consider myself a data person or a data science person or anything like that. I've been working in machine learning for years now, and I have a good grounding in it. But when I really come from, my background is really more in what I would call traditional engineering. I was educated as an engineer, as a software engineer technically, but still at a school that really focused on things like engineering for bridges and engineering for roads and engineering for, all these kind of big structures that humans have been building for hundreds of years. Now, how does this relate to data science and machine learning? Well, engineering is really all about building systems that are, scalable, reliable, and come within cost and budget and things like that. And the reason it's kind of treated as a separate discipline, or it's something that people give a name to, is really that, these systems fail over time. And over the past couple hundreds of years, many of these engineering systems have failed, and we've learned terrible lessons about that. The bridge you see on the screen here is not actually just any bridge, but it's a bridge called the Quebec Bridge in the Canadian province of Quebec. And it fell down twice during construction. And we have this bridge to thank, or specifically the negligence of its engineers, for what we call modern engineering today. So if you've ever heard of some engineers having licenses or being professionally regulated or being members of professional organizations, specifically outside of tech, this is very common. And that's because this bridge failure and the corners that were cut during this bridge's construction really started the process of having engineering being more regulated and being treated like a very serious profession in a way. Fun side note, if you're a Canadian engineer like I am, when you graduate, you get a ring from this bridge, or supposedly made from the iron of this bridge, to remind you every time that you sign your name to a document, the bridge fell down, make sure you're doing this right. But I digress. This bridge really fell down because corners were cut and constraints for the problem were not well observed. Engineering fundamentally is about building the best thing that you can given the constraints of the problem itself. And many of these constraints are kind of obvious. So you got things like safety and reliability. You want anything you build to be safe and reliable. And others apply to really any project, not just engineering projects, like time and cost, right? We don't have infinite time to build a system. We don't have infinite budget to build a system either. So this brings me to the way that I think about engineering in general, and this applies to machine learning just as much as it applies to bridges. Anyone can build a bridge that stands, but it takes an engineer to build a bridge that barely stands. And this seems kind of flippant, and it is. But what this really means is it takes an engineer to build a bridge that is cheap enough so that it barely stands, right? It takes an engineer to build a bridge that meets the design criteria in such a way that it fulfills all of the things that we need to fulfill, right? It's not over budget. It doesn't take forever to build. And we can do it without bankrupting the town that asked for the bridge or the company that asked for the software to be built. In this case, think about the fact that the Romans built bridges thousands of years ago that still stand today, but they were extremely expensive even by their standards. And today we wouldn't do the same thing because we have costs to think about. So to finish off this little tangent about engineering and kind of where I'm coming from here, I want to compare two different fields of engineering. And that is civil engineering, where we're building bridges, and software engineering, where we're building, well, software. And that includes data systems and ML systems and whatnot. In both of these fields, one of the most important choices you get to make when you're starting a project is what material to use, or what tools, what frameworks, and so on to use. In civil engineering, this might be what you literally build your bridge out of. In software engineering, this might be what framework do you choose, or what language do you use, or things like that. And these all have different trade-offs and different costs and different amounts of performance you can get from them. In civil engineering, you might build your bridge out of wood, and that's great. It's plentiful. It literally grows on trees. Everybody knows where to get wood from. And in software engineering, the analog might be something like JavaScript. It runs everywhere. Seemingly everybody can write JavaScript. It's very, very common. It's cheap to build, but it might not be as powerful as you want it to be, or it might not be able to do certain things that you want your software to do. In civil engineering, you might use iron if you want to build a bridge that's a bit more sturdy than your wooden bridge there. And in software engineering, maybe we would choose Python. Again, a little bit more expensive, maybe sometimes harder to build, but gives us more performance. Continuing down the list, you might use steel to build your bridge if you really want something that is very performant or very sturdy. And in software engineering, maybe you want to rewrite your code in C++ if you want to make it even faster to run, or to run in certain scenarios where Python is just too heavy or too slow, but it takes a lot longer to write your code, so it's more expensive. And then continuing to the very bottom of the cost here, or I guess the most expensive options. In civil engineering, there are new materials that people are using all the time, one of which, for example, might be carbon fiber. You wouldn't build a whole bridge out of carbon fiber. That's quite expensive to do. But for certain applications, carbon fiber really gives you a lot of strength, and it can do things that other materials cannot do. And the equivalent here in software engineering, in my opinion, is machine learning. It's like the carbon fiber of bridges. You don't want to build an entire bridge out of carbon fiber. You wouldn't want to build your entire project out of machine learning, but it's got some very, very nice properties. And if you're willing to pay for it, it can do some things that other materials cannot. So if machine learning is the new expensive tool that everybody wants to use, then how can we use less of it in order to save money? How can we still get the benefits of machine learning, but not have to put it everywhere in our product and use it as minimally as possible to still make it economical to deploy? That's basically the entire point of my talk today. So let's dive into this. Congratulations. You and I, everybody on this call, we all now work at a new company. And this company is called Video Chat Inc. It's actually the video conferencing platform that we're using right now to host this conference, and it's how you might talk to your coworkers every day. This fictional company is the world's most popular video conference platform. And we are engineers or data scientists or machine learning people on one of its engineering teams. And we've been tasked with building interesting new features for video chat. One such new feature just came on our desks right now, and it showed up as this RFC. The business people and product people at Video Chat Inc. want us to build a coffee brand detector. Now, what that means is they want us to build a system such that on each video call, Video Chat Inc. can automatically detect the brand of coffee that shows up in video calls, and then automatically put a button on the screen so users can reorder their coffee and stay caffeinated without even leaving their seats. Sounds like a pretty lofty idea, but it also sounds like something that isn't impossible to build. So we might as well get started here. Now, if you're a machine learning practitioner, as soon as you see something like this, you might start to think of ways to implement it. You might jump in and say, well, I could use an object detection model. I could use PyTorch Vision or ResNets or any things that you've seen online or in the community. And that's great. But coming from an engineering perspective, that's like someone telling me to build a bridge and me saying, well, I'd love to build that bridge out of wood, even though I don't know which river it's going to cross or how many people need to be on top of it, right? We don't need to use our tools anywhere near this point in the process. We should instead figure out what this project needs and what the requirements are. So let's do that. Let's say that we've worked with the product team and the business team to figure out the actual needs here, and we've come up with a list that we can use to start building. This does sound kind of waterfall-y and less agile maybe, but for a big project like this, we need at least some guidelines to work within. So we've come up with these requirements, and I've split these requirements into two different lists. Now, they're in two different lists because this is a technique that comes from more traditional engineering. We've got one list called functional requirements and another called non-functional requirements. Now, the functional requirements are things that we need to make this system work in the first place, right? So this functional requirements list is how we judge if the system is done, if it's been built yet. And then non-functional requirements are ways that we can evaluate how well we did or the quality of the final system. So regardless of if it works, was it cheap enough for us to build, or is it fast enough if it's a software system, stuff like that. So our fictional system here is going to have a couple functional requirements. We need to be able to detect the top 10 most popular coffee brands that show up in people's video calls. We also want to be able to detect the brand of up to 1,000 users of the system per day. So that's our load. That's kind of our scope here. And then also our system must have a precision of at least 99% and a recall of at least 90%. So these numbers are kind of just picked out of thin air, but we can try to build a system that does have these numbers. And then for non-functional requirements, well, we want the system to cost less than $100 per day, which is quite a tight quite a tight cost bound, but we definitely want to make sure that we respect that because that's going to determine if we can deploy this or not. And the system must provide data by the end of each day. So it doesn't really matter exactly how quickly or how slowly it works, as long as we give the results to the business about the end of each day. So with those requirements in mind, let's do some engineering. So big disclaimer first, the following calculations are incredibly oversimplified to make a friendly and digestible point in a 20-minute talk. Do not depend on these numbers. You might find bugs in them. You might find miscalculations. But given that, please continue to suspend your disbelief for the rest of my talk here. So following from Joel's talk that you just heard from, let's start with the simplest thing that might possibly work first. Let's have a tip number 1 at the bottom of the screen here. Let's just run machine learning on every single frame of the video we get in real time. So we get frames coming in from our customers, just like what you're seeing right now. Some of these frames have coffee cups in them and others don't. And let's say we pick an object detection model off of GitHub. Someone's already pre-trained one for us, and it has the required accuracy that we're looking for. Let's just run that on every single frame of video in real time and take the outputs and put them into some sort of aggregation tool for later. Now, I'm going to do a bunch of back of the envelope calculations here on the left-hand side, and I'm going to fill up with a bunch of numbers, but don't be too scared. I'll talk through every single number as we go through. We know our daily compute budget is $100, so that's what we want to be underneath here. And we know we get in 30 frames per second of video from each user. We also know that this PyTorch model we have here, well, let's say we've measured it and we found that there's a certain number of floating point operations we need to do in that model to process each frame. From our measurements, that turns out to be about 40 billion floating point operations, which sounds like a lot and kind of is a lot. But multiplying these numbers out tells us that we need about 1.2 teraflops per second of computing power to process these videos in real time and give us results. That's actually kind of doable on modern GPUs. This is not too out of the ordinary. Then we also know we have a maximum daily load of 1 million users. We know that we have about 4 hours of daily usage per user. People are on this app all the time because they use this to talk to their coworkers and they spend half their days in meetings, or at least I do. And then that multiplied out means that our daily hours of video is 4 million hours per day we need to process. So that's quite a bit of video. Then multiplying that by the number of teraflops per stream, well, that means we need 17.3 zettaflops or zettaflops. I don't know how to pronounce this number, but it's a lot. And we're going to have to use that to estimate our cost here. So let's say we have GPUs available in our cloud of choice, and we're using the cloud here. The flops available per GPU turns out to be 8.7 teraflops. And dividing those two numbers, we need 551,724 GPU hours per day to make this work. That sounds like a lot. But let's suspend our disbelief here and say that we can get that amount of GPU capacity, and we just have to pay for it. Looking at our price sheet here, let's say our cost per GPU hour is 45 cents, and that means our total daily compute cost is only $248,275 per day. That's $250,000 per day. I don't know about you, but that's not viable for any environment I've ever worked in. And if I presented that to the folks who asked for a product like this, they would probably laugh me out of the room and find an engineer who can build a system that actually works. So let's see which numbers that we can change here. What can we look at to make this system cheaper without sacrificing our functional requirements like our accuracy and our load and such like that? Well, to start with, we have the number of frames per second that we're processing here. We're processing every single frame of video right now. So attempt number 2 might be something as simple as just run the ML on fewer frames, right? Just run ML on some of the frames. Don't even change the model just yet. Let's just subsample the stream. And I know this is a big if. We don't actually know if this is going to work, but I'm going to guess that if you're drinking coffee, you can't raise the coffee cup to your mouth and take a drink in less than 1/30th of a second. It's going to take longer than that for you to actually take a sip of coffee. So this assumption might have to be tested offline, but let's run with it. This reduces our frames per second to 1 frame per second, and then our per stream compute is now 30 times lower, so only 40 gigaflops. Across our entire user base, the number of daily flops required is a much more pronounceable 576 exaflops. And that means the number of GPU hours required is actually within the realm of possibility. We only need 18,400 GPU hours, which could be done with a large GPU cluster maybe. And at the cost of 45 cents per GPU hour, this only costs $8,280 now. So we're down from $250,000 a day to just less than 10,000, which is still quite a lot and almost 10 times our budget. But it's gone from being completely inviable to maybe we could kind of do this. But let's keep going. What else can we do to make this cheaper and find a solution that optimizes for all of our constraints? Well, let's take a look at the number of floating point operations per frame that we're running here. We've got this PyTorch model that we pulled off the internet. It works, but can we make it faster? Can we make it smaller? And this is where I'm going to, I know this is NormConf, we're not talking about papers, but I'm going to show a paper on the screen. I'm so sorry. 1 second here. It'll be only up for a second, don't worry. So this is a paper from Google from 2017. It's called MobileNet, and it presents a class of efficient models called MobileNets for mobile and embedded vision applications. Now, what these researchers have found is they can change the model architecture they use for object detection and spend 1/10 of the computing power for only a small drop in accuracy of a couple percentage points. if we use this architecture or any similar cheap architecture to run our model, we can potentially get huge gains in cost or huge savings in cost without significantly affecting our performance. So let's do that. Let's say that we've retrained our model. We still have video coming in here, but let's retrain this model with a more efficient architecture. Now, let's deploy this with something a little more optimized for cost. Let's maybe use TensorFlow Lite, and let's deploy this as a mobile net on our backends here. And each frame of video is still giving us the same outputs, but we only need to spend 4 billion flops per frame instead of 40 billion. That reduces our per stream compute to 4 gigaflops per second, which is much more manageable. Again, down by a factor of 10. Our daily flops required is 57.6 exaflops, much better. GPU hours is now only 1,840. And that means our total daily cost is $828, which again, still a lot, still almost 10 times our cost budget, but we're getting really close here. Our viability is, within a stone's throw from what we've got now. But what can we do next? What's the next thing we can turn to? Well, I see one number in this list that's a little bit suspect, and that's the number of floating point operations that a single GPU can do. This number seems low to me because GPUs get more powerful every single year. And if we were to simply upgrade to more expensive, more modern GPUs, we might be able to get much more performance per dollar here. So let's try that. For attempt number 4, let's use more cost-effective GPUs. And if I pick the most advanced GPU on the shelf right now, I can get 312 teraflops per second instead of 8.7 per GPU. And that means we only need 52 hours of GPU time per day instead of those thousands we had before, even though these GPUs are more expensive at $2.93 each rather than what they were before. And this reduces our cost even more. This means our total daily compute cost for all this GPU time is only $152, which is great. This is amazing. This is only 52% over budget, which for many engineering projects would be a slam dunk, a huge success. But we can go even cheaper. What do we do to get down from $152 to almost $0? Well, I have a proposal here. What if we take this model we have here and we were to make an even cheaper model, even faster model that is way, way, way less accurate? I know we have accuracy bounds. We want a certain amount of precision and recall here. But what if we retrain this model, use some transfer learning and build our own copy of it that is wrong a lot of the time? We can get our per stream compute numbers down here by a huge factor if we just pre-filter some of our data and only deploy our more expensive model on frames that we're reasonably certain already contain coffee cups. So let's do that. For attempt number 5 here, let's use a 2-stage model architecture. So let's take our original model, let's retrain it so that it gives us a huge amount of recall. It catches almost all the coffee cups that do show up in frame, but it's not very precise. Sometimes it'll think that a cell phone is a coffee cup rather than an actual coffee cup or a cell phone. But this model here is much cheaper. It only requires 100 megaflops per second, and it could even run on CPUs, which is great. So we're almost done here. Let's take this and drop this into temporary storage. So the outputs of this model go in there, and then we run a batch pipeline and then drop the results into MobileNet. And then there we have our full precision output. If I race through all these numbers here, because I know I'm almost out of time, this reduces our cost all the way down. We only need to run our heavy model on 0.0001 frames per second. Our offline computing power is in the kiloflops instead of the teraflops. And multiplying all the numbers out, we get to $0.01 or 1 cent. Of course, I'm ignoring a bunch of overhead here, but we're pretty much good to go. And that's all I've got. We talked about 5 things: how to do the simplest approach first, how to process less data, how to make our model smaller, how to use more efficient hardware, and then finally, how to split up our model and use cheap ML to pre-filter our data before applying the heavy ML. And thanks so much for listening. I'll stick around for questions, but that's my talk. Thanks, NormConf.
Awesome. Thank you so much. And we do have questions somewhere. Should I find them? Ben, do you have to have the questions up? Because
absolutely. We've got some questions for you, Peter. They're in one of my screens, and I have 15 of
getting lost in tabs. Okay, so there's one. I see one question here. So, what are, aside from GPU time, what is like the most expensive cost to consider when running these giant ML models?
Yeah, that's a good question. I definitely skipped over a whole bunch of overhead and other stuff like that. the gist is that GPU time is a large cost, but you also have to think about CPU time for all these models, right? How do you get your data onto the GPUs, network communications, all sorts of other stuff like that, right? GPU time, once you optimize your model enough, might actually turn out to be a small fraction compared to the rest of the system. But yeah, hopefully using techniques like this, you can get the GPU time, which is usually the biggest thing, to be much, much cheaper, and then focus on the boring stuff like CPU, network, and so on.
Cool. I've got another one here. Someone's talking about the two-stage approach that you kind of showcased, and was asking, like, okay, setting up all these pipelines and all the complicated interactions between them, is there a way to like set these things up without spending tens and thousands of dollars worth of engineering person hours building all that infrastructure?
Yeah, I mean, that's an interesting point. I mean, a theme that I've seen in many talks that have either already happened or will be happening for NormConf is that, like, you don't need to build complicated infrastructure. You can basically just build the simplest thing that works. And for a lot of things like this, like the suggestion that I had there about taking frames that contain coffee cups and putting them somewhere else and then running ML on that, that could be as simple as throwing those frames into an S3 bucket and then having a trigger on that and running a Lambda function or something like that, right? It doesn't need to be a really, really complicated solution that requires a lot of engineering time. It could be the simplest thing that works, and then you continue to optimize by looking at each piece independently and getting the cost down there.
Cool. So GPUs, like you were showing how like getting the latest GPU might very often increase the price efficiency, right? Like Moore's law being what it is, it doesn't seem to be affecting GPUs as much because they just make bigger dies. But today, like, is this generally true that like it's probably a safe bet for the next year or two that getting the latest chip is probably going to save you money, and so you could. What I'm saying is you can probably not consider like the 5-year-old chip or the 4-year-old chip, right? Like that's probably not going to be cost efficient.
Yeah, no, that's a good point. What's interesting is that many GPUs that are kind of older are discounted on cloud platforms. So you might still have to do the cost efficiency calculations yourselves because it might look like a GPU is cheap and abundant, but then per floating point operation or per capacity, whatever it is, it's not as good of a deal if you can really saturate a bigger GPU. One big point I left out of all of this is that this assumes 100% GPU usage, which is almost never going to happen. But assuming that you're able to optimize in some way, I don't know how much runway we're going to have though. Like, our GPU is always going to get faster year over year. I hope so. And so far they've been doing a pretty good job at it. But I guess the point is really more, don't use GPUs that are 5 years old. Like, use a 1-year-old GPU or maybe a 2-year-old GPU.
So theoretical question from the audience. What if you ran your models not on your GPUs, but on the customer's devices? Like, what if you just distributed it there?
That's a great idea. And actually, I was going to talk about some of that. I cut a slide for time here. It's definitely possible. If your customer's devices can be relied upon to have a certain level of compute power, and if your models are something that, you're not going to cause their fans to spin up or the batteries to drain, and it's something that brings them value, then of course, yeah, go ahead and deploy that on device. I will say, there are a lot of gotchas around that. It can be very, very difficult because everyone's device is different. If you're deploying to mobile devices, who knows what everyone's got in their hands? There are thousands of Android devices and so on. But in general, yeah, that could get your costs down even more if it's a model that customers would appreciate to run locally.
So you're talking about like the idea of like edge devices, having these processed on people's phones and what have you. And then there'd be that alternative option, which is just like if the customer has GPUs, you could run on them. Right?
That's true. Yeah, I was assuming edge devices like we've got a chat program or something like that here. But if a customer had a GPU cluster, that'd be cool. I would want to work with that customer.
No,
everyone's phone has a GPU, just bolted onto it. And
I was just thinking, I'm like, yeah, that would be cool if my phone had a GPU. I don't know. I actually personally just bought like a GPU because I want to start running these things on my own. But there's that calculation. I was thinking in your talk about this idea of like trying to you're optimizing a number of different things, but like part of me is thinking, if we all just had our own GPUs to run a few of these things, that might be easier. But of course, it's costly, and then there are all these people who are mining Bitcoin or whatever. do you foresee a world in which that's sort of distributed out there, or I don't know?
Absolutely. I mean, it depends on the amount of computing power we're talking about here, but even like a modern laptop or a modern phone does have a GPU in it that is usable for many interesting ML use cases, right? You might not be able to run Stable Diffusion on it efficiently or ChatGPT or something like that, but that's not out of the realm of possibility at the speed we're advancing. And if you have a smaller model that does something like object detection, like what I've been talking about here, you could definitely run that in real time on a phone nowadays. It's not out of the question.
Today I learned. That's awesome. All right, Peter. Well, there are a bunch of questions that you might, have in the Slack if you want to stick around and answer those, but we don't want to take your time forever. Are there any kind of parting thoughts you might want to provide us as we end your talk here?
Not about my talk, but really just a huge thank you to all the organizers. This has been an amazing conference so far, and the energy is addictive. I can't wait for the next one.
All right. Thank you so much.
Thank you.
See y'all.
Awesome. That was a lot of GPU talk, and I can always re-justify my GPU purchases by saying I'll play some games on them. But speaking of GPUs, we do have a sponsor we'd love to call out. The company Lambda has given a lot of support to this conference, and they have a public GPU cloud offering, so that and you should, if you're interested in using GPUs, probably they've got a channel in the Slack that they're talking about their stuff. There is some talk about free credits in there. I haven't seen the details, but hey, if you want to, not buy a GPU but use some GPU time, they're a place to look at. Thank you very much for their sponsorship.
Yeah, thank you very much. There's, why buy my own GPU when I could have been using Lambda? I should have thought of that, right? But then again, I mean, Helena's talk kind of inspiring. I kind of wanted to just do what she does. So
own the means of production.
Don't get me started, Randy. This is a conference. I don't want to.
All right.
Okay. All right. So we got another speaker coming here who's going to talk about some great stuff. So do you want to introduce our next speaker?
All right. So our next speaker will be Jeremy Jordan, and he will be talking about ML doesn't always replace rules. Sometimes they work together. And Jeremy's here with us. Welcome.
Hello, hello.
Hello.
How's it going?
Hey, Jeremy.
Glad to see you all here. Let me just pull up my slides real quick.
You might not be aware, but Jeremy not only is a speaker, but he is also an organizer for NormConf. So, we appreciate him.
Mm-hmm.
Yeah,
right.
It's been fun putting it all together. Okay, perfect. I will go ahead and get started.
Take it away.
Awesome. All right. Hello, NormConf. My name is Jeremy Jordan, and I'm a machine learning engineer at Duo Security. And as been mentioned, also one of the organizers of the conference. So thank you all, everyone, for coming out. Thank you all to the speakers that have given some wonderful talks today. It's really, really exciting to see everything coming together. So today I will be talking about machine learning and rules engines and how they can work together. So let's start by walking through the life cycle of a typical machine learning project. Let's pretend that we work at an email company and a product manager comes to us and says, hey, users are complaining about spam. Can you filter out those messages? And so we say, yeah, sure thing. And we get to it. So where do we start? The kind of like the standard advice is to start with a rule-based approach and deploy that into your product. Like this is literally rule number 1 on Google's great guide to machine learning. And there's a good reason for that. And that's that, machine learning requires ideally labeled data. And we don't necessarily have the luxury of having that at this stage. So instead, we spend some time to get familiar with the problem and build up some domain expertise that we can encode into a heuristic. So we can start off by writing kind of just a simple rule that looks for spammy keywords in the email body and then deploy that into our product. And now that we've rolled out a spam folder into our product and are using that heuristic that we just wrote to decide which content should be placed in that folder, we can start to observe user behavior. So we can see when users move emails into the spam folder. And we can also see when users move emails out of the spam folder back into the inbox. And just like that, now we have a labeled data set to work with. So now we're cooking. We have labeled data, a better understanding of the problem we're trying to solve, and we can go ahead and replace that simple heuristic with a smarter machine learning model to identify spam. So we'll take that data that we observed from user interactions in our product, instantiate a model, fit it to our data. Great. Now we have a model that we can use to replace that heuristic that we deployed in the first iteration to now improve our product. However, I've learned that it doesn't always work this way. And specifically, I've been working in the field of cybersecurity for the past 5 or so years. And working as a machine learning engineer, just for some context in cybersecurity, I've mainly been focused on threat detection tasks. So this is things like detecting phishing URLs or malware attachments in emails, and trying to identify when bad actors might be trying to log into your accounts. And threat detection exists in an adversarial environment. As we get better about detecting and blocking malicious content, threat actors find new vulnerabilities to exploit. This means that the threat landscape is constantly changing, and we need to be able to keep up with those evolving threats. And spoiler alert, this is typically done using both rules and machine learning, since they each have their own unique advantages, which I want to touch on. So let's talk a little bit about rules. Rules are honestly pretty great. They allow us to directly encode our domain knowledge about threats and the threat landscape in the rules that we write. We can also easily update those rules to fix false positives quickly when like a customer complains about something getting blocked. Hopefully you haven't experienced this personally, but blocking benign content can be very disruptive, and we definitely want to be able to make sure that we can remediate those false positives quickly after we learn about them. Rules also allow us to react quickly to new threats. We may learn about a new threat through a research briefing and want to provide protection against that threat before we actually see that threat in our product data. And if you're curious how that might work, a lot of research briefings will include useful information they call indicators of compromise. Think hashes of known bad files, for example, that we could use to quickly write a rule. So, just to give you an example, here's a recent threat research report on some new malware variant, along with some of the file hashes that we could use to detect known samples. And then finally, rules have interpretable logic, which makes it easier to understand and fine-tune the rule. And we can look at a given rule and kind of reason about why it classified a piece of content a certain way. But machine learning is also pretty great. It's much better at generalizing to unseen data. And this is useful in a variety of settings. I've built threat hunting tools that leverage machine learning and semantic search that let a threat researcher say something like, here's some malicious content that I'm interested in. Can you show me similar examples? Or maybe, can you show me examples that have this particular aspect in common? And this can be very useful for tracking the evolution of malware, for example, over time, as those files evolve and are changed to try to evade detections. These models can also be useful for, kind of just being able to learn more nuanced, complex decision boundaries than rules might be able to, and allow us to discover new threats when we're using them for, classifying malicious content. And part of that's because, as I mentioned, we're often very sensitive to false positives. So we have to write, when we're crafting rules, we have to make sure that they're very high precision. So those rules can usually end up carving out very narrow areas in feature space. So sometimes my mental model is a model can help fill in some of those gaps. And another nice thing about machine learning is we can automate the process of figuring out the proper detection logic. So this is simplifying things a bit, but like, as long as you have a labeled data set, you can kind of let computers figure out the rest as far as like classifying that malicious content goes. And then that aspect becomes very powerful as we continue to collect data from product usage, as it enables us to easily retrain our models and improve them over time as we collect more data. And that's one thing that you can't really do with rules. You can't necessarily take recent product data and call fit on a rule to make it better. And then finally, I'd argue that the maintenance costs scale better than rules. The maintenance cost for machine learning scales better than rules. I think rules can be great for simple logic and capturing low-hanging fruit, but you can reach a certain complexity where it starts making a lot of sense to leverage machine learning. And so from another perspective, just to kind of like help visualize this, if we were to look at a precision recall curve, one of the ways I think about this is kind of rules helps us capture some of the low-hanging fruit and capture threats that are easy to express in a rule. But adding in machine learning to the mix, we're able to kind of push out that Pareto frontier and detect more malicious content. And again, when we're making blocking decisions based on threats, we have to make sure that we have extremely high precision. So in practice, adding machine learning models to complement the rules really helps us kind of like push out our recall and stop more threats from causing users harm. But ultimately, these two systems are strongest when they're used together. And I think that that's the really important point that I want to emphasize here, is that each of these two systems have different perspectives on the data, and combining those perspectives gives us a unique vantage point. We're able to look at subsets of the data where the model and rules agree, as well as highlighting subsets of the data where the two systems disagree. And those disagreements or discrepancies are a really useful tool for triaging human review of data, where we can investigate and go in and attach like a ground truth label to that example. So for example, we can look at a mocked up discrepancy feed here, which compares the outputs of a rules engine and a model prediction. And we're able to surface data where the two systems are disagreeing. Humans can then come in and review this discrepancy feed and attach an ultimate ground truth label to resolve the disagreements and improve the individual detection systems. So for example, we have a row here where the rule classified the data as malicious, but the model said it was benign. And after human review, we concluded that it was in fact benign. In this case, we now know that we need to go fix that rule to reduce its false positive rate. And then in this case, we have a rule also classifying a piece of content as malicious, where the model says it's benign. And after human review, we concluded that it is in fact a malicious piece of content. And so we'd want to take that example and maybe some other similar examples, make sure they're all labeled, and then include that in some of our training sets so we can retrain that model and improve that model's performance. Ultimately, to build kind of an effective threat detection system, we need to have a layered defense. And this includes some manual effort, kind of exploring the data and hunting for threats, developing rules to encode our domain knowledge of the threats that exist, and training models to help scale our detection of malicious content. We can leverage discrepancy feeds to help improve our rules and machine learning models. And ideally, we can also capture user data and feedback and incorporate that data in our model training as well. So hopefully you can start to gain an appreciation for the values of both rules and machine learning in a threat detection system. And one topic that I've been thinking about a lot lately is how we can make this all work well together. So I'll talk through a couple things that I've been thinking about here. The first is being able to package rules and machine learning models such that they look similar at inference time. And this allows us to easily start with a rule and deploy that out for a given threat, but just as easily introduce machine learning models kind of in parallel as we've collected more labeled data into our detection stack as and there's a really cool library by one of our NormConf speakers today, Vincent, called Human Learn, which basically lets you craft rules and wrap that into a scikit-learn interface. So if you're at all interested, I highly recommend you check it out. Vincent has some great examples and documentation to get started on that. And I think it's a very interesting kind of like library and approach to making inference look the same. I also think it's incredibly valuable to be able to track and evaluate these models and heuristics using common infrastructure. So after writing a rule, you should be able to run it through an evaluation set and capture important metrics for that model at the time that you authored that rule. And then after training a machine learning model, we can run it through that same evaluation set, capture those same important metrics that we care about. And all of our experimentation data and context can easily be stored and discovered in a single tool. And then this can also carry over into something like a model registry, or I guess in this case, a model plus rules registry, where we can link artifacts back to all the data that we have in our experiment tracking system, as well as have a kind of centralized control plane for rolling out new artifact versions to production. And this can be really useful in quickly answering questions like, what models are deployed right now? Did we make updates to that one heuristic? And this detection rule seems to be firing a lot. How often did it fire, like in our evaluation set? And then finally, when we have multiple systems making judgments about a certain piece of content, we need to be able to combine those outputs into a single decision. So this concept of a policy layer, which is kind of responsible for defining how those outputs should be combined, becomes important. And in some cases, the policy might be super simple, like just a logical or statement. So if any subsystem classifies a piece of content as malicious, then we'll go ahead and block it. Or in other cases, you might have some more complex logic here, such as scenarios where you may not trust the machine learning model's output. Like maybe that machine learning model has low certainty on a specific piece of data, and you want to be able to fall back on the rule system's output. Or let's say the machine learning model has a false positive that a customer reported, and you want to be able to very quickly remediate that. You might want to be able to override the model's prediction for that specific scenario in the policy layer. And ultimately, I think as we take a step back to kind of look at the big picture, machine learning exists as a part of an overall threat detection system. So if you were just listening in to Peter's talk, I thought it was a really great point about kind of like, machine learning is the carbon fiber material. And you wouldn't build an entire bridge out of carbon fiber, but it's a very useful material that you can use. So in my experience, I haven't actually seen the scenario where we replace some initial rule-based logic with the machine learning model. Instead, the two systems, at least for threat detection scenarios, the two systems kind of work together in a symbiotic fashion. All right, that's all I've got for today. I hope you found it interesting to kind of learn a little bit more about the world of threat detection and how rules and machine learning models can work together to improve the overall threat detection system. Thanks for listening, and I think we have some time for questions now.
Yep, we do. And you want to
Wow, that was
us?
great. Yeah, I mean, thank you for the talk. I'm going to start off with a serious one for you. I don't want to trip you up just yet. Okay, so we have a question from the audience. One of the questions from the audience is, have you looked into algorithms that generate rules from labeled data? Bayesian rules lists, for example. They allow for an enviable feedback loop with all other advantages of rules.
I will say I've looked into it a little bit. I haven't dove too deeply into the whole world of Bayesian statistics, and I'm sure there's a lot of really cool things to learn there. I guess I should probably go take one of the courses from one of our sponsors, Intuitive Bayes, and learn more about it. But yeah, I also think there are some models that, you can kind of look at as like encoding a rule, like, like a decision tree that we train. And rules look very similar to that. I think for like kind of as I mentioned, that the two different systems kind of serve different purposes. So when we're expressing things in a rules engine, that's usually like information we know about threats that we want to encode into our system. But then being able to just like chuck a bunch of data that we've collected into a machine learning model and see what it churns out gives us a really interesting perspective as well. So yeah.
Cool. So I've got a question here. Someone's asking about rules versus rules engines, right? They're sometimes talked about in different ways. And is there an actual like semantic difference between these, especially like in a business context?
Yeah, that's a really good question. I can talk about how I use the terms. I don't know if it's generally correct, but I basically think of a rules engine as a thing that executes rules. So like, an analogy into machine learning is you might have like a machine learning model and then like a model inference server that takes that trained artifact and like actually executes like, you pass in the input data and it returns the results. So one of the differences between machine learning models and rules is like a lot of times you might have like one machine learning model. Like we might deploy like a random forest model that's good at detecting a certain type of thing. But for rules, like you would have a whole set of rules, especially since I mentioned like these rules need to be kind of like very high precision rules, to have a set of rules that kind of like focus in on certain things and capture different areas or like aspects of the data that we might flag as like malicious. So when I think about a rules engine, it's basically like, okay, I have this pile of rules, I have some data, I want you to run all of those rules across this data and tell me like which rules fired on that.
Okay, yeah, that checks out. I have another question for you, and that is from the audience as well. And it's this. So the question is, in your experience, are people who develop rules and models, are they the same people or different? For example, operations and domain experts versus data scientists. I actually had that similar question as well. I might, phrase it a little differently, but along the lines of like, yeah, you're kind of implementing the rules, but like I've been in situations, and maybe you've been in situations where it's like, oh, the people who are like at the ground level might have this context that I don't have. So do you do any like user research to like determine some rules that might not be readily available in the data or anything like that?
Yeah, definitely. So I think kind of like the best people that can author these rules are threat researchers. And, if you're not familiar with kind of like what is a threat researcher, their job is keeping up with recent threats, trends and what various threat actors are doing, and like basically hunting for threats all day. So they're looking at like the product data that we collect. They're looking at blog posts and Twitter posts from various people in the threat research community. It's a fairly open community. So like once one threat research team identifies a new threat, say some new malware, they will typically write a blog post and talk about that. And that example on one of my slides was an example that I think was published just like a couple days ago of a new malware that we've seen, or that the threat researchers have seen. So I think like the best setup is when you can have threat researchers that are keeping up with the threat landscape. They're the ones that are like truly the domain experts, and they're able to author rules. And then having some like kind of like a complementary team that works very closely with the threat researchers that might have like just a little bit more expertise in like how to train models and keeping up with that, both communities, like the threat research community and the machine learning community, like there's just a fire hose of information to keep up with. So I think it's valuable to have people that are kind of keeping up with machine learning as well and able to, work with that data and, fine tune models. And there's definitely really great collaboration points, and like learning from the threat researchers can give a ton of inspiration as to like how you might do some feature pre-processing for, if you're like training a random forest, for example.
Follow-up question to that. So it sounds like you're saying that, like, are there a bunch of people who are like protecting the world and from threats, and they're just writing blog posts, and then you all have to find them? Are they being paid, or is this open source, or what's going on? Do we need a num focus for security researchers?
Yeah, no. So, so these are people that are generally like employed at cybersecurity companies. So like that is a common role across cybersecurity companies is to perform threat research and make sure that, their respective cybersecurity product has protections against those threats. But we also care about, at the end of the day, we definitely care about protecting our customers, but we also care about just like protecting people in general and making sure that nobody gets susceptible to those threats. So I found that the threat research community is generally like pretty open and open to sharing so that we can kind of help each other out.
All right, very cool. If you want to take down your slides, that way we can all see each other, we can do that. I've got a few more questions for you. Thanks. Okay, so here's another one for you. I don't mean to pepper you with questions, but we have the time and the people are curious. So the one question comes from the audience and it says, is human learned used in production on your end? That's the question.
It's not. It's something that I like sent to a coworker maybe about a month ago. I was like, hey, this looks really cool. We should like look into it and see if we could use it. So I think it's been a busy month. But we're planning to have a little like research day where we can really dive in and like start using the library with like in the context of our work and see how it might be useful, or like a similar idea.
Okay, so here's a fun one. So when Vicky was organizing the conference with us, she had to buy a bunch of gift cards, and like those gift cards were like, I don't know, $100. And then her bank like contacted her and was asking if she was up to something nefarious or if she was a bot. Are these the type of rules we're talking about? And did you write those rules?
I did not write those rules. But yeah, like I kind of work in the land of threat detection. Fraud detection is like right next door. And I imagine fraud detection architectures look very similar, where you have this combination of rules as well as some machine learning models that are looking at all those transactions and trying to kind of identify like which transactions are authentic and which might be, somebody compromised somebody else's account and is just trying to make a heyday.
All right, well, we just kind of had to ask. If you have any questions, I've got some more queued up, but if you want to ask any, please feel free.
Oh, you asked all the ones that were on the list. But so let's see here. Oh, I think there's one here.
Okay.
All right. How do you organize whom should review and flag discrepancies between rules and models? Like, who reviews the reviewers?
That's a really good question. I think in an ideal world, you actually have multiple people that are reviewing that. So you kind of can like look at labeler agreement or disagreement. That obviously has cost associated with that. Like if we have a fixed human time budget, then forcing multiple people to review the same content means we can label less content. So I think usually what happens in practice is like, it depends on your confidence about a given label. So, if you're looking at some data and you're like, okay, I'm very confident that this is in fact malicious, or this is in fact benign, then it's easy enough to go ahead and label that. But I've had scenarios where like, somebody's looking at inspecting a piece of content and is like, man, I'm very perplexed, and we'll like share it in a Slack channel. Like, okay, what are everyone's thoughts here? And sometimes the investigation rabbit holes can go very deep. But yeah, they're usually fruitful investigations.
So that sounds like a good bar. It's just like if you're tempted to go into Slack and go, what is this?
Exactly.
All right. Well, Jeremy, we've peppered you with many questions. We appreciate you being such a good sport about it. There are probably some more in the Slack. Is there anything you want to say before we transfer to our next speaker?
Yeah, sure. I guess so. One thing that I'd love to hear from the audience is I'm curious how all of these ideas of like rules engines and machine learning models working together map to your respective domains. Because I've been working in the field of cybersecurity, but I'd be really curious to hear how much of this experience resonates with machine learning engineers working in other fields. So if it resonates with you, hit me up. I would love to chat about it.
All right.
So you heard him chat. Do your best at just peppering him with your thoughts on this.
Yes, please. And enjoy the rest of the day. It's a wonderful conference, and I'm so glad that everyone was able to make it out.
All right. Thank you so much for speaking with us.
Thank you, Jeremy, very much. And before we, move to our next speaker, which we're very excited to hear from, we have another sponsor that we want to thank. So this time it's Neptune AI. Thank you, Neptune, for your support. We heard that they're doing a scavenger hunt with some fun prizes. So please check out their booth for more info. You can see it right on the screen. Neptune, thank you again for being a sponsor. And yeah, we've got about 2 minutes until our next speaker. So I think that this is a good time to talk a little bit about ChatGPT. Yes, chat.
This is happening.
Well, I want it to happen. We'll see if it actually does. So the thing is, when preparing for being an MC, you got to have all the material in front of you. And one thing we did was ask ChatGPT some questions that we're going to read to you today. So, for instance, we asked ChatGPT, write 5 jokes about TensorFlow. So these are 5 jokes from TensorFlow that I'm going to read to you. So 1, why was TensorFlow so good at telling jokes? Because it had a high tensor of humor. That one's, I don't know, rate them in the chat. Rate them in the chat.
All right, I'll read the next one. So why was TensorFlow so bad at telling jokes? And the answer is because it always tensored to be funny.
It's high reliance on tensor. We need ChatGPT to really
just hammering on TensorFlow.
Let's see if this one's going to be any good. Okay, why was TensorFlow so popular with data scientists? Because it was deep learning made easy. I gotta say, I'm not really impressed with these results.
That put up a giant question mark in my head. It's like, I think it's just trying to sell us on TensorFlow at this point.
It's big TensorFlow trying to get us to talk about it. All right. Well, luckily we can transfer to our next speaker now. Let's see here. I can be the one to introduce her. So let me just expose the slide here. And here we go. It's loading on my screen. Great.
All right.
All right. So next speaker we have is Shreya Shankar. And Shreya, are you there?
Not yet. There's probably a couple of hiccups. So are we going to keep reading? Are you going to keep making me read TensorFlow jokes, or are we going to do something?
I didn't even know that was the thing. So it looks like you get to read more TensorFlow jokes.
All right.
I'm so excited about
for
this.
deliverance. Okay. So why was TensorFlow so good at improvising jokes? The answer is
Why?
because it had a flexible neural network.
I mean, yeah, I guess.
All right.
I guess
like compared to the previous ones, that's like a pass, but
that's
not by much.
All right, let's try a different set of things we asked ChatGPT. Okay, I'm going to read this while being an MC. Here it is. Ready? Generate a tongue twister about machine learning. This is what ChatGPT told us. It said, Peter Piper picked a peck of pickled peppers, but the peck of pickled peppers Peter Piper picked couldn't match the accuracy of a machine learning model trained on a large and diverse data set. That's the tongue twister. Now, honestly, that bodes well for my talk later that I didn't stumble on that, but I thought there'd be more P's.
I'm much more impressed that you said the thing correctly than what it spat out. Maybe I'm just not very impressed by ChatGPT at this point.
Not looking great.
Oh. You're like you've shown your ability to give it prompts that it's like struggling with, which given like the stuff that we've been seeing on the internet when it was like went totally viral, right? It seemed challenging to give it, but we found a way.
Found a way where there's a will.
Get
There's
to
a
talk
way.
about machine learning.
Okay, so here's another one. This one I actually am curious about. I haven't looked at the results because I just kind of wanted to see what happens. Okay, so the prompt was this. I'm the MC of a data science and machine learning conference. Give me 10 humorous topics that my co-MC and I can banter about between speakers. Okay, so the never-ending quest for the perfect data science team member, the unicorn, the werewolf, or the dragon.
All right, that's much better.
Yeah, that one's pretty good. Okay, so I guess the idea is like, would you rather have a unicorn data scientist, a werewolf data scientist, or a dragon data scientist as like a team member?
I would not want to have a unicorn because that's what everyone keeps trying to hire. So I'm going to go away from that. So I'm going to go with the dragon just because it sounds cooler. And, the dragon data scientist might eat me if I give them the rejection letter.
Yeah, I also would go with the dragon, not to like, I know you're, in improv, you're supposed to be like, yes, and do the werewolf, but I mean, the dragon's the coolest one. And so that's the one I want to choose.
All right. Okay. There's no good explanation for why these animals, which is interesting. It's like,
yeah, the prompt had nothing to do with dragons or werewolves or anything.
Oh, well. All right. So let's try another one. So another topic is the perils of trying to explain machine learning to your non-technical friends and family.
Okay. Well, my family is watching right now. So I don't know. They're probably texting me literally right now about some of the things they like. It seems like, honestly, they've enjoyed most of what they've watched. My mom said, I really like this speaker, Peter Sobat. So, Peter, you did great. My mother, who knows nothing about what we do, really enjoyed your talk.
Yeah, perils, like really like the biggest peril is really just as I start going into the details, their eyes just get that look and you're like, I should cut this short before it gets ugly.
Yeah, I don't know. Like, do you talk to your partner about this stuff, or
not too much? Because at some point I get excited about something silly like pizza separated values, right? Now that should be the standard for data transfer across all organizations everywhere. And then she's just gonna like give me this look, and she's just got that smile where it's like, I am completely humoring you at this point.
Well, we've humored ChatGPT, and I think now it's time to pivot back to our speaker of the half hour. So I am going to now transfer the talk to Shreya. Shreya, thank you again for agreeing to speak with your talk today. I see you in the chat.
I see
or
you
in
live.
Zoom. You're there, but you're not there, and that's okay. We'll give Shreya a few more minutes. Maybe there's still some compilation
Just
issues
shout out
going
if
on.
if your stuff is working. Feel free to just shout out and see.
Just scream at us, seriously. Like,
Yeah,
hey,
just jump
get
in
off
and
the
say, stop
stage.
talking about ChatGPT. Oh,
Okay, can you hear me?
yes.
Oh,
welcome.
absolutely.
Welcome. Deep breath.
And then hopefully you can see a screen.
And yes, I see slides.
Ideal. Let me put that in full screen. Can you still see it or no?
Yep, we see just that slide. Yep.
Okay, perfect. So sorry, let me get all of my stuff ready to present. But anyways, thanks so much for dealing with my technical difficulties. My name is Shreya. I am a PhD student at the UC Berkeley EPIC Lab, and I work on data management for machine learning. So like very much continuing with the theme of what we've been doing today. In previous lives, I've been a machine learning engineer, and the reason that I kind of went to do a PhD is it's like a fully funded experience to sit back and fundamentally rethink the way that we do things. So that's why I'm here, and I'm super excited to share with you what I've been thinking about in the last couple of weeks. And this talk is brought to you by hundreds of hours of databases, at least studying about databases, machine learning debugging, and stable diffusion. So it's no surprise that machine learning is kind of taking the world by storm in the way that we develop applications across industries, across different sizes of companies. But it's not very pretty in practice. I mean, we have a whole conference track dedicated to this. But there are a bunch of bugs that happen when you have machine learning in production. I'll talk about two of some of my favorite. One is you have this ML model that takes in a feature that relies on a different part of the code base. And if an engineer makes a change to that code base that causes this kind of get status to fail, how would you know that really? And maybe it's failing and it's failing quietly. It's returning like a negative value, for example, something that kind of doesn't put an error out there. And it really begs the question, at least the authors of this paper asked, like, do you know when your data gets messed up? Are you able to do that? Who knows? And another kind of bug was when a healthcare kind of company is kind of monitoring patient outcomes, and they take a lot of vitals through a mobile app logging device. And one of their patients kind of was just, their battery on their phone was dying over time, and they stopped sending data in. So this is kind of complete opposite. It's not that the data is changing, it's that the data is staying the same when you're pulling the latest data. You know when you stop getting data. This seems like a nightmare to kind of catch all these different bugs out there. And I feel like we've had this sentiment really in building and debugging ML pipelines, where it's like when we train an ML model and it works well and we feel satisfied that it actually accomplishes something that we want. Unfortunately, we kind of throw the model over the wall, if you've heard that sentiment before, and it becomes some sort of ops problem. And what does it mean to have an ops problem now? It means you have an engineer out there just sitting there collecting bugs, getting super overwhelmed. And most of these ML failures really have nothing to do with machine learning. They have something to do with some data corruption in the pipeline, some engineering bug, as I mentioned earlier. But still someone is tasked, right, of like identifying that and then trying to fix that as quickly as possible. And kind of as Jeremy mentioned in the previous talk, when you try to fix things very quickly, you tend to use rules, you tend to use other things off the shelf. You don't want to go and try to retrain a model for every bug that you get. And you end up stitching together all sorts of tools, all sorts of different rules, all sorts of different filters. And it creates something called a pipeline jungle. I really, really love this term because it's a jungle really not just of tools, it's also a jungle of people. You know, this diagram gives me anxiety. I think it also gives Vicky anxiety. I'm not even gonna go through it. I'm just gonna put it out there. And this diagram also gives me anxiety. It's a jungle of tools. And when you have all of these tools, one thing very, very, I don't know, terrible about it, but natural, is you feel like you're getting sold snake oil. At least I felt like I've been getting sold snake oil. Last year I went to some networking event and someone was telling me, you know, like they had this new tool where all you had to do is add decorators to your functions and then set drag dependencies and set your schedule. And it's just a few lines of code, you know, but you can get some like production ML pipeline. And I'm sitting here thinking like, okay, I don't even know if I want to productionize anything, but it's a Jupyter notebook that I want to productionize. Another networking event that I went to is someone was trying to sell me feature stores. And while they might be useful for a lot of cases, I was very skeptical. I was very happy with my table of features that I was just adding to on a schedule. I didn't really know why I needed feature stores, but I felt like I was being sold this a lot. And maybe that was just me at a startup, but I'm sure a lot of people have kind of similar experiences here. But it's not just this kind of feeling of getting sold snake oil that's a bad thing about pipeline jungles. Lots and lots of reasons why pipeline jungles suck. You know, onboarding sucks. There are tons and tons of bugs that come up out there. It takes forever to go and diagnose a bug, right? You don't even know where it is. And at least this is my opinion, I really think it requires some sort of PhD or equivalent of experience. You know, you work for so many years and collect all this expertise just to be able to maintain or have hope of maintaining these pipelines in production. You can think of many, many more. But the goal of this talk really is to give you a data practitioner or software engineer without like a PhD in machine learning, someone who's not training machine learning models, but you're working on ML-powered software. I want to give you maybe a new, different framework for interpreting ML bugs. And kind of spoiler alert, it has to do with materialized views. So before we get into it, at least before we get into the new view of ML bugs, I want to talk about how we kind of get to pipeline jungles in the first place. I have this section called Jupyter Notebook, from Jupyter Notebook to Pipeline Jungle. And I took this example from a paper that I wrote earlier this year. But the first kind of step in ML is just to identify, you know, is ML even the correct or ML even the correct tool for you to solve this problem? Can you actually train a model that gets good performance on some set of data? So maybe we open up a notebook, we experiment, you know, we do EDA, exploratory data analysis. And this example is also just taken from the internet, scraped from GitHub. And we create this notebook, and maybe we do decide that, you know, this model outputs something reasonable, and we want to go ahead and productionize it. And we have different kind of components in this notebook workflow. And what does it mean to really productionize something like this? So one mode of production ML I call single-use production ML. And that is, I want to take the results from this workflow and present them to someone else, or have that kind of implicitly inform business decisions. So maybe I clean it up, get rid of my EDA, and I only include the relevant code. And then I submit these results, and I'm happy, I call it a day. And that's great. There's also another mode of production ML, which I'll call multiple use production ML, which is I want to run this on a regular basis when the underlying data is underlying data is changing. I want to run this regularly. I want it to continually provide value, and I want to do it with some form of low latency. So I want to take the same thing, and I kind of want to construct some directed acyclic graph, a DAG, out of these different nodes. And I don't have the tags here, but the same like data loading tag and the same fitting the model tag. But there are also, in multiple use production ML, there are also different stages that we need to do, especially if we're getting continually changing data, right? We need to do data cleaning or some sort of validation. Maybe we have an inference node that kind of quote unquote serves a model. And very, very quickly you go from something like this to something like this. And this is taken from a blog post from Uber a while back that was motivating feature stores. And the idea here is you have this DAG, of dependent, or you have this DAG of nodes that need to run in order to be able to serve real-time or even like low latency predictions. You have your model, you have your data preparation, and you have your inference. And maybe you start out with something like this just to meet your like online requirements. But as kind of ML engineers observe new bugs that come in over time, they need to react quickly, right? So how do you patch this whole pipeline up to prevent against failure modes in the future? And an interview study that I did quite recently, I love this quote, but whenever they deployed their model, it was a chatbot, like customer service kind of model, and someone would ask the language model, like, what time is the business open? The model will hallucinate sometime 9 a.m., something that like kind of looks right on the surface, but if you look at kind of the website of that business, it's not going to be, it's making up times. So the ML engineer responsible for this, if they filtered the output, if they detected time, they filtered the reply, they referred them to the website, rather than try to fine tune the model on every single customer or every single business's web page. So what ends up happening in the pipeline is you end up adding filters kind of after the inference. Sometimes you add filters even like before the model, if you can kind of detect that the data asks for something like time. So you can see how these kinds of pipelines will get to something that is this like amalgamation of ML models and filters. So now I'll argue that this kind of DAG is not really great. It gives us a headache, gives us, meaning ML engineers, for a lot of reasons. Current ML pipeline DAGs suck because they, for one, require low-level scheduling. So for every task in that diagram before, I need to set a schedule. Like maybe I use Airflow, I use some cron thing. I need to make sure that we materialize each single task's output on the schedule. Then most of these tasks run on different schedules. And that's not like, it makes sense that it does run on different schedule, like data ingestion, for example, runs maybe every day, but model retraining might run like every week. Maybe the model retraining step even takes several weeks, and so maybe it's run every month, right? So given like compute requirements, just like organizational requirements also, these tasks end up running on different schedules. And then when you have these kind of low-level DAG requirements, people now have to handle consistency on their own, right? What do you do when a task fails? What do you do when someone changes the code? Do you go and backfill old outputs? All of these questions now come up, and especially when you have rotating ML engineers, right? Like that's an incredible amount of knowledge that you need to share just to make sure that this works. It requires constant babysitting and monitoring, which absolutely no one wants to do. And now I'll argue that these DAGs kind of are the way they are because they're quite training centric. What does training centric mean? It means that your workflow starts with, the goal of the workflow in the beginning is to understand whether a model can achieve good performance. So everything is about the model, be it data centric, model centric, whatever. It's about getting a good model that gets good validation set performance. And in this training centric approach, right, recall like the Jupyter notebook that I showed you earlier, you do some sort of data preparation, you run experiments, and this part is like really where you spend most of your initial time, right? Like, can you even get a model that will work? Is ML a good use here? And then once you're satisfied with that, you can get the best model artifact and then throw it over the wall, hand off this artifact for deployment. What does this look like in the pipeline setting? It means your model or your kind of training job, your retraining job is really written first. Your predict job is written second. Your data preparation and cleaning is written third. And then finally, all the online stuff, like the queries in itself, are an afterthought. This is not great. So maybe I'll present to you an alternative view, the idealistic view of how we would want to do machine learning, the query-centric approach. So what does this look like? It means So this is actually, I want you to forget kind of how you've been taught ML in the past. Forget that training-centric approach. Completely different way of thinking about using machine learning in software systems is to think from the perspective of the query. When a new query arrives, what we want to do is retrieve the historical examples that were similar to that, or retrieve the historical examples of the same schema per se, fit a model to these historical examples, maybe all of them, and then use this model on the new example to surface the prediction and return that prediction to the end user. So I'll keep this diagram here for a little bit. The idea here is we want to, I know it sounds crazy, the idea of training a different model for every query, but conceptually, like this is how we want to think about machine learning, right? It's when you get a new data point and fit a model to your existing data points and then return a prediction. And we cannot do that. We're not even close to this yet, right? Like obviously this is like the highest latency policy you could ever imagine. There's a huge gap kind of between these training-centric and query-centric worlds. And I'm not going to argue that you should be doing this. That's like the goal of research really, is to figure out how we can move closer to this world. But what is the gap between the training-centric and query-centric worlds? In the training-centric world, fitting the initial model is really an experimental process. Like, can we even get a good model? What is the best model even look like? What are the best minimal, like what is a good set of features? All sorts of things, right? In the training-centric world, the model in itself is really an artifact, whereas in the query-centric world, the kind of training set, the store of all examples, that is mainly the artifact that we want to manage in production over time. In training-centric worlds, your tasks are recomputed inconsistently, right? Data preparation is run differently than model retraining. So those maybe run batch, offline, different schedules. But in the query-centric world, right, once you get a new query, kind of everything, all of your data is as fresh as possible. It's clean, it's whatever. We have those kind of guarantees. And you've seen this word consistency, consistent data all over my slides. So this smells a lot like a data management problem, right? What does it mean to have consistency in DAGs? So now I will kind of pitch ML engineering to you as materialized view maintenance. And don't worry too much if you don't remember what views are, materialized views are. I'll do a very brief refresher. So suppose you have a table, something like this. So tables, like you are all familiar with this, data structures of rows and columns stored in your database. So a view is kind of a virtual manipulation of this data. So it's kind of formed as a result of a query, but it's not stored separately. You can query this view as you would query a table. And when you do query the view, then the outputs of this view is then materialized or created when it's queried. So then the question becomes, okay, like what does materialized views even mean? How do we do that? So materialized views are stored in the database, and they're computed when you initially define that view and on base updates to the table. So every time I add a row to the new table, then I recompute my view. There's a ton of open problems or open questions in materialized view maintenance. So you're wondering, how does this apply to ML pipeline land? Materialized views in the literature really are just some form of derived data. So same thing with ML pipelines, right? When I issue a query to an ML pipeline, that prediction is some result of transformations of the data. So in the ML pipeline world, we can think of views as kind of the training sets and the models that we are creating. And the idea of view maintenance, which is maintaining these views, is this crazy DAG that we're building to update the training sets in models as we get new data points. And views can be kind of maintained, updated, all sorts of different ways. You can do it immediately. You can do it in batch, like deferred view maintenance. So retraining is almost always done in a batch setting. You can, every time you need to recompute your view, materialize it on every update to a base table. You can materialize the whole thing from scratch. So retrain the whole model from scratch, for example. Or you can kind of write custom operators to incrementally materialize them. So this is super, super tedious, right? Because you have to maintain some state, you have to maintain what you will do on update. That's different from the initial, that requires custom logic. So, food for thought, what is low latency, right? If you do things in batch, that's low latency. If you do things from scratch the whole time, that's easy to code up. So you can think about that later. But whole crux of my argument now is that in these kind of ML DAGs, you have these inconsistent materialized view maintenance policies. So when you're training models in development, you're working off of like immediately materialized features, right? Like things that can make you iterate as quickly as possible. But when we're training in production, since we're retraining on a cadence oftentimes, we have this it's deferred view maintenance. Like this cadence kind of comes out of thin air, and when we're issuing online queries, we can't really, it's not the same assumption as this immediate maintenance in development. And then when you're serving in prod, maybe some of your features are immediately materialized, right? They're done online. Maybe you're querying your batched features or joining with some batch features. So you have this hodgepodge of immediate and deferred, policies. And we're using some retrained model. So you have all these crazy kind of mismatch in policies, and it's really no wonder that we get so many bugs. At least if you get anything from this talk, this should be it. No wonder we get so many bugs. It makes a lot of sense. So now I know I have only a few minutes left, so I'll finish in 2 minutes, I promise. But if you think about recasting kind of ML bugs as view maintenance challenges, you can think about some of them as view staleness problems, right? When you're materializing outputs offline in batch, you might get train serve skew, right? You need to make sure that your model is retrained as kind of frequently as possible. In the interview study that I did, I love one of these quotes. The retraining cadence was just like finger to the wind. I almost never see a very principled way of figuring out what the retraining cadence is. And you get kind of these feedback delays also. So if labels are done, or if humans are in the loop, like labeling data, and labels only come in every couple of weeks or so, right? This will make your training sets stale. Your models will be stale, even in offline, right? So how do we kind of think about that or reason about that? Then we also have view correctness problems, right? If I run inference on bad quality data, if I retrain a model on bad quality data, right? All ensuing predictions from that model are also going to be bad. Have a paper on that coming up soon. And data errors really compound, right, over time. If you have error ingestion, right, the error just grows as you move throughout the pipeline. So are you really you got to implement data validation and monitoring at every stage in your pipeline. And then finally, kind of bugs that arise from the dev prod gap. And this is stuff that I never thought about when I was an ML engineer, but it was my validation and development time equivalent to kind of how I served at prod. So for this retraining cadence, did my validation set have the same number of examples that I would serve in production, the same representation, same subpopulations, et cetera? Was my validation set in development time sampled like a contiguous sample of production queries? This was almost never the case at the company that I previously worked at. I almost always saw random train test splits. This is not the same way that you would kind of monitor performance in production. And finally, are you verifying this when you're promoting from development to production, like in your CI? I'll skip through this almost, but this is really just kind of tips and tricks for if you're an ML infrastructure engineer. Validate everywhere, as I mentioned before. Version data, training sets, and code together. Make it super easy, right, to check out old versions. If I time travel back to last week, can I get a view of the pipeline everything in the pipeline at that week. This is super hard to do, but very important to kind of get debugging in provenance as first-class citizens. And with that, thanks so much. Especially thanks for handling all of my technical issues in the beginning.
Shreya, we really very much appreciate it. Thank you so much for the talk. Randy, would you like to do the quick transition? And Shreya, I'm sure there are questions on Slack, so if you want to head over there, people are definitely curious.
The slides for that for the next speaker. But our next speaker will be Joanza Joseph, who is here with us already. And I mean, should we just let him take?
Let's just let him go. I'm excited to hear what he has to say.
Share your slides. We'll do a quick check to make sure they're up, and you can take it from there.
Right.
And sharing is happening. All right, I see slides. It is all yours.
All right, sounds great. Thank you for the introduction. I am excited to talk about OpenAPI 3 today. As someone who is working on a new company building APIs, this has been an important specification and made my job a lot easier. So I wanted to just give a little intro and talk through how exactly it makes my life easier. So for the agenda, I'll talk about why OpenAPI 3 a bit. I'll talk about my experience building API integrations across different fintech domains. I'll talk about OpenAPI 3 specification, its history, its use cases. I will do a demo of some OpenAPI 3 tools, and then I'll wrap up at that point. So let's talk for a second about financial APIs. So some of the most popular financial APIs out there are like the Stripe API, which enables you to make payments online. And so this API has enabled, all sorts of new use cases for payments in the world and in apps. There are also open banking. So Plaid, Finicity, these APIs allow you to connect to bank accounts and programmatically exchange information. But all of these together can really enrich our lives as individuals and also our lives as businesses by enabling that kind of quick transport of data, and then enabling new ways to look at things like underwriting. So understanding someone's financial history, some alternatives to our traditional methods of underwriting, for example, and then other financial instruments as well. And so that's what I am building, and that's why I'm interfacing with so many different types of APIs. And I've encountered, quite a bit of difficulties with that. And OpenAPI 3, whenever I have a specification for that, has made things a lot easier. So let's talk a little bit about RESTful APIs for a second. So in general, this is kind of your basic setup for a CRUD API. So you will have 5 methods. So a get, a post, a put, a patch, and a delete. And get should give you a list of that object back. So in this case, if you have slash products on the path without the SKU on the end, that should give you back all the products in that collection. If you add the SKU to the end, then that should give you the one product. Post will allow you to create products. So you should have some body that corresponds to a product, and you'll be able to create that. Put would give you an update, a complete update. So you are replacing that SKU with a new SKU, but keeping the same ID. Patch would allow you to update one field, so a mutation of that data, and then delete would allow you to delete that data. So this is kind of the philosophical idea behind the HTTP and the REST APIs. However, the reality is that people don't all implement this the same way. So some ways that this can go wrong and that API design can be hard are some small things to big things. So let's talk about some of the small things. So let's consider someone who believes that instead of making this plural products, that it should be product. So that's one way that they can do it. There also may be some APIs that believe that this is kind of too robust and too many methods. And so they might make a post API for everything. So there might be post, slash products slash delete, and then that would kind of take over the same effect as a delete HTTP method. Or you may have the patches and the puts and the gets all be implemented in posts as well. Furthermore, you may not want to use the path in order to pass the SKU ID. So you may pass it in a header, you may pass it in a body. And so as someone who's integrating with an API, you get used to the pattern that you see, and then you go to another API and they follow a completely different pattern. And so reusing your code, doing things in a way that is modular becomes very difficult and strenuous. And so OpenAPI 3 is an attempt to, one, standardize on how these APIs should look, and then two, provide some ecosystem around these APIs so consuming them is a little bit easier. So OpenAPI 3, what it is a protocol, or I guess more specifically, a machine readable, language agnostic, and open protocol for REST APIs. So it's a way to describe RESTful web APIs in a machine readable and language agnostic format. And so what do you get in return for that is community. So once things are machine readable and language agnostic, many tools will pop up. You get an ecosystem. So you get a wider array of tools. You get them being interoperable, which is the last point. And as far as the lineage or the composition of OpenAPI 3, what it is essentially JSON schema to describe the JSON objects that are being passed around over HTTP, and then some other, you can call it syntactic sugar to explain the rest of things that can happen in a web API. And you might wonder how this relates to Swagger. So Swagger actually is you can think of it the grandfather of OpenAPI 3. So essentially Swagger was kind of the initial attempt to do this, and then it spun out into something that was more generalizable, which is what OpenAPI 3 is. And Swagger and OpenAPI 3 are kind of mostly compatible with each other. You kind of find places where they aren't, and it's a little bit frustrating. So that's that. So let's jump into a demo of some of the OpenAPI 3 tools. Okay, so what I have here is Replit. So some of you probably have worked with this, but essentially I'm just going to go through 6 different tasks with different OpenAPI 3 tools. So first I'm going to start by taking an OpenAPI 3 specification and then consuming it and converting all the endpoints into TypeScript interfaces. And then I'm going to talk a little bit about how you can create your own specification, what that looks like. Then I'm going to take an existing OpenAPI 3 specification and generate a mock server out of it. So based on the spec, I simply will run a mock server and then be able to run some commands against that over Postman. Then I will talk about how you can take an OpenAPI 3 spec and then turn it into a nice documentation that you can share with either your customers or friends or colleagues. Then talk about generating a Postman collection out of an OpenAPI 3 spec. And finally end with generating an SDK. So this is specifically a TypeScript SDK. And yeah, TypeScript is just what we've been using for the company. So it's kind of the thing I'm the most familiar with at the moment. So before I do any of that, let's just take a quick gander at one of these specifications. So this one is one that I borrowed from this lady named Lorna, and she's trying to make this API that allows you to retrieve planets in the solar system. And so in this API, you can see she's got an Open API 3 specification version. She's got some description, and then here are the paths. So there's a get and for planets, so /planets, and then there's a get with /planet/ID. So pretty straightforward. Describes kind of what you can expect from the API. And one nice thing here is that it also gives these examples of what the values can be, and that comes in handy when you're trying to generate a mock server. So without further ado, so we're going to start by consuming this Open API spec, actually a different one from the planets one. So this one's kind of wordy. So what this is a CRM, so a customer resource management API. It's pretty long, but effectively we're just going to take this, which is like multiple method API, and then just turn it into some schemas that we can use in TypeScript. So we'll do that with this tool called Open API TypeScript, which just takes any valid spec of Open API and then turns it into TypeScript schema. So let's copy this, and so yeah, we'll just run that. Might ask me to install this. Okay, that's fine. Okay, so 1 second. Oh, I think I have a typo there, sorry. Okay, so that created the schema.ts file here. And so for each of the endpoints, I've generated these different interfaces in TypeScript. So I've got this /CRM/leads endpoint, and that's a get operation. And there's also a post operation for that. And then I've got these different webhooks. I've got the interfaces that are specific to the regex that they're described with. So for example, this needs to be an ISO format for time. And then I've got all that just kind of read directly from that Open API spec. And that just continues forever. It's a pretty long API, so I won't make that too long. But yeah, so pretty simple. This would work in any language. There's tooling, for this, all because you have the specification that describes this API so well. So we'll skip through this. We already kind of talked about this API. So we'll move on to mocking. So we are going to mock that planets API that I just showed, and need to install that too. Okay, so what this is going to do is going to spin up a web server on port 8080, and then in Replit, it basically will forward port 8080 to this domain here. And so from that, I can make a GET request against this. So I'll come over here to the Postman and then make a GET against planets. And then you'll see here that I get a planet Saturn back. And then also there's another API endpoint where I could do an ID. And so I'll also get planet back for that. So so simply, like, I didn't write any code, and then I've got an API that kind of just works against that specification, which could come in handy if you're working with APIs like I am all day. All right, so let's do the next one. So okay, so next we're going to spin up some documentation. So I'm going to use this tool called Redocly, which takes an Open API specification, all the examples, and then provides a nice page for you to display your REST API. So let's do that. Okay, so basically this whole API is described in that doc, and then what you get is this page here. So it has all the notes, explains the headers in your API, API keys. And then if you come down to the bottom here where the actual API is, so it'll give you, any kind of authorization parameters. It'll give you some examples of code. So you can, do Python or Java, and it will kind of automatically generate how this code should look. It gives you all your responses, and it's pretty solid, for just auto generating it. And as you get get used to using Redocly, you can generate nicer and nicer pages. And Redocly isn't the only tool that works with these OpenAPI 3 specs. There's several, but this is kind of one of the nicest and sort of easiest to use ones. So it's one that I recommend. All right, so let's keep moving here. So the next one, we're going to generate a Postman collection. So let's see. Let's actually just close this web view. I don't need that anymore. Move this over here. And okay, so we're going to take that same example spec that has a CRM API and make a Postman collection. So then we'll import that into Postman afterward. Okay, so that was saved in this temp directory. So we got temp converted CRM API.json. So we'll download that, and then we'll open up Postman, import new collection, and sweet. So now we've got that full API in Postman, and then if you can add any of these default values as well, and add a Postman environment if needed. So that's an easy way to get started if you were trying to consume a new API. Okay, and finally, we're going to generate this SDK. So we're going to take that same example spec and then generate an SDK for TypeScript from it. Okay, so now we've got this SDK.ts. So this is effectively an SDK that you could import and start using that implements this entire API. So it's got all the types, all of the methods, and exactly to the specification that was written. So let's go back here. Okay, so these are all the benefits that you can get from OpenAPI 3. So testing, being able to mock, being able to use the integrations in the ecosystem. And I think the most important, the sanity. So having a way to describe an API and letting kind of all the heterogeneity happen, from however creative people want to be in defining their APIs, but still having a way to describe it has made my life a lot easier. Being able to import the Stripe API as a spec or the Plaid API, just makes my life 100 times easier. And so I really love this tool. And if you haven't used it, I hope that you get a chance to. And that's it for me.
Wow. All right. That was some people. So you probably didn't see it because you were doing an entire presentation, but people were commenting on the fact that you were doing a live demo during this 20-minute presentation. So that was pretty impressive, I must say.
I don't live in fear.
That's for sure.
Randy, do you want to queue up a question?
All right, I've got one here. It's like someone saying that what they really want is a way of generating open API YAML from a bunch of curl requests that we already have listed in our README. Does something like that exist?
It does. So they're called interceptors. And so you can set them up to where you essentially have a listener on your API, and then it will basically parse the request coming in and then try to create a open API spec out of it. But there's a lot of limitations to this because there oftentimes are limited ways in which people are curling the API that doesn't expose the entire surface area of it. So it'll give you kind of a somewhat of an idea of how it should work, but not a complete one. So I think that it's okay, but I think consuming the specification is the best way, but you can intercept requests and create a spec from that too.
Okay, so you seem to know a lot about APIs. It's taken like a step back. Are there any resources that you tend to use that you think viewers could turn to improve their API work deployment?
There isn't, and the reason why is because I think the HTTP specification and then like REST APIs in general, there's just too much room for interpretation, right? There's too many ways to design it, and there's too many designs that you can call good. And so if you're starting out and thinking about how you want to design your API, like there would be 15 or 20 maybe canonical examples. Stripe always comes up, Twilio always comes up, but they're very different philosophically in how they approach things. And so I think the best advice I can give is, one, consistency. That's the thing that matters the most, because whoever's using your API will get into the habit of how you have formulated and how you designed it. And so whenever they encounter inconsistencies is when it's frustrating. So that's really the only design idea I have, because everything else is just, it's just opinion and personal preference.
Cool.
Makes sense.
Can you take your slides off so that we can better see everyone's face while we're talking?
Oh yeah, I could do that.
Yeah, thank you so much.
Stop sharing real quick.
All right. So one question is, you're obviously very, very experienced and good at using Open API. How do I, who knows barely anything about anything, get to where you are?
Yeah, I think one of the coolest things about Open API is that it's ubiquitous, even though you haven't heard of it. So if you've ever used Fast API or Django or Flask, these frameworks all kind of come with Open API 3 embedded in them. So they will automatically generate a specification based on your endpoints. And so I think that's the best way to start. Maybe if you have some existing APIs, just generate a spec from it and then take a look and maybe open it up in like Redocly. And you'll probably find that it's maybe a little embarrassing that your API wasn't designed as well as you thought. And then you can go from there and like iterate and get used to, the specificity that's in Open API 3.
You just kind of blew my mind at the fact that you're like, just, peel the wallpaper off of an API and it is just Open API just sitting behind. Like I did not know that.
Yeah, I think it's one of the tragedies of web development right now, and partially I think people who generate have companies that sell APIs are very familiar with this. In fact, there's a few blog posts out there where they use Open API 3 to keep all of their SDKs in sync, right? So when they make changes, all their SDKs are built off of Open API 3, so all matches. But I think for internal APIs or companies that don't sell their APIs as a service, it's probably less so, right? It's kind of more open to, just give me a README, just give me a Google Sheet or something to explain the API, and less about, I need a machine readable way to consume it.
Wow. We got another question for you, if you're willing to answer some more. Okay.
I am.
So Peter asks, a few times I wanted a tool that goes from Open API spec to a dumb CRUD UI in one of the front-end JavaScript frameworks, React or Vue. Do these APIs to UI tools exist? Am I just bad at searching?
You're not bad at searching. I don't know of ones that will give you like a CRUD UI to say like, hey, this is an API like the planets one. Just give me a UI of this, list of planets. But that's a good project, maybe, Peter, that you can start. I don't think it would be too hard, especially for certain types of CRUD APIs.
All right, that makes sense. I have sort of like here's another one actually. The question is, something that's always interested me is the tension between data work and development work. Since you're focusing a lot on API development, how do you think about what your backend database looks like, or is that an incremental process?
Yeah, I would say that there's not a tight coupling between what the database looks like and what the API looks like. I think that the API really exists to be the bridge between what the user needs and what your public interface looks like, and then what the mess and destruction that your internal stuff might look like. I think that, as someone who has done, data engineering and, some quasi machine learning engineering stuff, I think at the end of the day, right, if a company or a user wants to consume whatever you're making, it's probably going to be REST. Right? It's 90% chance. And so I think that should be a good relationship between the two, right? Where you can have data that's easy to serve up, easy to express in a format that someone can consume. But it's sometimes easier said than done, right? Like a lot of these examples are, give me a list of planets that have 3 categories. But some of the data that we've seen in this conference, like is, we got 20,000 parameters or whatever, and like it's not easy to just kind of expose that in an API. So it takes some thought.
All right. Well, I think we are just about at time here, but just before we transfer, do you want to leave the viewers with any last parting words or thoughts?
No, I feel like I said so much. I'm just grateful for the people who organized the conference and the sponsors. So thanks for giving me this opportunity to speak today.
Thank you so much for being with us. There are a couple of more questions in the chat, so feel free to check over there.
Okay, yeah, I will.
All right. Thank you so much.
Thank you so much. All right. So we are continuing to, roll through this conference and through our speakers. We have a few minutes before we bring on our next speaker. So you know what that means, Randy.
Oh, no. This is the part where I like lower my chair and just fade out of frame, right?
That's right. It's more Chat GPT. I'm so glad that you're enthusiastic because I have some for you. Here it is. Okay. The prompt is, it was once said that data scientist is the sexiest job of the 21st century. Write a humorous but gloomy prediction of the sexiest jobs of the next 5 centuries. And we're going to go through these and see what Chat GPT thinks are going to be the sexiest jobs of the next 5 centuries. Would you like to start with the first one, or shall I?
All right, I'll start with the first one. The sexiest job of the 22nd century will be the radiation suit tester, bravely exposing themselves to deadly levels of radiation to ensure the safety of others.
I actually really like you're just shrinking away. I really like that one. You can't get away from this, Randy. All right, so the next one is the sexiest job of the 23rd century will be the asteroid deflection specialist, risking their lives to protect Earth from incoming asteroid threats. That one seems like fine.
Yeah, I guess. I'm just gonna keep going. But actually, time-wise, shouldn't we be having our guest show up?
Yeah, let's start transferring to our next speaker, and also because I know you don't want to continue through the ChatGPT. So, okay, great. I'm gonna share my screen over here, and we're gonna introduce our next speaker. Here we go.
All right. Ethan, you're around, I believe. Oh, nice. There you are.
Hi there.
All right. So we are going to transfer over to Ethan Rosenthal, who, whatever he says, DS to ML to AI, whatever pays the most at Square. So I think that's a great transition point for you, Ethan. We'll hand you over the screen, and whenever you want to start your chat, feel free to do so.
Sounds good. Yeah, I'm a total mercenary.
All right, we got slides. It's all yours. You're muted though.
I think we lost your sound. So let's while we're waiting for Ethan to figure the sound out, we are going to talk. I mean, look, ChatGPT is always right there. So we need to pull it in.
Can you see my slides and hear me?
Yep.
Now we can.
I know you wanted to go through that, so I don't mean to interrupt, but.
All right, it's all you.
All right, cool. Hi, everybody. Yeah, so my name is Ethan Rosenthal. I manage a small team of AI engineers at Square, and I'm not going to talk about any of that fun stuff today. So, we do things with large language models and all sorts of hot stuff. And, like with much of this job, I think the majority of my job is not doing that stuff, and it's instead dealing with the NormConf things. And so today I'm going to talk about the absolute terrible time that I had trying to get my team's code base to build on an Apple M1 laptop. And so this is largely going to be a cathartic rant, but I hope that it's also, helpful, and maybe you all will learn something too along the way. So why am I talking about this today? I would be surprised if you could forget, but if you all remember our, intrepid NormConf leader, Vicky, sent out that tweet that was heard around the world back in July about creating this conference. And I was like nose deep into trying to get my team's code base to build on this M1. And I, kind of snarkily made a reply to that tweet. And here I am now, actually talking about that. So kind of fun to bring things full circle. So what is the M1? For those of you who don't know, back in 2020, Apple released a new line of laptops that use their M1 chip, which is kind of like the first time that Apple had created their own CPUs, like specifically for their laptops. And so they followed up like a year later with the M1 Pro and the M1 Max, and they had all these nice charts showing that you get more performance for lower power. And so a lot of people were excited about that. Who doesn't want their code to run faster? And who doesn't want to burn their thighs with their laptop when it's using too much power? And so this all seemed cool, but I was not very interested in any of this because, I know the first rule of programming, which is that you should never change anything. Like if it ain't broke, don't fix it. And my team's code base was working. And so I don't want to mess with like success. Unfortunately, time is like the one thing that changes that, none of us can stop that even if we wanted to. And so what happened at work was that in January 2022, it was announced that M1s were now available to new hires at the company, as well as people that were eligible to upgrade their laptop if, their current laptop was kind of old. And so they made that announcement, and one of the people on my team was kind of excited by these new laptops. And so they requested an upgrade. They got an M1, and they failed to get the code base to build. They spent about a week with this and no luck. And then a couple months later, another teammate tries to get a new M1, spends a week trying to build the code base, and they fail. And then in August, we knew that there would be 2 new members starting on the team, and they were going to be issued M1s. And I stupidly decided to start managing the team a couple weeks before. And so this meant that this was now my problem, and I was going to be the one that had to figure this out. And so like any good engineer, I completely underestimated how much work or time this could possibly take. But I tried to be reasonably smart about this. And so anytime you embark on something new at a company, I think it's a good idea to, check the wisdom of the masses. And, Square is the biggest company I've worked at. I used to work at some startups before this, and I never really appreciated how helpful it is to have a big company Slack. It's kind of like your own personal Reddit where you can get recommendations for like local accountants or holiday gift ideas and everything else. And so I decided to, delve into Slack to try to see if anybody else had already run into this problem before. And so, I'm reading through Slack search and other sorts of things, and I find these, esoteric Google Docs and Notion docs where other people had attempted to solve this problem. And if you search through these docs, you stumble upon these like incantations, right? These cryptic brew libraries that you have to install before you do anything, and these other cryptic environment variables that you have to set. And you don't understand what any of this means, but you're just gonna like copy and paste it and run it like everything else that you do with Stack Overflow. So I did that, and I thought, all right, like I'm good to go. Other people have run into this, I'll be good to go. And so the first step is, now that I've done my brew installing and set my environment variables, now I just need to install Python. Like my team's code base is built in Python. That's the first step. And immediately I failed because my team's code base was based on Python 3.7, which it turns out is not supported
on Apple M1 laptops. And so now I find out that we can't use our version of Python. We're going to have to change the version of Python. Thankfully, it's not like going from 2 to 3, but I'm guessing most of you out there probably don't like to change your version of Python too often. And so setting this Python version, this was kind of like the first node in this like tangled web of shit that I had to wade through. And so one recommendation I have is if you want to deal with different versions of Python, PyEnv is a great little package that allows you to install different versions of Python on your laptop. And so then anytime you are, starting a new project, starting a new virtual environment, you can choose which version of Python you're going to use via that. And then, I had to decide which version of Python to use. And I think, my rule of thumb is to go with Goldilocks. So don't go with the latest and greatest 3.10 because, this is like on the bleeding edge. Don't go with the oldest 3.8 because it's, it was kind of like almost out of support by that point. And so just, go with something in the middle that's only a couple years old. So we chose 3.9. So this was like a 2 minor version upgrade that we went from 3.7 to 3.9. So now that I've changed my version of Python, this means that I'm going to have to change some of my Python dependencies because certain dependencies only work with certain versions of your dependencies only work with certain versions of Python. So what I mean by a Python dependency is like a library that you are pip installing like NumPy or matplotlib or something like that. And so now I'm going to have to change the versions of these dependencies. But it's not just that I have to change them because they are now incompatible with my new version of Python. The other issue is that I have this brand new flashy sports car of a laptop, and there are no wheels. So Python wheels, for those of you who don't know, are like zip files where other people have kind of like pre-built your code so that it will run wherever you run your code. And so for a lot of these libraries, you need pre-built wheels in order to run this code on like your laptop or in the cloud or something like that. And it turned out that even if I had certain Python dependencies whose versions worked with my new version of Python, these versions of these dependencies did not work on Apple M1s. And so now I need to go and find what version actually introduced wheels that are compatible with the M1. Okay, so we've changed our version of Python. We've changed a whole bunch of Python dependencies, and then ideally you are not managing these dependencies yourself. I think if you're spending all day kind of hard coding all of your dependencies into a requirements.txt file, then you're not going to have a good time. But if you use a dependency manager, which is a tool where you can kind of declare, these are the high-level dependencies that I need for my package, then this manager will go out and find those dependencies, those dependencies, and this entire like nested graph. And it will make sure that it finds, the exact versions of all of the subdependencies such that everything will work and kind of, be reproducible every time you install your package. And be aware, a little bit of self-promotion, but I have an entire blog post about this where my actual entire process around how I do data science is that every time I start a new project or analysis, I create an entire Python package and I manage all the dependencies with the dependency manager. And the nice thing here is that this means that 6 months later when I come back to the analysis because some stakeholder had a question in a Google Doc from an analysis that I ran 6 months ago, I can reinstall my package and rerun my analysis and have everything work. The other thing that I learned in this process is, it's kind of difficult sometimes to make sure that all of your different versions of your Python package actually all work together. And so what you end up finding is that, you run your dependency manager, try to get all your versions to work together, and the dependency manager spits out some, weird error saying, these two packages conflict with each other. There is no way that you can install all of these. So I kept running into this, and a very stupid skill that I now have is that I learned how to debug this pretty well. And my debugging strategy is that I create a minimum viable Python package. And so what that means is that instead of starting with my huge code base that has all these dependencies that takes, it takes a really long time to add a new dependency because you have to like traverse this giant graph, I create a tiny little new Python package. And I first install that offending dependency that seems to conflict with other ones. And then one by one, I start to add some new dependencies. until the conflict appears. And then I know which exact dependencies are conflicting with each other. Hopefully, like, ChatGPT solves one day and you can just ask it, feed it your lock file and ask it what the issue is. But until then, you now have this very painful process that you get to go through too. Along the way, we were using pipenv as our dependency manager. I never really liked it. I always wanted to change to poetry, but I, don't like to change things at the same time because everything was working. But never let a good crisis go to waste. And so we ended up switching our dependency manager in the process. We also had to do this because for the life of me, I could not get SciPy to install with pipenv. I think there was a bug somewhere. And so this ended up being actually like a necessary requirement of this refactor. So now we've changed our version of Python, we've changed a whole bunch of dependencies, and we've changed the way that we actually install and manage those dependencies. And so, of course, we don't do all of this manually because we are engineers and we like to abstract stuff and build declarative systems. And so everybody's favorite declarative system, the makefile, and we have a couple 100-line makefile in our code base. This now needed to be updated to work with the new dependency manager. But thankfully, by this point, I actually got everything to build. So, I was able to build my code. I was able to run tests. I was able to, train some small models on my laptop. So I should be done, right? I fixed it for the new laptop. But unfortunately, code doesn't just run on our laptops. Code runs in the cloud. And the way that we run our code in the cloud is we build Docker images, at least on my team. So we use a Docker file to build a Docker image, and then we ship our code up to the cloud and run the code up there. And that Docker file is building the code that we are writing locally. And so there is kind of a natural coupling between the Docker file and our code base. And one of the things that the Docker file has to do is it has to install Python, it has to install Python dependencies and other sorts of things like that. And so this meant that I needed to update all of our Docker files so that they now worked with this new setup. But we don't just run regular code in the cloud. We run code on GPUs because we're training fun things like language models and everything else. And that code that runs on GPUs, we need to install CUDA, which is like the NVIDIA library. We need to install that in both the Docker container as well as the EC2 instances that the container is running on. And so now we have this other piece of our cobweb. If you go to NVIDIA's website, they have this diagram there where I think they're trying to argue that it's simple to do stuff on GPUs, and maybe it's a lot simpler than it used to be. But what you actually are not really, what's not entirely clear until you look closer at this is that there's this tight coupling that exists in GPUs between all sorts of layers of the stack. So you have to make sure that you have like the right versions of drivers and CUDA that are running on the actual instance that's running in the cloud. That is coupled to the version of these libraries that is running in the Docker container. And all of this gets coupled with the application that is actually doing the programming, which in our case is PyTorch code. And it turns out that all of this coupling is terrible, and it's like a lot of work, and it's a total pain. And I wanted to try to find the words, but I couldn't find the words to convey this to you. And so instead, I decided to burden some GPU hours and ask Stable Diffusion to paint me a Renaissance painting of a GPU burning in hell. And ironically, the hallmark of the GPU here is really the heatsink fans, which seem to be trying to dissipate the heat of hell. And so, yeah. So if you go to PyTorch's website, which is the deep learning library that we use, they have this wonderful little widget where you can pick, are you on Linux or Mac? Do you install your Python packages with pip? Which version of CUDA are you on? You pick all of these pieces, and then they give you this wonderful command that if you just run it, works most of the time in order to install these libraries. And all of this is great if you're on like the latest and greatest version of PyTorch, but for various reasons, my team was not. And so if you try to go back to earlier versions of PyTorch, this is the recommendation. So depending on which version of CUDA you're running, or if you need GPU support or not, and which platform you're on, you have all of these different pip commands with like pip indices and other sorts of things that you have to worry about. And so, I needed this to work with our dependency manager. And so I was having some trouble, so I decided to search on Google for how to, work with PyTorch and poetry, and stumbled upon 36 comment GitHub issue that was prematurely closed because the problem was definitely not resolved. And so then a new issue was opened, and that issue is definitely still open because this is entirely unresolved right now. And so I ended up doing something terrible. I had this beautiful dependency manager that allowed me to, declare my dependencies, and it would figure everything out for me. And instead, I ended up kind of just having to hack and ruin it. So what I ended up deciding to do was that, in our code base, in the dependency manager, we would just install the version of PyTorch that does not have any GPU support because I don't have any GPUs locally. And then in our Docker file, we're going to first export a requirements.txt file from our dependency manager. So we will generate, kind of like running pip freeze, we're going to generate all of our requirements. And then I have this terrible sed command, which just substitutes the line of PyTorch with a hard-coded URL to a wheel of my exact version of PyTorch. And so it feels bad, but it works, and I haven't touched it since I made this change. And so maybe that's a sign that it's working. And if you're struggling with PyTorch and poetry, this hack, it actually does work. So sorry if you end up having to implement it too. So fine, we've figured out how to build our code locally. We've figured out how to make sure that that code also works in the cloud. We're good to go, right? Unfortunately, there's actually a third place that my team runs code, and that's in continuous integration. So anytime we want to merge our code into our main branch of our repo, we run various tests and things like that in our own build system, kind of like GitHub Actions. And so we need to do everything within continuous integration as well. And it was at this point that I realized that I've been possibly blaming a lot of other systems out there, right? I've been complaining a bit about GPUs and poetry and all sorts of other things. And but part of this is my team's fault as well. And so one of our issues that I realized is that we had 3 entirely separate different processes for where our code runs. So when we're local on our laptop, we have one way of installing Python. You have to install a dependency manager, install those dependencies, and then run your tests or run your code. And so there's a very set process for doing that on your laptop. But then when you're in CI, there's an entirely separate process for installing Python, an entirely separate process for installing those dependencies. And there's a little bit of coupling between the two. We kind of use a make file for a little bit of this coupling, but not fully. And then within Docker, there's an entirely separate process for all of these. And so what this meant was that anytime I had to change one of these blocks, I had to change it in 3 different places. And so this is maybe a sign that we have not architected our setup in quite the right way. And so I realized actually after this that at previous companies that I'd worked at, we had been a bit smarter about this. And so one option is that you do all of your CI within the same Docker container that you're going to use when you run your code in the cloud. And this actually kind of makes sense because the whole point of CI is to test your code in an environment that's fairly similar to the production environment, kind of like the same way that you create a test set with your machine learning model, because you want that test to be representative of what's going to actually happen when your model is running in the real world. And so one option is to use that exact same Docker container within CI so that you only have within that container, you have your method of installing Python and the dependencies and everything else. And then this way we actually, at least only have 2 ways of doing this. You can start to collapse this more, but I don't know, programming with Docker locally is not great. So what ended up actually happening? If you notice, it was August 2022 was when I needed to finish this by. If we go back and look at some of our timestamps, you can see that it was July 26th that I sent that tweet at Vicky. Next day, I submitted a PR. And my goal was to get that PR reviewed by August 3rd for the very important reason that I was going to be on vacation and I didn't want to have to worry about this after going on vacation. And sure enough, August 4th, it got merged. I went on vacation and somehow nothing broke. So that's the story of that. And you can find me elsewhere on the internet. And thank you all.
Thank you so much. That graphic of the slow reveal of that map was terrifying because it's it's one of those ancient maps of the new world, and it's what serpents and dragons are lurking under those gray squares as you're peeling them off.
There were a lot more too, but it was only a 20-minute talk.
I mean, it was bad enough when you're make files.
Don't get me started. That's
gosh.
one of the make files. There are multiple in the code base. So
And then a make file for your make files. Oh gosh, there's so many layers.
it's the original DAG.
Oh boy. Okay. Well, we got some questions for you. As you can imagine, there are a lot of thoughts, mostly dread in the comments of like people, commiserating. Okay. Randy, do you have any questions, or do you want me to start with some?
You probably have one in mind. Go ahead.
Okay, cool. Okay, so this one's near and dear to my heart. Part of in one of your parts of your slide, you were talking about like the Goldilocks approach to Python versions. I was hoping you could expand on that a little bit. Like, why lag Python versions? Why not just stay up to date with the most recent Python version? Like, what errors could, emerge?
Yeah, no, that's a good question. I think if you try to go with the bleeding edge, like a new version of Python gets released every year now, I think is what's happening, a new minor version. And, all those libraries need to keep up with this. And I think, a lot of these libraries are, just open source libraries with a couple people building them. And so they might not be able to have those libraries ready right when like a new version of Python comes out. And so if you try to go with that latest and greatest version, then it's easy to run into the scenario where a new version of Python ends up breaking some of these libraries. And so the longer you wait, if you use an older version, then it is more likely that third-party libraries have had time to adapt to that library. Of course, if you use too old of a version, then you stop having libraries that are compatible with it. Like new versions of libraries are no longer compatible with that version of Python. And so finding that sweet spot, I feel like 3.9 has been pretty good to me right now. Maybe next year I'll upgrade to 3.10. We'll see.
Don't be too adventurous.
I don't want to change anything. So.
All right. So I've got a question here. Did you ever get to the point where you thought about just switching away from Python entirely?
I definitely wanted to flip my table a couple times. I mean, I have no desire to switch away from Python though. So half of my team's code base exists in Java and half of it exists in Python, and we kind of straddle that world. But for everything that we're doing with like deep learning, natural language processing, like Hugging Face and things like that, it's really nice to have the Python ecosystem there. And I mean, personally, installing dependencies, dependency management, like this is the biggest issue that I have with using Python, but I think it's all worth it for the rest of the ecosystem.
Yeah. The dependencies. Speaking of dependencies, Conda. So you mentioned poetry, you mentioned Pippin. Can you talk a little bit about like, I mean, this isn't a talk about pros and cons of different dependency managers, but I mean, do you have any commentary about like what you like in poetry, versus what's maybe in Conda, which is also a very popular dependency manager?
Yeah, I have opinions on these things. So I used to only use Conda, and I ended up switching at a previous company that I worked at because we wanted to publish internal Python libraries, kind of like your own internal PyPy. And we only had support for pip installing internal libraries. And that's actually the same thing at my current company. And so, constraints help you to decide on solutions. And so like having that constraint is a very easy way to say, all right, like I just can't use Conda. With that said, I did used to run into issues with Conda, which I think I've asked on Twitter and I haven't gotten like a satisfying answer to yet, which was around like, if you use Conda and you use different channels to install these libraries, then it was sometimes hard for me to perfectly recreate a virtual environment using the exact match between the channel that I used and the library that I used with that channel. And so things kind of got like collapsed together. And so I felt like from the reproducibility standpoint, I struggled a bit. But with poetry, minus PyTorch issues, I found that I can like, rebuild my virtual environment from scratch many, many times. And it always kind of works.
Cool. So I've got
all about reproducibility. So.
Mm-hmm. All right. So if you were to go back, knowing what you know now, right, about dependencies and everything, would you build things in the same way or different order or choose different things entirely?
Hindsight.
Mm-hmm.
I wish I had that. I mean, like, there's like, what would I have done in this situation? And then there's what would I do if I could rebuild the entire code base from scratch, right? And so I think the difficult thing with refactors is that if you know exactly what you're coming into, then you can make these decisions. But the difficult thing with this was that I had, it's like every time you pull this thread, like, this entire other sweater unravels. But knowing what I know now, I think like still the goal with refactors is to not change things too much. It's like to keep all the functionality pretty much the same, but kind of like migrate the code underneath of that. And then later, if you want to change some of the functionality, you can do that. And so what I largely tried to do with this one was keep a lot of the existing functionality the same. So keep the make commands the same, keep our process of like, like building Docker images the same. And I think that was helpful. And I think I would still make that decision even now, even if it's not the best way to do it. It meant that migrating everybody else over was a lot easier than it would have been if we had changed up a whole bunch of processes.
Got one final question for you from someone. Her name is Vicky. I don't know. It's unfamiliar.
Is that with a V?
I think so. The question is, when you encounter challenges like this, does it ever, does the question, oh, here it is. Does it ever question your understanding of where you are in your development career? Asking for a friend, like maybe you thought you knew everything and now you are reduced to nothing.
Yes, every single time. Because when you run into issues like this, I feel like it reveals a leak in the abstraction layer, right? Like if I can just use poetry and not have to understand anything under the hood, if I don't have to understand lock files, I don't have to understand pip or anything else like that, and I can just use this high level tool, then my life is great. And I think I know everything because I'm like, oh, I'm using this tool. I know how to use the tool. But then the moment anything underneath breaks, it kind of like exposes the inner workings and you realize that you had no idea what was going on under the hood. And yeah, that happened at every step of the way here. So solidarity.
All right. Okay, well, great. Well, so thank you for this. We actually have a bunch of other questions for you. So if you want to head to the Slack and answer them, a lot of people are really curious about what you talked about. But any parting words before we move on to our next speaker?
No, just thank you to the organizers. This has been fantastic. The conference has been amazing. And yeah, thank you all for listening. So cheers.
Thanks, Ethan.
Thank you.
And before we start with we introduce our next speaker, we have someone else to thank here. So I'm going to share my screen here. I think you can see it. So this one is, it's actually pretty near and dear to my heart. We want to thank Block Science for agreeing to match the NormConf donations for this year, or for this conference. So thanks to Block Science, we are able to match our donations. So we're going to meet our goal of maybe $15,000 sent to NumFocus, which is a nonprofit dedicated to supporting the very libraries and tools that all of us have been talking about throughout the day. This is a really great turn of events. So we really appreciate Block Science. And of course, we appreciate NumFocus for doing all it does to fund and support the tools and the people who make those tools that we use every single day. So thank you, Block Science.
Awesome. And I want to say that I will be heading off because I sense there's going to be more ChatGPT and I'm going to get as far away from that as possible. But in my place is Caitlin Hudon, who is going to replace me and introduce the next speaker. So thank you very much for an awesome conference. I will fade off of camera now.
We'll get you soon, Randy.
Yeah, thank you so much, Randy. I was cracking up at all of the chatter. So I want to introduce our next speaker, who is Peter Baumgartner. Peter is a machine learning engineer and consulting services lead at Explosion AI. And the talk he's going to be giving today is Data is the New Oil Coffee. Thanks, Peter.
All right. Are we rolling? Let me share my screen. Let's do.
All right.
That.
I see it.
Looking good. Let's roll then. Oh, let me get Zoom out of the way here. All right. Here we go. Thank you, everyone, for watching my talk. Data is the new coffee. I am Peter Baumgartner, and I am just going to dive right into it. So I'm a machine learning engineer at Explosion. We created the Spacey natural language processing library and the Prodigy annotation tool. I also lead our consulting services. So I work on various applied natural language processing problems. And often those problems involve the process of annotating data, which is also called labeling or coding data. For those of you not familiar, there's an example here on this page. In this image, we have a common natural language processing task called named entity recognition, where we're looking to identify entities and their types within a piece of text. So right now we have models that can do a pretty good job at this task. But the reason we have those powerful models that can make predictions about entities is because people have done the work to annotate thousands of documents with named entities like this one. So one part of my talk is going to be talking about this process and exploring this question of where does our data for machine learning come from? Specifically, what's this process that transforms unlabeled raw data by adding annotations or labels for supervised learning tasks? But we're going to get a little weird. We're going to take a winding road to answer that question because first we have to talk about coffee. So I love drinking and learning about coffee. The idea for this talk came from this book on the right here. It's a sort of manuscript, a very long exploration into the world of professional coffee tasting. And as I was reading, I noticed there were just a lot of similarities between the world of professional coffee tasting and what we do when we annotate data. It raised a lot of interesting questions about coffee for me. It's like, how does a bean travel thousands of miles to end up in our cup without having defects? When we're at the store, how do we actually know what kind of coffee we're buying? How does a coffee taster convert these raw taste perceptions into a quantitative and qualitative assessment of that coffee that can be shared? Who came up with the descriptions that we see on coffee bags and menus, and how did they do that? So my twist on the NormConf theme here is illustrating that I think there's a lot we can learn from these mundane, habitual, very normie tasks like drinking coffee. And so we'll start getting some answers to these questions about coffee by exploring the world of professional coffee tasting, and then see what we can adopt for data annotation. So a typical coffee tasting consists of sampling several coffees. Depending on the purpose of the tasting, this can result in a description of their flavors, assigning numeric values to the qualities of the coffee, like bitterness or acidity, and tasting for any defects in the coffee. We'll see an example of this in a bit. This is a screen cap on the slide from a video that was the world's largest coffee tasting, which was a virtual event put on by YouTuber James Hoffman, who I would strongly recommend if you're at all interested in coffee. In this video, he's doing part of this virtual tasting, and he's tasting 5 different coffees that have been prepared in the same way with a process that's formally called cupping, which is different than how you typically brew coffee for consumption. You know, one difference being that you actually are going to slurp the coffee from a spoon, like he's doing here. So on the right-hand side of the frame here, there's a sheet for taking notes and scoring the coffee. And this is where the magic happens as tasters annotate their experience and convert it into structured data. Often tasters will use a structured form or a protocol like this one from the Specialty Coffee Association. There's a lot going on here, so I'm just going to split up this form into 4 different parts. So one thing that's happening is they're doing a numeric assessment of flavor characteristics. So we've got fragrance, aroma, flavor, aftertaste, acidity, body. There's some descriptive notes of the flavors. So this one is very floral, silky body, beautiful aftertaste, extremely balanced. There are check boxes for any defects that are noted in the coffee. And then there's a final score that's basically the sum of all the points minus some points for any defects. So coffee tasters completing this form and doing a tasting is similar to annotating data. And the benefit for us is that they've been doing it for a long time and have these established methodologies that appear to be working. So now I'd like to transition into talking about practices in professional coffee tasting that I believe can be of service to those of us who rely on annotated data for data science. I'm going to talk about 5 different practices that exist within the world of coffee tasting and draw some analogies to annotation. All right, so first up is this idea of calibration and agreement. So professional coffee tasting sessions usually begin with a day of what's called calibration. What happens here is before evaluations and descriptions are formally recorded, tasters work together to come to a sense of agreement on what various descriptors and scale values mean. This is important because everyone has different backgrounds and tasting abilities and experiences that are going to merit the need for calibration. If everyone is proposing their own idea of what an 8.5 for flavor means, a large part of the value of tasting is going to be lost due to that inconsistency. There was an interesting example of this in the book that I mentioned. So typically when the descriptor orange is used in North America by coffee tasters, it refers sort of straightforwardly to the flavor of the orange fruit. However, tasters from India typically use the descriptor orange as an iconic descriptor, where it essentially serves as a substitute for the idea of good flavor. So this is just one of many examples of how interpretation and judgment can be influenced by sort of local characteristics of a tasting. So luckily with annotated data and with digital information, we have a way to measure how much people agree on the annotations and the labels. This is the idea that is called inter-annotator agreement or inter-rater reliability. And these are measures that you can calculate when you have multiple annotators labeling the same set of examples. When you're starting a new project and you don't know how difficult your annotation task is, agreement metrics can provide extremely valuable information. If two humans can't agree on how something should be labeled, your model isn't going to output consistent results, and you and your users want consistent results. Additionally, you're going to bias your training data set based off the individual whims of your annotators. So like imagine if we had a magical machine learning model to predict whether coffee had orange flavor or not. If half the data set's annotated with North American tasters and half with tasters from India, what is it exactly that we'd expect that model to produce? So starting a project with multiple annotators, calculating agreement metrics, and revising your project based on agreement, to me seems like a cheat code for successful machine learning projects. As an example of this, here's a chart displaying an agreement metric called Cohen's kappa and the F1 scores for that model, for a model trained on Google's Go Emotions dataset. Vincent covered this dataset a little bit in his talk. I think this data set is sort of like a mini dumpster fire, but one of the good things that they did do was have multiple annotators and calculated agreement measures on their annotations. So the goal of this task, just as a refresher, they're classifying Reddit comments into one of 27 emotion categories. So each dot here is the agreement score for a single emotion category on the horizontal axis, and then the F1 score from that model on the vertical axis. So there's super high correlation here. So hopefully it's clear that having multiple annotators and calculating these agreement metrics can tell you kind of early if your model is going to be trash. So if you agree with me that agreement metrics are awesome and you're using them on a project and find out you have a sort of poorly performing task with low agreement, what is it exactly that you would be fixing? So we'll talk about that as it relates to structure and process. So we saw that in coffee tasting, they have this form, this protocol. The form guides tasters towards what aspects of the coffee to pay attention to and how to pay attention to them. Coffee tasters also go through years of training and refining their perceptions and descriptions of taste. Essentially, there's just a deliberate effort to document and scale this task of tasting coffees and making sure this process is as shareable and consistent as possible. So here's another example of a tool that provides some structure. This is a flavor wheel. I know it's too small for you to read anything. Don't care about the details, or go Google flavor wheel when you have more time. This one's from Counterculture Coffee, and what it does is just lists out common descriptors or flavors in coffee in a hierarchical manner. So it's just a nice tool that coffee tasters can use. So for projects needing data annotation, the equivalent tool to the cupping form or something like a tasting wheel are called annotation guidelines. So annotation guidelines serve as your reference for how data should be annotated or labeled. Here's an example of one from, I just Googled annotation guidelines. There's this Time ML project And essentially, this is just a specification for marking up temporal events within text. So their annotation guidelines include detailed descriptions of all their tags, instructions on how to annotate with them, and most importantly, numerous examples of annotated texts. So without guidelines, it's difficult to know exactly what you're evaluating when you do something like a model evaluation. Your model could be performing poorly because of inconsistencies in your annotations on your training or your evaluation data sets. Now, this isn't a document that you need to have perfectly defined when you start a project. Your annotation guidelines could be developed iteratively over the course of the project and then solidify over time. You really want them to be finalized, though, by the time you're annotating what we usually call like your gold or your test data set. And you also want to be sure that you're reapplying those finalized guidelines to your training data for consistency. So speaking of iteration, let's talk a little bit about that. So this one, I'm going straight to the example. Here's a bag of coffee I had a few months ago. I've highlighted the profile of this coffee on the bag, and it says it is apple, toffee, and milk chocolate with a medium juicy body. So a natural question here is, is the flavor of apple actually in this coffee once I brew it and taste it? Is it my job to extract this inherent taste sensation from my experience while drinking the coffee? And that's certainly one way to think of drinking coffee as a task. But tasting notes in this profile here can also serve as a jumping off point for additional discoveries. So rather than being a specific experience I'm trying to extract, this apple flavor can be used as a jumping off point for additional discoveries. I might think of the flavor of apple, have a sip and try to locate that flavor and fail to do that. But that experience can lead me towards another flavor that I can experience more clearly. So I could use that experience the next time I take a sip and see if there's something more clear that comes through. This is the idea of operating reflexively. It's like bootstrapping your experience by adopting an initial task and then like revising it in a cyclical process. So we can adopt the same reflexivity in annotation and labeling data. If you have a new data set and a new task, and the concept or idea in which you're annotating is still sort of not well defined, you don't have to have your annotation scheme finalized or a production-ready model in order to use those tools to help you explore the problem space. You can just make up an annotation task for yourself that will give you exposure to the data and experience with translating this raw sort of data information into a structured task. It's fine to start with something simple and discover your task is actually something else along the way as you start to encounter more and more data. Your goal here is to understand the data through this process. Another place this reflexivity shows up is with model in the loop workflows. In this case, you will have trained an existing model that's making predictions on the data that you're annotating. Here, the reflexivity stems from using these models, the model's predictions, to better understand what type of data you might additionally collect or annotate. In short, you can perform a simplified task or intermediate version of your final task as a stepping stone to your final solution. Don't expect to get it right the first time. So this very formal protocol-based testing isn't the only kind of tasting around. There are actually 3 different sort of categories of tasting. I've covered descriptive tasting, which is this long process with the form. There's also discriminatory tasting, which is like tasting for defects. And there's also hedonic tasting, which is just tasting discovering whether a taster personally likes or dislikes a coffee. So these different tasting tasks get employed strategically, and we should be thankful for that. As lay tasters, we don't want to complete an entire form to determine if we enjoy a cup of coffee that we brewed in the morning. Suitability is important because it helps you not waste time solving the wrong problem. On the left here are examples of 2 types of defects in coffee beans, insect damage and fully black beans, which usually result from environmental issues like frost. Fortunately, these can be visually inspected for issues before the coffee is tasted. But if the process didn't include that task of checking for defects, these beans could get all the way to an actual tasting and we'd have people wasting their time with the wrong task, which is tasting coffee when there are known defects. In the same way, you have to think about the suitability of your annotation task relative to sort of like the use case for your model and the limitations of your data. So my favorite task to pick on, of course, is sentiment analysis. So let's say we wanted to know whether a movie review was positive or negative. I've got a real life example here from the movie Birdman, which I love. So this is just a paragraph from that review. Now, most sentiment models would just classify this text as negative. And we can work with this coarse sense of sentiment if it's valuable for our product to know generally how much people enjoy a movie. But if we're interested in a more nuanced characteristics of the movie, like the quality of the musical score or the cinematography or the strength of the weakness of the acting, a broad sense of sentiment isn't going to help us answer those questions. So here's an example of a paragraph later on in that same review that actually was overall positive, talking about the cinematography of the movie. So you have to align your raw data, your annotations, and your use case and make sure all these things sort of line up and that you're solving a suitable task. Another point here is that other people have mentioned is that you should always be assessing whether machine learning and supervised learning specifically is the right approach for your problem. You should be thinking about machine learning as one component of a larger system, not your whole system in itself. In the same way, it's not the job of coffee tasters to determine the tasting notes that appear on a bag of coffee or the description you might see in a coffee shop or how a blend might be successfully marketed. Instead, they're focused on trying to describe the coffee as objectively as possible and in a standardized way. All right, my last point is this idea of full stack collaboration. I apologize if this sounds like a weird management consultant buzzword, but it was the best thing I could come up with. So hear me out. So coffee farmers don't often taste their own coffees, actually. Typically, they're just trying to achieve the highest yield, which just means the lowest number of defects. So generally, there's not a lot of interest in positive taste characteristics. So farmers don't know exactly what they're selling a lot of times. This is one of the areas that people in the coffee industry are actually trying to change so that farmers can better understand what it is they're selling and improve their crops. And in the same way, I think machine learning projects kind of have some sort of communication and collaboration risk if this whole sort of team pipeline isn't working correctly and not everyone understands what the other one is doing. So the risk here is having a project that's sort of too heavily focused on one team in this diagram. So focusing on the left, I sort of have this thought that a lot of, when you look at a lot of organizations attempting to do machine learning or some research projects, they think the real problem is trying to find a cost-effective annotation team and getting data labeled for as cheaply as possible. And on the other end of the spectrum, you have spaces like Kaggle competitions that are framed in this sort of like sterile product management business problem perspective. Like you just get a problem and they want you to bring the data science and you can't ask that company to annotate more data or provide additional context. And then finally, data scientists and machine learning engineers or whatever you are. My green screen is tipping over now because I'm stepping on it. Whether you're a machine learning engineer or data scientist, we're also just as guilty as this too. I know numerous times, like I just want to get to coding. I'll just download a pre-trained model, get the data set and just go to town. And that is to my own detriment later, I've found numerous times. So, there's downsides of focusing too much on one of these groups. If data science doesn't have insight into the annotation task, you can waste a lot of time on a task that might make logical sense and have good annotation guidelines, but be poorly executed or result in a data set that's just not workable with machine learning. The data science team also needs to help incorporate model in the loop workflows to perform error analysis on early iterations of the model so that the task can be refined. Data science also needs to communicate with the product team. It's unlikely that the things that machine learning can do out of the box with a pre-trained model or framework is going to be a direct solution to your business problem. And it's important to have product involved in the annotation task because the things that you annotate are going to be the outputs of the system. You need to be sure that those outputs are relevant and meaningful to the product that you're developing. I would say it's not out of the question for everyone on any of these teams to annotate data at some point in a project lifecycle. I think the best way to understand the details of the data and the annotations relative to each team's goals is to actually do that process. So by neglecting to think about where our coffee comes from and sort of this process of coffee tasting, I think we're missing out on, delightful coffee experiences and aspects of our coffee that we weren't aware that we could enjoy. And in the same way, I think we're missing out on a lot when we ignore where our data comes from and fail to implement processes that make it better. It's not enough to accept your data as a given of a project and move on. If we care a little bit more about where our data comes from and how our data gets annotated, I think we can also have more successful and more delightful data science projects. Thank you.
Wow, thank you so much. This was that was that was really great. We got a lot of interesting speaker viewers. As you can imagine, many people in the industry drink coffee. So I think you picked the right analogy here.
It's good to hear.
So do you mind if we ask you some questions, Peter?
Let's go for it.
Okay. So here's a question from Nicole. She was asking about the orange example. And she was asking, is this the difference between orange as a fruit and orange as a color? Or how are the Indian coffee tasters interpreting orange?
Yeah. So first, let me preface, I think my primary answer is I don't know. I think that's a really interesting question about how these sort of like cultural and linguistic concepts sort of get formed over time. And I don't know the history of that. I hate to just point you to the book to go explore more examples of that in detail, because the book is like super long. So I'd only recommend it if you're like really into coffee. But he goes to a little bit of detail about how different cultures sort of use descriptors and come up with them, and sort of like how that influences the types of coffees that get produced from that country. But he doesn't go into a lot of detail about like how those actually get formed sort of historically, and like why. I don't know where that orange thing came from in terms of why that's the way it's described in India.
All right, cool. And by the way, okay, we're good now. We had a question about the slides. They're down. Caitlin, do you have a question you want to ask, or do you want me to follow up with another one?
Yeah. So you mentioned having a gold data set. And once people are used to annotating data and you're getting consistency, you want to make sure that that data set is really well annotated. How long do you find it typically takes, or what's the process of getting there?
To the gold data set?
Yeah, like, does it take a ton of annotating to get everyone aligned, or like, what does that look like? Do you have a silver and a bronze data set beforehand?
Yeah, we'll typically do that. We've even upgraded to platinum in some cases. So I guess my short answer is like, it's going to take longer than you think. But I think a key part of that you've sort of hinted at is that it is an iterative process. And I think there's a lot of ways that it can not really go wrong, but you'll just get divergent results from people. So even if your annotation guidelines are perfect, people could still have different interpretations like of your guidelines, or you could be bringing on new annotators that aren't like trained in your annotation guidelines or aren't as familiar with the task. And I do think also it depends on the task itself. I think some tasks are just more inherently difficult to get agreement on than others. And so there's actually an interesting paper that I'll post somewhere in Slack, but they had talked about how it might be nice to treat tasks as either like subjective or objective, and having that sort of deliberate structure up front and saying like, this is a subjective task. We're actually interested in collecting like how much people disagree and why they disagree. And the use case here is for, I think they were doing it on like toxic comments, right? So it's like everyone has a different sort of interpretation of like what is toxic or not, and what sort of language constitutes that. So I think, yeah, coming back to a direct answer is like longer than you think. And it's definitely an iterative process to get there.
Is there a way that you know when you've reached that point? Like, is there a measure of alignment that you tend to look at?
Yeah, so the nice thing about agreement metrics is they can give you that number. So there's sort of standards for agreement metrics that are similar to, like, they pretty much line up with what you think about like correlation values. So it's like 0 to 0.2 is like not very high, and then 0.2 to 0.4 is like okay. And generally it depends on what you're doing, but what I've seen is like if you're exploring a concept, like above 0.7 for agreement is okay. But if you're like really trying to attempt to annotate this thing rigorously, you want like 0.9 and above. Like you want people to be agreeing most of the time. And then those edge cases, most of the time, are also going to be they just sort of correlate with the cases that your model, might also be picking up on some ambiguity and have difficulty with as well.
Okay, cool. Thank you.
Yeah.
All right, we got another question for you. The coffee takes keep coming. Here's one from our friend Jeremy. He says, what's your flavor notes for your favorite data set you've worked with? So the flavor of your favorite data set.
Oh, that's a brilliant question. I think having, well, I think the idea of like this data sheets for data sets is probably like the gold standard. And I think having something like that for every data set, just having the notes, I think is really valuable. And I don't know that anyone's done I haven't seen anything that talks about sort of like the quality of filling those out, because I see a lot of data sets where, like, if you go on Hugging Face and you look at their data sets, it's like they've got the template there, but like the information's not filled out, or it's like a sentence copied from the paper for the data set, and it's like not really descriptive. So I think as far as like actually generating the tasting notes, I don't know that they're totally there yet. I would say like some of these standard tasks that have been around for a while, like named entity recognition and some of these like very large data sets, like they have really good annotation guidelines that are very thorough. Like that time ML one, it's like 40 pages. It's super long. And not that everything needs to be 40 pages, but I think just the fact that it shows that you thought about the task and you put in the time to document it for someone else to use so that they could actually understand it, really goes a long way.
All right. Well, Peter, I think we're just about at time. You have a bunch of other questions in the Slack if you want to head over there and answer them.
All right,
but
I will do that.
Before we head off, is there any last thing you want to say to the viewers at home or at office?
No, I just keep watching the talks. They've been awesome. The hosts have been great. Thank you to all the MCs and all the other volunteers. It's been awesome. Like I thought I was going to pop on and watch like 3 talks, and I've just been like glued to the stream all day. So awesome content and talks from everyone. And thanks everyone for putting it together.
Thank you. All right. Well, Caitlin, I didn't even get a chance to welcome you in. But Caitlin, thank you for joining me as co-MC for the rest of this session. We're very glad to have you here. And we've got another speaker coming up our way. It's Katie Bauer. And yeah, so I'm just going to introduce her with her slides so that she gets the intro she deserves. All right. Here we go. All right, so we are gonna transition over to Katie Bauer's talk on how to translate to PM speak and back. Katie is the head of data at Gloss Genius. She once broke prod by shipping a data pipeline containing too many emoji. So that'll be a good story. All right, Katie, when you're ready, you can take it away.
Cool, thank you. And the emoji story is unrelated to what we'll be discussing today. That's more of a tale for another time. All right, these are my slides. Cool. Wait, can you see them?
Yep.
All right. So hello, everyone. I'm Katie Bauer. I am currently the head of data at Gloss Genius, a company that is used by independent owner-operators of beauty salons to run their businesses. Prior to that, I have run and built teams at companies like Twitter and Reddit, and I've also spent a lot of time attempting to communicate with PMs and sometimes even doing it successfully. That's kind of what we're going to get into here today. An original concept I had for this talk, by the way, was to conceptualize PMs as some kind of weird and vaguely hostile alien species. I could not think of how to extend that metaphor for 20 whole minutes. So unfortunately, all of the DALL-E mini generations that I created for it will go unused. Perhaps they can be released at another time. Instead of talking about PMs as aliens, I'm instead going to begin with a story, kind of a personal experience of my own, beginning many years ago. Originally, for a lot of my early career, I worked in sort of a help desk situation. Many of you are probably familiar with this kind of format for running a data team. You kind of get low context requests from people all across the business, perhaps through Jira, perhaps through some other ticketing system. And this was really how I ended up collaborating with stakeholders for the first couple of years that I worked in data. And it was fine, but I very rarely had context for what I was being asked to do. And it was a lot of just go and execute. And about the time that I was entering mid-career, I had gotten a new job where I officially had the title data scientist. I was very excited about this, and I was moving into more of an embedded structure. And by that, I mean, I was someone who, as a data scientist, sat on a product team. I attended their stand-ups. I would get tagged in on PRs and sometimes review code. And I was expected to have opinions about how the product should be built. And this was very exciting to me. It was something that felt like science, as opposed to just kind of being asked to pull data for people. And this was also notably the first time I worked closely with PMs. And one of the most exciting things to me in particular about this role was that the company was starting to run A/B tests. And when I say they were starting to run A/B tests, I really mean they were really just starting. They had a way of randomizing users into experiment buckets, but they didn't have really anything else. So that meant that when they were trying to run an experiment and they weren't sure what to do, the answer was usually ask Katie. And for me, this felt like a great opportunity to have impact. And an A/B test, is an opportunity for me to use real statistics and do something that really truly felt like science. So I got very excited and I got very into the whole idea that I was going to help them run rigorous experiments. I came up with templates. I would ask them to pre-register their hypotheses. We would calculate rigorous sample sizes to make sure that we were really achieving statistical significance on all the important metrics. I even started developing data pipelines to pre-calculate experimental metrics. It had an official name, the standard battery of metrics. So important, so official. And I would get requests from the product team to go and calculate and help design an experiment. And I would come back with extremely specific answers. Like I would come back and say oh, well, you need exactly 11,567 users for this to work. And they didn't like it. They were so overwhelmed by the level of detail that I was giving them that I may have been speaking a different language. And it ended up being kind of this weird pattern where they would ask me to do something. I would run off and go try to get a really precise answer, design a really robust experiment. And then their response was, well, let's just keep things simple and use 5% of traffic. And this was extremely frustrating for me. I'm a data scientist. I have a deep capacity for being pedantic. And I wanted to put that pedantry to a productive end. But for the most part, I was just really not doing the right type of work to work well with these PMs. They would ask me to do something, I'd go run off, try to get something very precise. And by the time I finished, I would come back and they had moved on, or they would only use what I gave them about half of the time. And it ended up putting me in just kind of a really bad relationship with a lot of the PMs that I worked with. And it continued to be this way for many years. I just didn't understand what they were looking for. I could not comprehend the reasons why they would ask me to do something and then not use what I did. I could be doing so many other things with my time and with the company's time that it felt like a waste. And I started actually having a somewhat adversarial relationship with product managers that I worked with. Requests felt antagonistic. It felt like they were trying to get things out of me or work around me. And I just could not comprehend how to talk to them in a way that they would understand. Eventually, I did have a mentor pull me aside and give me a piece of advice that once I heard it the first time, I started hearing it all over the place. And that was that I should assume good intent. For those of you who haven't heard this advice, it's very good advice. It's basically thinking about the people that you work with and assuming that you are on the same team. Like you might disagree on particular things, you may not work at the same pace, but you should assume that they are trying to do the right thing, that they are trying to do the same thing as you. And they're not trying to intentionally like cut you out of the loop or do anything like that. And while it did not necessarily help me understand PMs better, it did help me start improving my relationship with a bunch of them. And over time, things became more cordial, more civil. But it was not really the end of the story for me. Things didn't really change for me in my relationships with PMs until I ended up working with a PM whose team was in trouble. And I don't think he would characterize his team as having been in trouble, but this product team was very much like the Defense Against the Dark Arts position in the Harry Potter books, where there's always a new professor every year. It's like it's kind of cursed for whatever reason. Something bad always happens to the people who run that department, and something always happened to people who led this product team. And there's often churn in their engineering and design leadership. And this product manager had just come into a really bad situation. He'd had departure of other leadership that he was working with. And as the data science lead working with him, I was the closest thing he had to a peer. And it meant that we ended up talking all of the time. And we both felt pretty stressed about the situation we were in. We were really behind on a goal that had been set earlier in the year before either of us joined. And we didn't really feel like anyone understood how well this project or product worked. So a bunch of our conversations were just brainstorming and trying to really understand and iterate and get to a place where we could tell a better story about how we were turning the product around. And the fact that I spent so much time talking to this PM actually ended up helping me get into his frame of mind and understand something different about him, which was not just his good intent, but also his incentives, which improved my relationship substantially. We talked all of the time, and eventually I began to understand that for him, one of the biggest pressures he was under was that the head of product wanted to cut this product. He thought it was doomed to fail, and this product manager that I was partnered with, the thing that he wanted more than anything else was to prove that he was in control and could turn things around. And it led to me eventually amending that advice that I had received earlier in my career, which was not just to assume good intent, but consider incentives if you want to communicate with people better. It ultimately turned me into a place where I realized that if I wanted to speak the language of incentive and work better with PMs, I needed to realize that I had been really overly oriented on details, kind of missing the big picture. and learn that product managers frequently speak a language of progress. This image on the right, I couldn't find a good picture for progress. So you get this transcendent a moment in time. So if you want to speak in terms of progress and work better with PMs, I have a couple of pieces of advice about how you can think about doing that. The first is to remember that most questions that PMs ask you are implicitly causal. It doesn't even necessarily have to be in the context of experimentation. PMs are always concerned about figuring out what buttons they can push and what happens when they do it. So when a PM asks you to do something for them, whether it's analysis, design an experiment, whatever you end up doing in partnership with them, the number one thing that you should remember is to focus your work on things that they can control. If they want to know how something works, the reason that they're asking you for that is because they want to change it and try and hit a goal or achieve some kind of outcome for the product that they're building. So you should try to do analysis specifically on those things. If you include exogenous factors or macroeconomic conditions, it's only to count them out. And you should really start telling stories around things that happen when they change things they can control. Similarly, you should prioritize logical consistency in your analysis over being technically correct. You don't necessarily need to get them the most precise answer. You need to get something that is in line with actions they would take, with the company's values, with the company's roadmap. Those are things that are actually going to help you say things that PMs will be able to contextualize and use and increase the chances that they will listen to you. And then a final way to kind of put a ribbon around this paradigm or this way of thinking that a lot of questions are implicitly causal and about actions that you would take is to describe your results specifically in terms of inputs and outputs. Regression coefficients are an interesting example of this, talking about how if you include or if you increase one of the input variables by a certain amount, what likelihood that is about to have on the output variable. Like that's a way of turning something into a story. So like if you say, if we spend for every, like for example, like every $1 additional we spend on marketing spend, according to like a regression coefficient or an experiment coefficient, that would result in 10 additional sales, like something like that, like giving them a good example of an input and the output that they would be likely to receive on it is a great way to increase the chance that they will hear what you're saying and take it into account and be influenced by it. A second step is to plan your work according to the positioning of the PM. And by this, I really mean their positioning in the product organization. Product organizations, from the outside, it can be kind of hard to understand that they are all sort of in competition with each other. Mostly for resources. They all report to the same people. They all end up getting things from the same budget. And it might not explicitly be cutthroat, but it is important for them to look good in front of their peers and to their bosses. And if you want to build alliances with product managers, you need to think about how you can help them tell stories associated with their products, specifically based on what kind of product that they are working on. In my earlier example, the product manager I was working with was working on a struggling product. And one of the things that we ended up doing was quantifying the type of loss that we were seeing for the company and actually figuring out what we could do based on things that we could control to try and staunch the bleeding. Telling that story helped us get buy-in from the head of product to better resource us and change the way that we were perceived at the company. Things might be different if you're working on a successful product. Hopefully it's easier. There are a lot of different ways to tell good stories about successful products. Maybe it's talking about the quality of the users who are already using them and the good things that they do for the site. It's trying to find complementary opportunities related to that existing successful product and trying to position the product that you're already working on as key to moving towards those complementary opportunities. It's all about trying to make sure you figure out ways to expand the success. And as you're doing analysis and modeling and designing experiments, try to think about how you can position your work towards telling a story of success. Emerging products are probably the bread and butter, and there's way more of a playbook of how to support and tell good stories about them as data scientists. It's really all about product market fit. So for users that you are acquiring, like how long did they stick around? How much did it cost to acquire them? Helping product managers tell those stories when you're working on an emerging and new product, that is a great way to help gain their trust and communicate better with them. A final thing to know when trying to communicate with PMs is that in many cases, there is no perfect translation. And I mean this partly in a way where like there's no English equivalent of the word hygge. There's no PM equivalent of the word statistical significance. Hygge is like an idea of like coziness or comfiness from Danish culture. Like there's a lot of cultural baggage wrapped up into it that can't be easily communicated in one word, much in the same way that there is a bunch of technical knowledge and cultural like field practices wrapped up in statistical significance. And it is not important for PMs to understand this. It's something that you can still communicate well with them, even if they don't understand all the technical details. And this can be a really hard thing to balance when your job is to add rigor to a situation. So if it's helpful, think about some of your recommendations sometimes as being more guardrails. For example, on the opening anecdote that I shared about trying to calculate precise sample sizes, the PM ultimately did listen to my advice, even if they did not listen to it in a very specific way, because the 5% of traffic was enough that we were actually able to meet the sample size that I recommended. And I was frustrated that they hadn't specifically listened to me, but they still got the gist in a way that helped them make a good choice and ultimately reach an outcome that was rigorous enough for what we were trying to do at that time. Really, what you need to do is make sure that you are careful to pick your battles of where you want to introduce rigor and insist on accurate translations when stakes are high. If the cost of a choice is very high when you're wrong, if it's really hard to reverse the choice that you're about to make, then that's a good time to apply a lot of rigor and move carefully and be slower. But you don't always have to do that. Sometimes a Google Translate level translation is all of you need, all that you need to communicate well with a product manager. And that is okay. They don't have to always understand the specific details that you're getting into. So if you take time to carefully consider these things that we've talked about, you don't have to have an adversarial relationship with a product manager. In fact, you can build strong friendships with them, even if they're a little different from us and maybe can frustrate us sometimes. The alliances between data science and product managers are some of the strongest that I've ever seen, and some of my best working relationships have actually been with product managers that I've worked closely with. So with that, I will call it and be ready to take questions.
All right. Thank you so much. Caitlin, do you want to start off with a question?
Sure. Yeah. So I'm curious about learning more about PM incentives. And when you're going about that process, do you have any go-to phrases or questions that you use to dig a little bit deeper into what they're asking?
Yeah. The things that I like to think about are how they will be evaluated. So it's kind of like, what are your OKRs for this quarter? Like, what are you trying to do? Like, what are your goals at the company? Like, depending on the person, you can like ask them like, are you trying to get promoted? Like, who's your boss? What do they care about? Trying to just get a sense of like how they exist within their broader organization, who they work well with, who they respect, how they want to be seen. Those are the types of things that I would start probing at.
Okay, so we've got a bunch of questions here. This one's I don't know if it's a toughie, but I'm going to ask it. This person, Lev, asks, what is an example of something you communicated which was logically consistent but not 100% technically correct?
Yeah, that's a good question. I think sometimes like categorization can be a good example of this, where maybe there's some nuance in categorizations that like maybe there's a lot of subcategories, maybe there's like a like I'm trying to think of a very specific example and I'm struggling to on the spot, but like sometimes it's like fine for them to get a high level, like, yeah, this is like what a power user is. And like, maybe they don't understand all of the like things that get filtered out of, like, maybe there's like bots or something in a power user metric that like they get captured because of some level of activity. Like they don't need to always say like power users, not including bots. That kind of thing can be a good example of just when they say power user, they're not thinking of automated things. Like in their mind, they're mostly concerned with humans, and not needing to like specify every time you do talk about something like that can be maybe an example of it.
Awesome. Another question here. How do we get PMs to understand the power of data when working with PMs who are new to working with data science?
Yeah, that's a good question. I mean, in many cases, when someone does not understand why they would do something, a powerful weapon in my experience, maybe weapon's not a good word because I'm trying to de-escalate the hostility, but it's to help them do something and then feel appreciated for it. So finding a way for that PM to introduce data to a conversation, like maybe it's not even in a conversation with you, but like you arm them with data that they can then take and use in another context and look good because of it. That's a very powerful way I find to help them feel bought into the idea of data. Like it helps them get something. It helps them be useful. And if something is useful, people will use it.
We got another question over here from Emily. Emily asks, do you have opinions on structuring a data science org as fully centralized, as in data science works with different teams, partially embedded, as in data science reports to data science but mapped to specific teams, or fully embedded, one data science report to like a growth manager, another to market, et cetera?
Yeah, I do not think data scientists should report to non-data science leaders. Like maybe they could report to like a data engineering leader or something, but I don't think they should report into marketing or product or that sort of thing. At least if it's not like the senior most person. Like at the end of the day, like some person in the data science organization is going to need to report to someone who's not a data scientist, whether that's a CTO, a CEO, a CFO, whatever. But like my strong orientation is towards hub and spoke teams. I think data scientists do very good work when they have high context for the areas that they're working in, and embedded structures do that well. Because if they're functioning like a member of that team, like they share goals, they're in the same meetings, they know about problems and conversations when they're happening from the start, and they don't get looped in last minute. I think that's a really important thing to creating the right, I mean, speaking of incentives, like it creates a good incentive for the data scientists to care about the business outcomes of the area they're working in. That being said, consistency is a big part of rigor, and it's much easier to have consistency across different parts of your data science organization if they all are a part of like one team, even if like they may have specific things that they work on with their partner teams, but then there's shared rituals and practices and resources that are a part of their centralized team, if that makes sense.
100%.
Yeah, definitely. We have more questions coming in, so we'll go to the next one. This is from Nick. Do you have any advice for collaboratively getting on the same page when PMs do seem interested in discussing details, but there are some misconceptions or miscommunications that might impact the decisions they make? I'm thinking, for example, about precision and recall trade-offs.
Yeah, I mean, like this is a situation where examples, like concrete story type examples, really help hone in and help them give something specific to anchor to. Like one thing I find with technical details that can kind of confuse people is having no real experience to tie it to. And like when you give them a real example, like even if it's just like kind of silly or goofy, that's something that like it makes it real. It gives them something else to attach it to and can help them start getting into the technical details. The other thing I'll say about like if someone wants to start getting into the weeds, like trying to figure out what is the appropriate level of depth is always a challenge too. And And like that, I don't know if I have like really general advice beyond like what is something that is like kind of pushing them slightly beyond the level that they're giving to you is probably a good place to start. Like whatever they're starting with, try to go a little bit further and see if they're able to follow well. And then if they are, like you can keep pushing and seeing how deep you can go.
Okay. So one question is, how do you break the news to a PM? They sort of need to accept that no matter how much they want the data to show one thing, it's just not going to show the thing they want. They want the chart to go up, but it's going down, or vice versa.
Yeah. I mean, like in a situation like that, depending on what it, like if it's a really serious thing and they need to like accept that something was like a big failure, like that's something you handle a little bit differently and more delicately probably. But in a lot of situations, like sometimes PMs just want to do something and the data doesn't support it. And in that situation, I recommend actually thinking for yourself, like, is this a battle I want to fight? Is this a battle that's worth fighting? Like sometimes they have expertise that like maybe their intuition tells them something's up with this data and maybe they're right. Maybe you're not measuring something in the right way. Or sometimes it's just not that important. It's kind of a minor thing in the grand scheme of things. So like taking time to consider, like, is this a battle worth fighting? Being willing to accept that like maybe they know something that you don't, those are helpful. And then when it is something that's actually pretty serious, that's a situation where if the PM is really disagreeing, you might want to like seek out outside allies who can help you kind of get on top of and maybe persuade the PM to see things from a different perspective, or at least hear additional voices. Because of course the data person, so I was going to say, listen to the data. But if maybe their engineering counterpart or their design counterpart also is worried about it, maybe that would change their mind.
That's solid advice. Another question we're getting, how do we as data scientists work on a team with a PM, but not end up just building reports?
Yeah, I mean, for me, the key thing is that you have to be curious about the business outcomes and be willing to take questions a little bit further. And like this might feel like sort of a like, when am I going to do this? I don't have any extra time. But it's partly like having the sense, like having the context to know like this question that they're asking you is not an important question to dig down, or it's not the highest priority question to dig into at that time, and feeling comfortable telling them like, I actually disagree. Like, I think we should look at this other thing first and do this other thing. If they are someone who's actually good to collaborate with and you like have good perspective, like hopefully they'll be persuaded. Like it's treating it like a negotiation. Like you're trying to get to the same outcome as them. You're a co-equal in trying to achieve that goal, and pushing back and saying like, I actually think this would be more valuable for me to do rather than build you yet another report. That's a good start to starting to change the nature of the relationship.
All right. Well, you actually have a bunch more questions in the Slack if you are so willing to go and talk to people. But it's a lot of people in there.
These people are way more in my lane.
Exactly. But before we transition to the next speaker, is there anything you want to tell people at home or in the office?
No, I mean, just remember your coworkers are on the same team as you. They can be annoying sometimes, but they're your partners, they're your friends, they're people you will certainly encounter again later in life. So always act like you're on the same team.
Thank you. All right. Solid advice. Really appreciate it. And thank you again for speaking today.
Yeah, thanks for having me.
All right. Well, here we are. We are going to be transitioning to our next speaker. And this one is, it's going to come out of the blue here, but we have someone you might not be familiar with. Her name is Caitlin Huden, and she's going to be talking to us today. She's a data scientist at Figma, and she happens to already be on the Zoom.
Ooh. Lucky.
Yeah.
Let me set up my slides and just make sure that you can see everything.
Awesome. Take your time. And if we need to go to ChatGPT, it's always in the holster.
No, no, no.
Please God, no. All righty.
Okay. Are you able to see it?
Yep.
Cool. Okay, happy to get started. So in the spirit of NormConf, I thought that we could kick off with a good vintage tweet, which happens to be a favorite of mine. A wise man once pointed out that when you find yourself doing the same thing multiple times, you should move toward automation. I love Dave's second point here, which is when you find yourself answering the same questions, you should consider automating your advice. Today, I want to talk about frameworks for efficiently conquering the unknowns that stand between us and getting things to production. So these are things that I've seen happen over and over again, and I'm trying to come up with some ways to combat some of the unknowns as we're starting new projects. For example, taking a machine learning model from idea to production often involves similar steps. So the data and the specific application might vary from project to project, but I know that at some point I'll have to get some data, spin up a notebook, and build something. And I can't fully automate that process, but I can find patterns in some of the thinking that drives each step and try to get more efficient that way by focusing on some of the patterns I'm seeing. The best way I've found to automate things that don't fit into a function or a package is via frameworks. And so that's why I want to talk about frameworks today. Frameworks are especially helpful for automating workflows around organizing my thinking and working through problems. They're boring, but they work really well and they make my life easier because I don't have to remember things. And so I feel like they're very NormConf. I'm at Figma now, but previously worked at Online MedEd, which is a medical education company, and they created hundreds of online videos on various topics to advance a flipped classroom model. In order to scale, we had to match our curriculum to that of med schools and governing bodies to make sure that our material covered all of the same points that they expected us to cover. This was a really fun problem because, as Tolstoy foretold, each unique syllabus is unique in its own way, which in this case means that lessons are named very differently. They're parceled out differently in terms of how they're covered across different syllabi, and they definitely didn't match the lesson names that we had in our training data. So the manual version of matching syllabi with our curriculum involved a very knowledgeable medical subject matter expert reading a lesson and some of its key points on the syllabus, then searching on our site, which included keywords, but not like the full text of all of the videos, and scrubbing through those videos that matched to see if it was really a match and how fully it covered each of the lesson subpoints. You can imagine this is not ideal. And so we thought that maybe automating this matching process via machine learning would be really helpful. So here we've outlined this tool that would give the person the top N lessons to check first based on looking at the full content of each of the videos. And so this would significantly improve our ability to scale the process. And so this is what we proposed. This was the first machine learning model that we built at Online MedEd. So there was a ton of uncertainty around the project. The biggest open question being like not knowing whether the type of classification we wanted to do would even work with our data. Like, was our data big enough and unique enough at the lesson level to actually do classification? Was a very open, important question. At the time, we were also doing a big rewrite of our code base. So there were also questions around where the model would eventually live and dependencies and whether we would be able to roll it out. Anything that I could do to reduce uncertainty, both for stakeholders and for myself, was really helpful here. So I wrote a lot of documentation around like inputs and outputs and what those would look like, what the architecture could look like in order to build buy-in. Once we had buy-in, we decided that the best course of action would be to build a proof of concept. And so I decided to try a couple of frameworks out in that process to see if we could do it like more quickly than I had moved on previous projects. So with any project model code base, you have a couple of kinds of unknowns. Known unknowns are the things that you know you don't know. If you started a list of things you don't know, you could slot those things into the list. These are more manageable than the other kind because being aware of these gaps means that you can plan for them. In machine learning, this could be knowing that you don't know which type of algorithm you're going to apply, or knowing that you'll have to apply data transformations, but not being sure which ones. Unknown unknowns are the things that you don't know. So it would be impossible to list those things because your unknown unknowns are by definition unknown to you. You learn about these things as you're working through problems. And so a lot of them just kind of come up in hindsight. These are things that you didn't know. In a machine learning context, these could be things like dependencies that you definitely need to consider as you're implementing something, but you weren't aware of ahead of time. Today, we'll focus on two frameworks that help speed up the process of getting ML to production, or analyses, or dashboards, or new features. You can kind of insert your own thing here by efficiently conquering unknowns. So we'll start by tackling the known unknowns. How do we capture all of those things that we don't know and use that data to be more efficient? So we can borrow an idea from professional poker player and master decision maker, Annie Duke. Annie suggests that we start with a pre-mortem. So that's what we'll do. In order to tackle unknown unknowns, we want to make sure that we're not going to like trip over them. And so we'll dive into the second framework here, which is tracer bullets. We'll talk more about that in a minute. So we'll start with pre-mortems. What is a pre-mortem? A pre-mortem is an opportunity to predict possible outcomes for a project. Practically speaking, I think like the benefit you get here is a list of known reasons that a project could fail. This is a really good time to put all of the known unknowns into a list and figure out if anyone might be able to help you with answering some of those questions. If there are doom factors that would render a project like a total failure, missing a key deadline, for example, this is a really good place to discuss those things. I also want to note that I'm kind of framing this as a team exercise, but I found it really helpful to do pre-mortems even as a solo exercise as I'm starting projects. I've also found that interviewing subject matter experts and using that as documentation is juice that's very worth the squeeze. So I'll often include pre-mortem-y questions about like where they think there might be areas that we need to be really careful about as I'm working with subject matter experts. And taking these things together and like building this list is a really good way to take all of the strands of the things that you know and like braid them into a constellation that will guide the work. So the idea of a pre-mortem is pretty simple. I wanted to show an example. This is Annie Duke's recommended format. She also adds sections around luck and skill. Coming from poker, she has this really interesting take on decision making, and especially in her world, you get feedback really quickly. So she's gotten really good at increasing the quality of her decisions while making really high quantities of decisions. And so I do like that framing. I didn't include it here, but you could. If you're thinking that this looks like a prioritization exercise, especially because of that column on the right, I would agree. Besides like getting the concerns into one place, it also gives you an idea of which places you might want to focus on first. I love a pre-mortem because I'm very good at guessing how things might fail. And this is a rare opportunity to use that talent in a safe place where it is advancing the discussion. So they give people the opportunity to voice concerns without detracting. And I think that's super important because concerns are typically evidence of past experiences, and learning from experience is one of the best ways for us to be better and more efficient in our work. So I love writing a pre-mortem. Now that we've accounted for known unknowns through the pre-mortem, we're aware of some things that could go wrong, and we know where we might get tripped up. So armed with that knowledge, we can start building. To do that, we can move to our second framework, tracer bullets, for efficiently dealing with unknown unknowns. So last year, our engineering department read The Pragmatic Programmer as a book club. This is a collection chock full of practical advice built on years of experience, and it's solidified itself as an industry classic. I feel like it's very NormConf. The stuff in there is not necessarily groundbreaking, but it's a really good read. It's something I wish I had read a lot sooner. Anyway, I loved it. I highly recommend it. And I've since adapted some of the ideas there for my own machine learning projects. And so specifically today, I want to talk about the idea of tracer bullets, which come from this book. So outside of a code base, in real life, tracer bullets are bullets that are loaded at intervals alongside regular ammunition. When they're fired, phosphorus ignites and leaves a pyrotechnic trail from the gun to whatever they hit. So you can see the path that each bullet takes and how close it gets to a given target. These are particularly useful for quickly refining your aim because they provide real-time feedback under actual conditions. You're shooting these alongside anything else that you would be shooting. When you're building something that hasn't been built before, tracer bullets can visually illustrate the need for immediate feedback under actual conditions with a moving goal. So what does that look like in a code base? This is the visual that's in the pragmatic programmer. So each bar here represents a layer of logic, and you can see the tracer bullet goes through each layer of logic. When it intersects each layer, it carves out a small end-to-end path through all of the layers. The goal is to get through each layer with the absolute minimum amount of logic required before moving to the next one. So if we think like Peter in his earlier talk, we can say that we're building a bridge that's cheap enough that it barely stands, but it does stand. Tracer bullet code operates in the same environment and under the same constraints that actual code would. And the focus on using tracer bullets in development is to get to the target quickly for more immediate feedback. Because tracer bullets don't require building a full project, they're a relatively cheap way to test an implementation. And so that's why we wanted to test them with the project I was working on. So I've translated this a bit to tracer bullets in machine learning. So we might start with a data pipeline, actually getting the data that we need to use, and then work through feature extraction. How do we make sure that we can get the data to a place where we can put it into a model or algo? Then we actually need to build the model or algo and deploy it, start to apply. In this case, it was doing classifications, so starting to actually do the classification on data and put it into an API or somewhere that you can access that, and then put like a front end on it. So how are we going to make sure that we're getting this stuff into the hands of users or whatever system is going to use the outputs? A couple of additional notes on tracer bullets and like how they're different from prototypes, because this is something I didn't understand until I read it a few times in the book. With a prototype, you're exploring specific aspects of a final system. And so you typically will throw that code away and recode properly once the lessons are learned. So if you've seen something like a design sprint, you kind of want to have something that you can show to stakeholders by the end of the week, and you might not be actually coding a whole thing. It's really just important that they can see like the UI or the front end or that last step. This is about answering questions along the way with the implementation. So you're doing like the minimum implementation possible so that you can see how your entire system works end to end. So tracer code is lean, but it's complete. And it forms the parts of the skeleton of the final system. Once you have this skeleton built, I could choose to go work on like the tail for a while or the head for a while or flesh out the middle. But the entire system will continue to work with the tracer code framework. So this is where I needed to aim my tracer bullet. This is a quick architecture diagram from an early stage of the process and kind of what we were doing. So we have ETL logic, we have SRT files. These are like text files that are taking everything that's being said in a video and transcribing it. So that's all the text data that we're working with. We need to build logic to process that data and then to train the classifier. You need to actually get a classifier that works and is good enough for our use case. That was one of those open questions that we had. And then we need to be able to output the closest lesson. And so this is the example of the stuff that we wanted to deliver. A lot of this lived in a Jupyter notebook. We actually decided to put like a front end on it so that people could interact with it. But I think having this clear path for like, I need my tracer bullet to go through every single one of these layers was really helpful to answer questions that we had around architecture and like, would this thing even work? So firing the tracer bullet, we built the data pipeline, did feature extraction, built the classifier, started doing classifications, made sure all of that stuff was up to spec, and then added the front end. But something important here is like what's left after the tracer bullet. So if you look at like the pink area, that would be the part that was included or the part that was coded out as part of the tracer bullet. There is lots left to do at each stage here. So for example, the data pipeline, I didn't grab all of the videos or the files of containing like the text transcriptions of the videos. Some of those were still left on the table. They weren't necessary for the implementation. Feature extraction, some of the work that we were doing around like tokenizing, stemming, et cetera, we could change in future iterations, but we had like enough to build a model that was a good proof of concept. The machine learning code, we had a good idea for a model that worked. Obviously, that's something we could go back and update, but having it as part of the pipeline was really important. And then the API and the user interface, we were able to get feedback on. And so if there's anything that we needed to change, we would be able to do that pretty easily. And so this was really helpful to have an idea of just like, we're leaving some things on the table to come back and do, but also this doesn't mean that we're waiting, for example, for the entire data pipeline to be built before we're moving on to the next thing. So the advantage is that you can get to delivering something or shipping something faster, which is really helpful for stakeholder management too, especially if you're working with something where there's a lot of open questions. I built this slide about tracer bullet driven development. And so this would be like, let's say you had 5 checkpoints and you were working as part of a team. If you look at this first approach, this is if we're building sequentially. So we start with like the data sets and then the feature engineering and then the modeling and then serving the model and then having a front end. That takes a long time before we're actually seeing results and having an idea for whether the thing works or not. But if we take that same amount of work, if we assume it takes the same amount of work at each checkpoint, we can see that we're delivering like a V1, the first checkpoint, and then V2, and then V3, and 4, and 5. And so from a stakeholder perspective, this was really helpful to be able to say like, oh, look, we have this thing working end to end. We're going to improve the accuracy. That's no problem. It's just updating information in like steps 1, 2, and 3. So I really liked using the tracer bullets, especially for working with stakeholders and reducing uncertainty for them. And the other nice thing about using these 2 frameworks together is so the known unknowns, once you have those and you know the areas that could trip you up, you can build your system around them and make sure that they're included as part of the layers for the tracer bullets. So you kind of know based on those, like what are the layers you need to fire the tracer bullet through. And then you're able to fire the tracer bullet, make sure that you're accounting for at least everything you know about. That gives you the opportunity to find things that you didn't know about because you're actually building it. That always happens. You're always going to have surprises. But it gets you from the start of the project to the end of the project a lot faster and with some check-in points where you can offload information or share information. And I found that really helpful and really exciting. It's something I want to try more and more with future projects. And so I wanted to say thank you so much to the NormConf organizers for getting everyone together. This has been great. I've been watching all morning. I've been loving it. For anyone who wants to learn more about these topics, there's a couple books that I recommend. So I talked earlier about The Pragmatic Programmer. That's a classic. It's really good. Annie Duke's Thinking in Bets is also fantastic. She has a couple of other frameworks that I've used, things like backcasting. So if you have an idea of what success looks like, similar to like Amazon's PR approach, where they start with like, what does the press release look like? And then you work backwards. She basically applies the pre-mortem, but to success. So if we're successful, what are the points that we have to hit along the way? So those books are great. And if you want to learn more from me, I'm at Posey on Twitter and Rexis.social. And I also have a blog at caitlinhuden.com.
All right, that was great. Thank you so much. We have a few questions for you if you want to stick around.
Yeah, absolutely.
All right. So we have one question from Wahid. He says, what is the difference between a minimum viable product and a tracer bullet project?
That's a good question. So in the project that I worked on, we fired a tracer bullet, but I would say it's still a proof of concept. So this isn't something, when I think of an MVP, I think of something that you're shipping. And so at the end of the day, trying to get this thing shipped out, I think tracer bullets could definitely work there. Like, what's the minimum amount of features that we need to have in order to ship this thing? But tracer bullets can also work for proof of concepts, which is the example that we used here.
Okay, and we have one more clarifying question. Might as well just ask it in tandem. Alice asks, is a pre-mortem different to a risk register?
Oh, I haven't done a risk register, so I'm not sure.
Yeah, me either. I've actually never heard of that one.
No, I'd be interested to learn more if you want to type more.
Okay, well, Alice, if you have any further questions about that, we've got more time for some questions, but we're both not quite familiar with that one. Me personally, I'd actually never heard of pre-mortems, so I have a question about it. Actually, I have a few. But like the first, it's like, is this a common thing that companies do, or is this like it's starting to be a new thing? I've never encountered it.
So we read Thinking in Bets as part of a book club at the company, and then we started applying the pre-mortem framework within the company. And so I don't know that it's catching on a bunch of different places. I just know it was a framework that worked really well for us. And especially for me, like when I'm doing projects, analysis projects, machine learning projects, I often have a ton of inputs, like notes that I've taken on different ideas from different places, or notes about features, or notes about requirements. And being able to go through all of those notes and just say like, oh, this is a potential point of failure, this is a potential point of weakness, has been super helpful. So yeah, it was like best practice for us to do it at my last company, but then I've also totally adopted it as part of my own personal workflow.
All right. And before I ask a couple follow-up questions, mind taking the slides down? Want to talk to you?
Yeah.
With face on the screen. Okay, awesome. Thank you. So we got another question that's coming in before I follow up with mine, which is this one's from Roger. And Roger asks, how does one do a pre-mortem if they've never died before?
That's a good point. I think it's a good place to talk about your fears. So maybe you haven't died, but maybe you have a fear of death. Maybe you've seen some areas where you're a little nervous about your project and whether it could succeed. Like for example, I don't know if this made it into the presentation or not, but if you have a big deadline that you need to hit, like we had a busy season. And so to make a tool for onboarding, it really would have the most impact if you're delivering it before that busy season. And so I don't need to have died before to know that like that's really important and something that I need to account for as I'm thinking about ways that the project could go right or could go wrong.
Well, major props on that improvisational pivot. That was really great. Okay, so Claire has a question about this as well. Claire asks, apologies if this is obvious to others, but how does firing a tracer bullet actually work in practice? Like, is it a known data point that you fire through your ML model and see what happens, or some extra functions you write to log the state of the data frame at each stage of the model pipeline?
It's basically like building the pipeline that you want to use. And so for me, it was using like a subset of features, but I think of it almost as like an integration test, like you're making sure that things run across systems. And so it's really good at catching where things might be disjointed or where things might drop out in your system or need to be like accounted for or bridged. So it's like code that you're writing that creates something that is going to work end to end and that you hope to use like as production code. You don't want to delete this code after you're done. If logging is important to you, you could definitely add that. I would see that as being like one of the layers that you're kind of trying to fire through as you're building. I hope that makes sense. If it doesn't, I'm happy to follow up.
Oh, well, it makes sense to me. I guess one of the questions, okay, so you're part of a team. They haven't read the book. It'd be really nice if we all had a book club, but let's say they didn't have a a book and you say like, I saw this talk. I mean, maybe I'm answering my own question, which is to send your talk to your team members. I was going to ask, how do you get buy-in from your teammates? Let's say, besides just like sending them your talk, like what are some other ways that you could convince people like this is a worthwhile investment? Because this is an addition, as far as I can tell, to the actual like some other things that you're trying to do.
Yeah, so the way that we got buy-in, I think, for the proof of concept or the idea of building a model was very business focused. So we think that building this thing could do X for our business, like help us to scale onboarding, which is going to be very important if we're making a B2B play. The thing about the actual like firing tracer bullets that was really helpful for us is just understanding like we didn't know if building the model would even work. Like, could a classifier even classify this text? So we were very honest about not knowing whether that would work, and also proposing this approach as something that could get us that information and show them the tool and show progress along the way very quickly without us having to take the risk of fully building out an entirely like full featured system.
Okay, that makes all the sense in the world. Thank you for answering all these questions. I'm sure there are going to be more in the chat, but I do know that we have some transitions to do. We have a speaker coming up soon. But before we do that, it's time probably to thank another sponsor. So again, thank you again for your presentation. Before I bring up the sponsor, is there anything else that you would like to say to the viewers who are watching the conference?
Just a giant thank you to Vicky and all of the organizers who have been doing a killer job and working really hard behind the scenes to make everything so smooth and so great. I'm really happy to be a part of this.
Awesome. Okay, thank you so much. Well, you're going to be co-emceeing me with me, so great transition. Here, I'm just going to transition to thank our other sponsor while we have an opportunity to do so before our next speaker and before my keyboard activates. Okay, so yes, we want to thank Orchist. Well, you all know who who's coming up next, so maybe that's not such a bad thing. But Orchist, thank you very much for sponsoring NormConf, and Orchist has a booth in the Slack. So if you want to chat with them and learn about what they're offering as the ETL pipelines, we really appreciate their support. They've been with us throughout this conference planning, and yeah, thank you very much. Before we transfer to our next speaker, we have some time to burn. So like, I don't know, I can't find, there's no, my hands are tied. I think I've got to bring in ChatGPT. Like my hands are tied.
Okay, let's do it.
So when we last left off ChatGPT, we had so much more content about the sexiest job of the 21st century. So I'm just going to read off a next example of in the preceding 5 centuries, what the sexiest jobs are going to be according to ChatGPT.
Okay, great.
All right, so the sexiest job of the 24th century will be the Mars terraformer, working tirelessly to transform the harsh Martian environment into a livable one for humanity. That one, I believe there was a book on that, but it didn't end. It was a sci-fi book, and it didn't end well for anyone involved, really. So that one, I'll move on from that one.
It doesn't sound fun.
No, and like they were working in mines
and so much manual work. Yeah,
I wouldn't like it. No. Okay, well, too bad I won't be there. So the sexiest job of the 25th century will be the zombie hunter, braving the undead hordes to protect the remaining survivors of the zombie apocalypse. What I like about this one is that like it's actually kind of an optimistic prediction, because it's saying that for like a few centuries we won't have a zombie apocalypse. You know what I mean?
I guess it's a very glass half full reading. Yeah, I'm a little nervous that there is definitely going to be a zombie apocalypse. Like there's not much we can do to prepare. I guess just continue to pass the word on to future generations.
And that's the benefit of ChatGPT. If there's one thing you've learned today, people, it's that. But while I pull in the next transition slides, Caitlin, do you want to introduce our next speaker?
I do, yeah.
Okay.
So our next speaker is Sean Taylor. Sean is the chief scientist, at Motif Analytics. I heard that he is also a prophet, or wrote prophet. And Sean's tagline is "A foolish consistency is the hobgoblin of little minds." I'm interested in learning more about that as he tells us more about when not to use SQL. Welcome, Sean.
Thanks for the great intro, Caitlin. And thanks to the organizers for a really well-run conference. And I'm really excited to be here. And thanks for letting me talk about some crazy stuff. All right, let me get my slides up here. I also want to thank them for these beautiful slide templates. I've never had slides that look this nice in my whole life, so appreciate that. So as Caitlin said, I'm the chief scientist at Motif Analytics. And I'm going to tell a story about something that we've been working on, and basically my ex post rationalization for why what we did made sense. And I hope it sort of portrays a lesson that I've learned, and that actually what we're doing does make sense, but maybe it doesn't, and maybe I'm just making up some excuses. So this is a David Byrne quote that I've adapted. I joined Motif in July. We started working on sequence analytics, and I found myself at this beautiful startup with all these smart people, and we wrote a query language. And that's what we've been working on for the last few months. And I'm not ready to show it to you today. And this isn't going to be a Motif commercial as much as I would love to do that. But it is a little bit questionable. Should you write a query language? And everyone loves SQL. And I know a lot of people don't like new query languages. This is somebody that I really respect a lot, Eric Bernardson, saying, I don't really like software that invents its own query language. And we would joke at the company that maybe our product is dead on arrival because no one's going to want to learn a new thing. And smart kids say no to DSLs, which is I just love this graphic that he included. And once you decide to go down this road, every time you make a bad choice, it becomes harder to make a good one. And so you can end up in a bad state if you make a bad choice at the very beginning of your project. And so new query language may be a terrible idea. I'm going to try to justify to you why we might need that, and then why you also might need to be thinking about different kinds of query languages. So here's the setup for Motif, and I'm not going to belabor it too much, but roughly we think about user behavior on a website or an app as a sequence of events that occur that have a user ID, a timestamp, an event name, possibly some other metadata. And the kinds of questions that we like to ask are what happens after a user does something, what happens before something happens to a user, and then what happens between. These are what we call sequential questions. They have a certain flavor to them. And so we could lay this out left to right on a timeline and say okay, this is a kind of golden path for a user of a video streaming service. So they started a search page, they see some search results, they click on that, they preview a video, start watching, and finish watching. And a very natural set of questions to ask are things like, how many users make it through this process? Are they getting stuck at various times? And where do they get stuck? And where do they kind of stop using your site? Do they take detours into doing something else that isn't on this happy path? And does it depend on things that happen earlier in the sequence in various ways, say maybe what device they're using or what kind of connection that they're on? And is it something that we could possibly fix? And so this is a space of questions that's really rich and important for people. And I think we all are kind of interested in answering questions like these in our jobs often. One person in particular, Tej Murphy, who's a friend, and he gave me permission to share some of his slides from his Snowflake talk, spent a long time thinking about this and working on it. So he has this talk, Funnel Analysis in SQL from Start to Finish. And I didn't actually get to see the talk in person, so I can't claim it was a great talk. I'm sure it was. But the slides are great and they're very informative. And he basically spent a long time prototyping 3 ideas, and then there's a 4th one that I won't include because it's inconvenient for my point. But he's got 3 approaches to solving this problem using SQL. And so the idea is we want to count how many users make it from A to B to C to D, possibly with time gaps in between that we want to constrain, and that we want to kind of figure out how to analyze this funnel. And there's three approaches to it. There's a join approach, a window function approach, and a regular expressions approach. And they have different characteristics, like max K is one of them, which is like, this is how many steps that you're actually capable of counting in a reasonable amount of time. And so we can see for join, it's like a small number. Then there's performance, which is like how much data we're able to process. And then very importantly, there's this column on ease of use, and Teach very conveniently has this star rating system. I don't know if it's like out of 5 stars or out of 3. And perhaps he said this in the talk, but this is kind of roughly what we think about a lot as analysts, is like, how do we solve a problem in SQL? And then what kind of characteristics will that solution have? So we can think about like, what are we trying to do when we do sequence analytics in SQL, and why might this be a little bit challenging to think about how to do? Well, the left join approach is like taking a table and doing joins onto the same table. And you could even do like a recursive join if you wanted to, and create like a bunch of columns for all the different sequence elements. And this is what Edgar Codd, the inventor of the relational model, would want you to do, because he doesn't want you to add window functions or denormalize your data in any way. But this is very not performant, because you have to do joins, and for some reason databases are bad at doing many joins, despite that's what they're designed for. You could also use window functions. So the predicate now would, instead of being across columns like in these purple boxes, it would be across rows. And this is really kind of getting at the heart of what we're trying to do here, is like apply conditions or predicates that span multiple rows in the data or multiple relations. And so we partition, order the data, and then we can do this window function approach. Or we could denormalize the data and create a special column that has an aggregate type. And then that aggregate type, we could write like UDFs or something like that to apply to that. And in Teach's approach, it's like, oh, we'll just use regular expressions. We'll construct strings and use regular expressions. And that's another kind of like way that we might think about solving this problem. At the end of his approach, he sort of like, motivates these things plus a fourth approach. And then several months later, I saw him tweet this last night. This is like, shows how late I was working on my slides. I never want to write a funnel in SQL ever again. So this is the person that I know who spent the most time working on funnels in SQL. Maybe it's because he spent so much time on it, but he knows the most about how to do it and how it could be done. And he doesn't think it's particularly fun to do or usable. So I think they want to get to the point here of like, just because something is possible to do in a query language or in any language for that matter, it doesn't mean that it's likely that people will do it. And this is an important point. It's just not about like whether something is capable of doing something. It's about whether a user would practically do something. And we have Teach Murphy, the expert on funnel analysis, telling us that he never wants to do it again. It's a bad sign for whether people will be doing funnel analysis in their jobs. And I want to make the point that it's not the relational model that's the problem here. It's a fully expressive model. I mean, like, Edgar Codd is right. Like, relational model can solve this problem. And the events are perfectly well represented as a relation. So it's very reasonable to think about like, why should SQL not be capable of doing this very easily? And like, what should we be doing instead? And another important point to make here is that this is an analysis we're not going to probably write one time. There's this illusion that like, oh, we write this query and walk away from it. But actually, we all know that when we write a query that we end up tweaking it and making changes, and that the funnel might change or be more complicated than we first acknowledged, and that this is an iterative process. And so we're going to need to solve this in maybe a different way. And I want to be open-minded about that. And that's where that foolish consistency is the hobgoblin of little minds. So like, this is the only tool I'm allowed to use, is the one that I already have, is a little bit of a foolish consistency. So we have 3 possible things that we really boxes that we want to tick. We want to have completeness, which means like any possible funnel question could be answered. And it might be possible that some things are not possible in SQL. I don't want to make that claim because I know someone will immediately rebut it. So I'm not going to say that there's a thing that you can't do in SQL, or unless I want somebody to actually solve that problem. But I do think that expressiveness is a really important criterion here. It's like, even if it were possible to do an analysis, do I need an expert to do it? Could I do it in a reasonable amount of time? And then there's this like efficiency question, which Teach is very concerned with, is like, could it be done quickly or at all on the large amount of data that we might have? So we want to kind of like tick these 3 boxes if we can. So let's think like abstractly about what are we really trying to do when we design this procedure. It's like we have input data, and then our job is to fill this hole, the dashed line here, and create some output data that is the answer to our question. So I break this down into 3 phases. There's this expressing phase, where I go from intention to query syntax, and you can see all the joins that I have to do to get it to work. And then the database system will execute that query, produce a result, and then I will look at the feedback and like verify that it is complete. And so you can see like all three steps together, we get a core loop for an analyst who's working through a problem. I have an intention. It's like, this is what I want. This is the question that I'm answering. I want to answer. I have my human time that I spend getting to syntax. I have machine time getting from syntax to result. And then I have human time sort of spending time on the result and verifying that it's the right thing that I want. And getting through this loop quickly is really the name of the game for analytics productivity. And if we could do this quickly, then we could solve a lot of problems. A lot of people will say, hey, the machine time actually does matter. And I think that often we're just playing in different areas of this two-dimensional space of how often we spend writing new queries versus how often we spend executing new queries. And I think a lot of people will think about, like the query needs to be efficient, so it must be written in SQL. Well, that's people who want to work in the upper left-hand quadrant where they want a mature data pipeline where it's very repeatable and reliable. I'm very interested in this bottom right-hand quadrant where we're interactively working with data and reframing our questions on a regular basis in order to get the answer that we really want and verify that it's correct. And there might be two paths up into this like holy grail top quadrant where you're doing a lot of interactive work and also very fast on the machine time. And I think it's plausible that we'd start from interactive analytics and figure out how to scale something from there rather than start with a really mature thing that answers one question well and expand the scope of it, say using like something like templates. All right, so I got a little recap where like there's the pro SQL side. I'm not even going to make the argument because everyone's already made it online and told me not to even give this talk. SQL is great, it's fast and scalable. The data I have are already easily queryable, and of course, everyone can already read and fix my SQL queries, which like I don't think that's actually true. You can see it's an anti-SQL point too. And also, people have figured out how to analyze funnels in SQL, so it's not it's not impossible. But it's an awkward fit, and human time is important. And key to my point here is that if it takes a long time, we might not ever even do it. And there'll be questions that are left unanswered that are important for our business. And so just because something can be solved in SQL doesn't mean it's important to our business. And some things that are hard to solve in SQL might actually be very difficult. It might actually be very important for what we need to learn. Okay, so next phase of the talk is how to not use SQL. And actually, I changed the name of this slide at the last minute to how to use not SQL, because I don't think it's about replacing SQL whole hog. I don't really ever want to claim that I'm going to invent a new query language that's better than SQL in all ways. There's no free lunch. But we need to think about building systems that are complementary to the expressive power of SQL in other ways, and that it will be a thing that extends our superpowers and gives us like ability to answer new questions, but can compose well with the SQL queries that we're already writing. So here's my rough diagram of an analytics data, like a whole data org end to end, from the raw data all the way to the things that users really care about. And I know a lot of people online will probably quibble about all the boxes and arrows here, but just all models are wrong. This one serves my purpose. And okay, so we got the stuff on the very far right. This is the impact that we're having from the data. And then we have the raw data all the way on the left. And any analysis that we do, anything that builds value is a path along this graph in some ways, including possibly loops where we do something more than once. So we could think about different roles here. Like here's an ML engineer who queries relational data with Python and then trains a model and then serves the model. And the model, drives impact by powering some beautiful new feature. We got the business analyst who queries the relational data that's already been turned into an OLAP cube with a BI tool, creates a plot, and convinces the CEO that they're going to do a bad course of action. Or the data engineer who is thinking about how are we going to extract and load the raw data and get it into relational data, and how are we going to, run the pipelines, which are a batch of SQL queries that we're going to run on the relational data and continue to write new relational data into the relational data store. So everyone sort of has a place in this graph, and it's usually like a path through it that you are responsible for and that you think about. But the heart of the graph is the relational data. It's like, this is the heart of our organization. And I used to study social networks. We call this a position of brokerage in social networks. It means that to solve any problem, to communicate between any two nodes in this graph, it's very likely that you're going to have to go through the relational data. And so this is an important kind of like design consideration when you're building a new thing. It's like, if it doesn't read from and write to relational data, then it might be dead on arrival, like the query language that we built. So this is the inner loop, is a set of functions that we're going to run that consume relational data and emit relational data. And typically this is done with SQL or with Python and R in my experience, maybe less often. SQL is the most common case. Python and R can do this too. You can read from it, there's lots of connectors for databases, and then you can write back to the database, very common pattern at both of the companies that I work for, Lyft and Facebook. And one way that I like to think about this is that there's this abstract space of relational data, and each of these operations that we're doing is like a path that we're creating between 2 points, where the starting point is what the data that we have, and the end point is the data that we'd like to have, which is like the answer to the question. And so by looping through this loop many, many times, we construct a path that gets us to the data that we want. So a chain of these operations is a solution to the problem that we're trying to solve when we're doing an analytics task. So how can we add a new functionality? How can we be more expressive than SQL? Well, we need to remove the SQL node and replace it with something else. And so here are 3 broad strategies that I've seen in practice for doing this. And so the first one is kind of like the one that I already talked about, which is like taking the data, putting it in R or Python, working with it in pandas or dplyr, which know how to deal with relational data and can then emit relational data. So this sort of substitutes out a SQL execution environment for something else, but it still conforms to the interface that we care about. Then there's this new breed of thing that I'm seeing, which is to transpile a language into SQL. So Malloy does this and Prequel does this, which is take a query that is easier to write in some language and make it into a SQL query that could be a big, ginormous, thing that we're really worried about whether it's going to work, but it will because it's a transpiler and it can guarantee correctness. This is also an attractive strategy because you can add this expressivity, but get all the benefits of using SQL under the hood and using the same execution environment. And then what I'm going to talk about is actually this convert it into a new space and then operate it within the new space and then convert it back into relational data. So we need 2 things. Is the box is a noun. It's a useful representation for the data that's not relational data. A converter to and from that thing, and then some expressive set of operations that work within that space. So here's my topological analysis of this, is that we have relational data space on the left-hand side, and we have some alternative representation. And so this is how we do this, is we have a round trip that we're going to take. There's this difficult or expensive transformation that we'd like to make in space X, but that we can actually do in space Y under some sort of operations that we actually understand and are debuggable and are easy to express. And then we're going to round trip it back using the converter. So does this sound like a crazy idea? Actually, I think I've seen this play out in practice in kind of informal ways. And there's at least 4 different kinds of intermediate representations that I think make sense here. One is graphs. Graphs are sort of very hard to query in SQL, especially along paths. But if you convert something to a graph, it's very easy to think about how to solve graph query problems in some other way, say with a language like Cypher. And then you could convert a graph back to SQL quite easily because they're very easy to map back and forth. I've seen people use embeddings, where you take individual rows or items within a SQL table and convert them into vector representation, and then work with vectors. And then we could generalize vectors into some kind of tensor, and work with tensors. And tensor operations are very easy to do on say GPUs or in some area where you have better ability to execute the computation in a more efficient way. And tensors are very easy to map back and forth into a relational model. And then finally, you have the heart and soul of Motif is moving it into a sequence representation, operating on sequences directly, and then moving sequences back into the relational model when they need to be analyzed in a different way. And if this all sounds really crazy to you, I want to just call out almost everybody who's watching this talk has done this mapping at some point in their lives. They have exported a CSV file from a database, worked with it in Excel, and uploaded it back into the database. You're using the design pattern that I'm proposing if you've done this. And I bet if there were a real audience here and you could all raise your hands, a lot of people would be raising them right now. This is the OG way of mapping something into a space where it's more malleable, the operations are easier to think about, and that you can be more productive. And think about what is the problem with this workflow? It's not Excel. It's that exporting CSVs and importing CSVs is a lossy converter. And if you had lossless conversion, that actually this design pattern would be much more resilient than it really is in practice. I have 1 minute to wrap up. I just want to make the claim here. I love SQL. I'm not trying to tell you not to use it. I'm just saying that sometimes you maybe consider not using it when things are hard to do in SQL. And it comes from this kind of willingness to admit that you're going to iterate on solving a problem. I don't think that we write queries one time. They're usually like a malleable artifact that we're trying to nudge into the right state, and that we iterate as our business changes. And so expressive code and things that are able to express operations in a succinct way are very valuable, both for writing and for reading and understanding and reasoning about your system behavior. And so this expressiveness really matters. And choosing a good representation will actually make expressing the problem that you want to solve, the solution to the problem that you want to solve, a lot easier. And the way to integrate it with the way that we currently work is to think really hard about the interfaces. Don't reinvent nouns, reinvent verbs. And you can add one new noun if you want, but then at that point you need to think only about verbs. And this has been a very productive way for me to think about the problem. And I've seen this design pattern in other places, like say in the tidyverse, where the type of data frame that we use has expanded in scope over time. So I just want to kind of like encourage everybody to be a polyglot and think about new verbs. They can change the way you think about problems, and you might find that it's more productive, and that you can still use SQL. It's always going to be there. All right, thanks everybody.
Thank you, Sean. That was so great. And thank you for being so giving with your time. Unfortunately, we don't have time for questions just yet because we are taking a transition coffee break right now. So I'm going to share my screen right here, just so everyone knows that we are taking an official coffee break for what is a surprise that no one knows about. So you should see my screen. There's going to be a new link. The new link is right here. You can find it on the NormConf site. Sean, there are a bunch of questions for you, I'm sure, in the Slack. So if you'd be so willing to engage with people who are very curious about your talk, it was great. Everyone else who is watching, please take your coffee break, but don't go too far from your computers, because around 2, we will be having a surprise on the next session. Caitlin, do you have any closing remarks on your end?
I don't. Thank you so much, Sean. That was a great talk.
Thank you. Thanks for having me.
Thank you, Sean. Everyone else, I will stay online, but only to tell you to go to the other link. Hopefully some of you are logging in there already, and we should be seeing you very shortly for the next session and the surprise showing. So thank you very much.